So, hello everyone. Good morning, good afternoon, good evening, wherever you are. So, welcome to the second edition of the Regenerative Design in Digital Practice crash course. The focus this time, 3 years after the first edition, is about ecology, carbon and health, and what are the tools, the digital tools to address this important phenomena. A few instructions before we start, before we dive into the event. So as you're noticing, the event is being recorded. Your microphone is muted, and if you have any questions, please use the Q&A box. We will address them possibly during the event, live or directly in the Q&A box, depending on the type of questions. Apologies if you're not able to address all of them. In this case, we will follow up with an email after the event and providing answers to your questions. So we will do our best absolutely to address all of them. And if you have any other questions regarding the event afterwards, please write to info@living-future.eu. We will be happy to address your inquiries. We will not present extensively the speakers and the program, just for the sake of time, let's say. Please go visit the registration page, the landing page of the event, to look at the detailed program and to look at the bios of our fantastic speakers. Obviously, we will introduce them briefly, but for the full bio, please go to the registration page. So I'm taking the opportunity absolutely to thanks all of the speakers and also to introduce myself and also the other co-hosts. I'm Carlo Battisti, Future Europe President. Living Future Europe is, as you know, a non-profit organization really trying to advance the culture of regenerative design across Europe. And I'm absolutely very happy to be in this call, in this event with distinguished Professor Emanuele Naboni, co-host, co-organizer, and co-creator of this concept. Hi, Emanuele. Your microphone.
Hello, everyone.
Hi,
thanks, Carlo.
And I'm also taking the opportunity to thank Christine Contos, our regenerative impact manager. She tirelessly worked on organizing this event and will be our co-host in the background. And again, thanks to all of the fantastic speakers that we have today. Again, we will introduce them during the event. It looks like there is big interest in the topic. We had more than 4,000 unique visitors and more than 8,000 views on our registration page. And as you see, there is a very good presence from the United States, from other parts of Europe and on the world, Oceania, Asia, and so forth and so on. So absolutely, so there is very great interest regarding regenerative design and how to implement tools for addressing regenerative design in real practice. As you notice, these are the countries that have the greatest number of registrants to this event. We have more than 130, around 140 registrants, mostly from the United States, Italy, United Kingdom, Spain, Belgium, Denmark, Germany, and so forth and so on. But before we dive into the contents of the event, we would like to launch a first poll to you guys to understand how do you use environmental performance today in your practice. So, Christine, if you can please launch the poll so that we can address this question live.
Yes, it's been launched.
Okay. Thank you. Yeah, how do you use environmental performance today? So we provided a few different options. Christine, I'm not able to read them for in the moment, but I think everyone can read them.
Yes, we have a lot of the participants are responding at the moment. We have about 50 responses so far.
Okay. Yeah, maybe we can wait a few seconds. So are you considering environmental performance in your project? Are you at the beginning, or are you really using an environmental angle and topics really to drive your design? to guide your design, or is it really a strategic theme and topic that you are considering when you are working on designing and constructing your buildings? Yeah, we can see the first results. So I would say there is absolutely 50% of the participants using environmental performance as a decision filter, meaning that I'm reading this like, okay, we are considering sustainability, we are considering environmental performance in our projects as a sort of metrics that we are applying, let's say, to our project to look if they are if the projects are consistent, and also a very good percentage that are using environmental performance as a driver of form. Emanuele, what do you think on this? Any comments?
It's a very interesting result. And I would say that we will probably focus on all of this point, but primarily we will focus on form and as a generator of form. So perhaps this is a gap that we can already see by this survey and that we will try to address.
Okay, good. Okay, so thanks for your responses. But first of all, just really to introduce the context, why are we speaking about regenerative design? So this could be maybe the first question. I know that could seem trivial, but in the end, we are there. So we are basically, you know, this is Jan Rockstrom previously at the Stockholm Resilience Center. So this is the trajectory we are moving on, let's say. More in general, let's say, at the global level, we exceeded most of the planetary boundaries, as we know. And the point is that our built environment is really dramatically impacting on the ecological crisis. You know that buildings account for 40% of final energy consumption, 30% when it comes to energy-related greenhouse gases emissions. There is a lot of energy inefficiency still, I would say, in the 75–80% of the buildings globally. Not to mention construction and demolition waste representing 1/3 of the total waste generated, and so forth and so on. So this is the point, and this is why we have this big challenge, but also a big opportunity to address this topic through the built environment in a absolutely much more effective way. And this is basically what we are working on. So trying to move the conversation and the practice from doing less bad to doing more good, really moving from reducing impact to adopting, let's say, a positive impact and approach on the built environment. So passing through a sustainability level, but then becoming a restorative and then regenerative. So really creating the conditions for the ecosystems to thrive, and the built environment can be really an important player in this regard. Introducing regenerative design, what's your current take on regenerative design? This is another poll that we would like to launch, understanding what is basically your current adoption or understanding or implementation, let's say, of regenerative design in your organization. So we have another poll for this, and again, we are absolutely looking forward to see your feedback and responses on this. Christine, if you can launch the poll, please.
I'm just going to give everybody another minute to respond.
So is it a new concept? Is something you are using and adopting and maybe in some pilot projects? Are you like dedicating a part of your business in exploring how to implement this more advanced, let's say, approach for sustainability in the built environment? Is it anything that you're already considering really to adopt in the majority of your projects? What's your position on this for the moment? I would say a good 1/3. You are talking about it, so I think this is absolutely promising. But I would add another 27%. So in total, I would say 2/3, or let's say 60% of you you are started talking and experimenting, but also another promising 21% applying selective projects. So in the end, maybe I can say that the vast majority of you is talking about it and started implementing and doing something. So, and absolutely, this is encouraging feedback. Probably you are taking part in this event because you are already, let's say, familiar with the concept. Emanuele, any comments on this?
No, it would be very interesting to collect loosely the definition of regenerative design that everyone gives, because it is intended in so many ways as well. In literature, we have a stream towards radical ecology. Some other, it's more about the process of systemic integration of values. Some other see it as a positive outcomes on several axes. So I guess along the course we will shape also more definitions. Yeah, very interesting results.
Yeah, no, thank you, Emanuele. So you are in the right place. So this event is exactly for you. This crash course is for you. And what will you learn, let's say, in this event? What are we dealing about the whole day, this long day, with a number of very interesting examples? I'm passing over to you, Emanuele, to introduce.
Sure. So in this day, we have tried to collect speakers, outstanding speaker, that are giving a contribution to some of these fields. Obviously, a common denominator is that each is making an innovation when it comes to computing methods. Next. And so the first pillar, of those that are directly, in this case, the Norman Foster team, as well as MVRDV, Sanne, are contributing to tools that are shared with the community, and tools that contribute to carbon balance within the perimeter of a project. Next. And then we have the pleasure, we have some iteration like the one of Oscar, because the development fits in multiple categories. And there is a certain emphasis today, obviously, in what has been the topic of climate change, but also how to address microclimatic solution, especially with the integration of the built as well as of natural form within it. So we will have Ata, Tore, Oscar, and Wojciech. Next, please. And one expanding topic, and I guess all of us in some form is trying to understand how to approach it, is the one of biodiversity, how to curate living system, how to make them in a prosperity state. And computationally, there is a gap. Verena and the team of Rhino here represented is trying to make major effort. As well, I'm working on it, so I will present a few outputs. So this, I think it will be one of the interesting pillars to explore. Next. And obviously, the creation of carbon as a value, how decarbonizing can be awarded. Sanne has developed quite an interesting tool. It's representative of others, of course, and also that doesn't apply only to the realm of the project, but also the organization that stand behind projects. And Paul from GRIMSHAW will tell us about. Next, please. And to conclude, it is also about methodology. It is about how to integrate measure, how to, let's say, measure. And Nitsan will talk about artificial intelligence, and Emily will follow on the topic. Next one, please. Okay, and this is the beautiful array. Worth to mention that when it comes to regenerative computing methods and innovation on the topic, Chris, Mustafa, as well as Jakob, within their practice, they have quite innovate the workflow. So that will be another stream.
Thank you, Emanuele. So I know you will expand now in the first session really about this difference between decoding or recoding. What does it mean in terms of the approach you are implementing and in your daily activity? So I'm passing over to you, Emanuele, so that you can keep on with your presentation, which is really, let's say, about how decoding and recoding regenerative design.
We have you muted, Emanuele.
So we see your slide, Emanuele, but we cannot hear you. I don't know if you're speaking.
Maybe Carlo, I can do the
Thanks.
No, okay, sorry.
Thanks so much. Sure. For the Murphy law, they're cutting the tree. I cut a tree with a jigsaw just right now, after 3 years of not activity. But okay. So the topic we wanted to tackle today is the one of understanding all the forces on the flow that interact with the project, and then trying to record them in a regenerative way. Just a few words about myself. I'm a practitioner with my own firm, and I collaborate with few universities in Spain, Denmark, Norway, another location. And as entity, I collaborate with the World Health Organization and with the IPCC panel for climate change. And this comes from past collaboration with YAC, ETH, PFL, and as a practitioner, I've been working for a while with Skidmore and Merrill, with William McDonough, author of Cradle to Cradle. And this context has given me the possibility to pass through certain epochs of what has been designed and intended as the mutation from sustainable design to regenerative approaches. Understanding that we are in a system that keeps degenerating, as if you can follow these red lines, and where we intend sustainability just as a slower of the process of degeneration. But we have the chance to create environments that are positive when it comes to ecology, that decarbonize and that makes health. And to do that, we may have to rely on different approaches, especially a systemic approach, and we need to understand all the ecological value. We understand how carbon moves, what it means to be salutogenic, for instance. And obviously, that cannot be solved with typical silo-site type of approaches. It's necessary to understand what are the cells that compose the topics, and then create tissue where this topic can be connected. And here comes the title of the presentation. When we talk about decode, it means to understand the structure of a system and trying to, let's say, reduce the harm. And this is typically developed in a vertical, according to vertical lines, as we are going to see in a moment. And we can also try to recode it, amplify the value that are existing in this type of grammar, and using one integrated shared playbook where tools are cooperative in order to create a dialogue between competencies. And the overall scope is to make the positive bigger. Now, I would like to show you my palette when I was working. This is my palette of 5 years ago, where I was tackling more or less some topic. Perhaps I had less interest into ecology back into the day. And we can see it's quite a silo-site type of approach using tools that are to some extent unable to exchange information, and where the ecological part, for instance, and the influence on others part is reduced. And this is the tool palette that I'm using today, where almost each of the script, and these are custom-made script, are able to cooperate with others. So there is an input that comes from another script, and then the output is passed to another. So when we talk to climate, it affects ecology, ecology affects health, health itself affects carbon, as it may affect the way we move. And mobility itself then return to affect climate change. So there are several recursive paths that it's true are happening globally, but when we take a site and we extend the boundary of it, each act of design has multiple type of iteration. And this is a process of recording in the sense that to be able to approach regenerative design, we need to understand and calibrate models according to existing flows, understanding the structure, understanding connection, implying that science is neat, climate science, implying that we are able to understand ecological system, carbon flow, and with an important understanding of what are the psychophysiological value involved. Some example. So when we talk about recording, I will talk more about the script that I have developed, and some can also be shared. Very few are on a GitHub, but we can have a talk about that. So, for instance, we oftentimes approach very long simulations. So I have created a script called MVFast, not to offend an existing tool, but allows in minutes to account for all the variables, including the ecological layer for comfort. And this allows also to see interesting phenomena like relative increase of temperature due to climate change. And what we notice in certain type of consultancy, for instance, this for Maranello, the city where actually Ferrari is in a consultancy for them and for the professional ceramic industry. So what we could see is that climate change hits much more the ecological layer, and this is all vegetation, as compared to the city center. So I developed another tool that allow in a very fast way to point on the canvas, let's say on a map, a few points, whether they are agricultural field, whether they are parks into the city and city center. And what we notice oftentimes is that higher temperature to the script are where vegetation is rather than in the center of the city. And this is because the scripts are able to account of when plants dry or die and are unable to perform climatically for the site. And this is another script, EPW pollution, I call it, and that allows to understand also the pollutants that are emitted as a consequence of traffic and vegetation. One thing that we notice is often undermined is that making vegetation is often a problem more than a resource, especially when it intersects with traffic. Traffic and vegetation together are responsible of the creation of a local O3. So this is it comes from conversation also with biology and specialists. What we could see is that NO2 produced by traffic and bioemission from plants when interact make park edges or mix park and traffic being creating O3, which is actually the primary element of that in summer into city along with temperature. So it's quite an interesting fact that with plant vegetation and if we see zones that are only trafficked, they are much less producing O3 locally. So the use of small script sometimes that are spatial and allows you collect make an interfere space and this type of APW data along with traffic intensity allow this type of conclusion. For the city of Gothenburg, we try to develop an instrument that allows to understand their possibility to carve existing vegetation, especially because many people tend to move outside of the city, asking for more space to be then transformed into built in residential. And this type of script, which are actually script purely accounting for forest benefit in terms of preservation of air quality, water services, biodiversity support, climate support. And interesting things of these spatial tools is that allows us to understand for different times from 2050 or 2000, or this is the actual condition, the work was done 2-3 years ago. And what we can see is that if they have a plan of carving 25%, by how much we carve the habitat that sustain biodiversity or value of carbon sequestration, and then the city, if it acts in that sense, have to compensate this type of value. And this is very interesting for each small project to accompany the carbon strategy or the air quality strategy or the climatic strategy with this type of data. But this is about the degeneration state. And let's try to understand how we can recode that through ecological method. So I'm involved in Riyadh with the new Murabba and the new Mukab. This is a 500 tall building, and these are 250 meter tall skyscraper. And since phase 1, the most important asset in this 40 square kilometer area in Riyadh has been the creation of a green infrastructure. And it's a very difficult site to build a green infrastructure. Managing 40 square kilometer with models is quite an enterprise to be made. And so the MVFast model I created was the only way to capitalize and gather value such as comfort in that case, importing also part from other tools. So other legacy tools are involved. Obviously, when it comes to CFD, imagine to have a high resolution CFD for 40 square kilometer is quite a thread. But the most important thing is how to go beyond these thermodynamics that are interesting, but as just underlying layer for many more values. Being the old strategy based on the wadis, which are the dry river, or as so-called, we try to decode how wadis are actually working in reality. So I map and collect and talk to scientists and understand deeply how natural wadi existing in the Saudi are actually functioning. Try to bring that into the model where a bioreceptivity of each of these elements and design is then tracked. I forgot the legend, I'm sorry, but we can see how any surface is a different color corresponding to bioreceptivity. And to model that, that is largely influenced, for instance, shape, because shade was obviously in radiation control was a parameter, self-shading among 3, selection of species. And for the here, this is a sort of annual biodiversity chart where every hour of the year is tracked so that this system, and when we tweak the design, data are keeping changing. So this allows to understand from pollinators to wild animals to vegetation, how their life can be extended. And in primary version, this sort of bar were quite contained, so that the livability for other species has been extended through this type of design. Another example, this in Milan for a student housing in Navigli area, where within the constraint of the project, the idea was to use 4 integrated exchanging continuously data script for biodiversity, absorption of CO2 by the natural system, typical or at least run, let's say, CO2 from energy and embodied calculation through a very fast script. But I would like to focus on how this chart has influenced all the other elements. So the script allows to understand by climate change how different species from mammals, birds, insects get out of their comfort zone. And we can see that most of the species in typical time of the year, they get out of that more consistently due to climate change. And we want to create health by having a life biodiversity layers and by reinstate certain time species within context. So to do that, I created a script that allows to, according to the form, making the texture of the facade, to understand how it is possible, for instance, this for vegetation, but this applies, there is also a slide for multiple species, how we can create and increase super green area where plants do not have any thermal stress and also photosynthetically activated into winter. And why this is the base? Because that sustain local agriculture, it sustain also CO2 absorption, because the further we have surfaces of that kind, the more we can have biogenic absorption of CO2. Each plant has a physiological index that is rapidly represented and imported into the model. Also, it is important to understand that there is a drought time, very high drought time. And with this small script, I work with the landscaper, try to understand, for instance, what species could have resist according to condition of water, radiation, and air temperature. These three values make the possibility, let's say 30 degree, 200 watt-hours square meter. This is a good condition for a plant. But over other condition, we end up into a situation where the plants dry and then it may die. That's why we have several dead plants into the city. And how do we cope with that? Well, first of all, we can reduce radiation. So in most of the design I participate, plants are shaded. So plants do not shade purely the context and create a performance. We need to shade plants. That's what we find in several type of location. When it comes to carbon, and this it's and I see Kevin here, but probably is also participating into this recording. But and this is a carbon tool for the whole city. So we pass to the second topic, the one of carbon, where the topic is to understand that the city has several flows that needs to be mapped, and we cannot just rely, as often happens in construction, perhaps mobility, embodied energy. A district has many more flow. And so these tools allows for different type of design and with a few input about how people moves, the type of waste, how energy is made, amount of green, type of greenery, presence of water. Water is big absorber, of course. So it's possible today, just by design, by massive materiality operation, to get to a city that is carbon negative. These are different scenarios. With an example of in-class exercise on some of my courses, where students have to get to this point making decision. And another tool instead related to the embodied carbon, where and it's much simpler than one-click LCA and so on, is for the early phase, but it allows to make quick decision and see how your building fits within this bar. Why I like this bar? Because we can see the average European emission to build in Europe. We can see also how in vernacular time or before plastic enter into the system, we have much lower type of consumption. So at the end of the design of this tool, one chart is given to the client is then where your project locates according to current development. And through design, I can see that now most of the projects I collaborate are around 250 or 300. It's very rare to go down here, let's say. And starting from, let's say, the early consultancy work, I was doing at SOM when we worked to the Burj Khalifa, which is very impacting per square meter, to some more recent. We could see how the value are probably now around this. Of course, there is very interesting development in biomateriality that allows something less, but there are other parts of the building always I notice that compensate and keep the number a little bit higher. And last point of the talk in this last couple of minutes, it's about carbon and comfort. And I would like to share some key concepts. First one is that we need thermal heterogeneity. We don't need environments that are at the same temperature all the time, and our body and our physiology benefits when in time and in space we are exposed to different type of temperature. The second concept is that we don't need buildings to be acclimatized to the wall, and comfort band can be much more expanded. The third one is that when we are able to have thermal heterogeneity within space, and when we have larger comfort zone, we can really save carbon. The fourth concept is that just by design and through modeling, this is, for instance, genetic studies for different climate, but the same genetic study can be, I actually perform for any type of project, is that just by design, we can achieve 70 to 80% carbon saving just by design. And traditional building norm compliance, LEED compliance, BRIN compliance, save at the maximum 35%. So with digital tools and with pondering a large population of solution, we can get in almost every project up to 80% just by design, excluding renewables. The last point is that when we talk about building design, we can reach carbon negativity only if we are able to do this extra effort into carbon. Because I think when it comes to construction, we may get there, but operation, it's still something that isn't that studied much. And also what is never accounted is how living system, which to me are really like, the element, can decarbonize and make potentially every building be carbon negative. And just quick example of that, thermal heterogeneity for the consultancy for the Lavazza building in Turin, where each panel gives a different mean radiant temperature and occupants can choose where to stay. In Milan, a consultancy for this building, where the idea was just by design to follow thermal heterogeneity, where there are unconditioned space and people can move from zone to zone according to their preferences, and where vegetation offset some of the carbon, where there is a vegetation as a cooling system, but where air passes through and stream, and this is one of the few, if not the only, super elevated building in Milan. This is a consultancy for Cucinella architects, and where also there are these blocks that are blacks that are activated in winter in order to have an use of the outside. And this strategy came by this small script, which is the Delta Climate Change Delta Strategy, that tell us just by simple EPW what strategy should be pursued into the future according to the efficiency that has today. For instance, the box we have seen before is because we could see that capture internal heat has a certain coherency today, but with climate change we'll have even more coherency for that type of project, as well as passive solar was less interesting. So there is somehow an understanding of how climate change, but also design will change accordingly. And the concept of thermal heterogeneity has been perhaps in a more generative way developed for this tower in Milan, where actually thermal heterogeneity is given by a facade that converge heat in different ways by reflecting direct heat into the interior in winter, and then a facade that has different modules with different insulation, and then a pavement with different coloring and type of finishes. So each color corresponds to a different insulation, as well as the ground to a different materiality. And why? So the concept thermal heterogeneity before was actually done with some script where we can see for the different floors and the different facade, the possible difference in temperature of the inner walls, as well as the pavement tiles difference in temperature. In spring, here we have up to 10 degrees. This in order to extend the usability of the exterior, and this for creating this thermal asymmetry within the interior that then is supposed, according to science, to give this positive heterogeneity. But to conclude, an interesting tool still is intuition, obviously. I'm working with the Italian train station in order to design all station for 2050 in being them carbon negative if possible. And in this case, the tools were very useful after having understood how this is a train station for Rome Airport, understanding how the planes, for instance, land in one lane or the other depending on the wind. And we use that forces in order to design the building almost like a Formula One car, where the CFD tool has granted the shape and the inlet. The carbon negativity will be fully achieved in that case by letting the building be at whatever type of temperature, assuming that it's not necessary to control, like today, stationary design, the temperature within it, especially in certain closed area, but to let it be and use a ventilation without any use of carbon. So there is not even mechanical movement of openings, and there is a much wider condition. This leads to potentially to carbon negative, especially because there is in plan a huge amount of vegetation to be included into the area. And in conclusion, so I've developed this palette with several tools. They are integrated, they are customized. The idea is to make them public and have them in GitHub, at least the skeleton of them. And if I would have referred to my palette of 5 years ago, which I see some practice keep using, where we have one tool for microclimate, one tool for LCA, one tool for let's say daylighting and energy, and you know the names, we could see that when we look at covering the topics, ecology is totally underrepresented, biodiversity is totally misrepresented. Carbon is accounted only in certain parts, as well as when we talk about health and comfort, it's scattered here and there, and interoperability is quite undeveloped. With this palette, if we follow the line of, let's say, regenerative performance are in between and are connecting the different domains. So there are this blending in between the core topics and this interrelation. But as you can see, in that case, I try for each project to represent by having the topics aligned, as well as what is important is that all of these tools cannot be reliable if we don't have input that come from other scripts that interpret the raw data that are available through EPW, through the urban structure, through the basic tools. So basic tools like Ladybug, Honeybee, other are for me just the basic layer in order to extrapolate information to be used today. And another problem is that some of them are quite lengthy, so it is necessary in that case to prepare your own tools, especially when you deal with the complexity. And the last two scripts show the benefit of this. These are economical and performance type of script. And there is one about regenerative design, but I try to apply to most projects, where I can see how the implementation of strategies has a benefit in climate, biodiversity index, CO2, and psychological. And this is, for instance, as a when we talk about psychological, we always model access to nature, circadian rhythm, and where thermal is just one of the part of this type of indexes. And when we come to the economy, we can see that a sustainable project has probably a meeting point around 30 economical point about 30 years after the making, but it's probably possible to be regenerative and have much more mature. So thanks so much. I hope we're in touch.
Thank you, Emanuele.
Yeah.
There are a few questions in the Q&A box. Unfortunately, we don't have time to reply to them live. I promise to reply to only a few of them. Maybe you can reply directly in the box, but I promise to reply to a few of them. Really quickly, if you have just a really flash answer, sorry. What's the measure unit for bioreceptivity analysis that you used? The measure unit, really one.
Sure.
Reply.
So basically, it's made by categories. So it is when a species can prosper within a surface, which means that radiation, temperature, water, airflow create an environment that allows certain species to be there. Yeah.
Okay, thank you. And another question, how long does it take to run a complete script? Meaning for, let's say, 10 stories residential building. So this is a very practical question.
Sure, it depends obviously on the type of simulation. So from those that are dynamic, we try to simplify the dynamicity and we can shorten the period. And that can be a few hours simulation from, but most of the script are minutes of computation.
Okay, maybe the last one, what do you use for doing the benchmarking for embodied carbon? So are they, because one of the participants said that she's struggling in finding consistent databases. So how do you do this benchmarking?
Sure, I did a literature review of European and international limits for what it is a benchmark, and then European Community reports about consumption for CO2. I have a literature review, maybe I can share with this person later. Yeah.
Perfect. Thank you. Emanuele, thanks again. If you can stop sharing your screen, this would be amazing. And again, there are other questions to be addressed in the Q&A box. And it's absolutely a pleasure to introduce to you Henning Larsen's Director for Innovation and Sustainability. I like so much that these two things are coming together. Jakob, Jakob Strømann-Andersen. Jakob, it's a pleasure to have you with us. How cities can really become leaders in regenerative design. So I know that Henning Larsen is doing a number of amazing things. So we are looking forward to hearing from you what's the state of the art on this.
Thank you, Carlo. And the sound is working okay?
Absolutely fine.
Absolutely fine. And first of all, thank you for the invitation, Carlo. I'm always happy to be able to have a dialogue around regenerative urban planning, but also innovation and computational design tools. I will just share my screen here, just a moment. But thank you all for the invitation, and I'm really happy to and I think it is a good compliment to what I put together here for Emanuele. Just a bit of background. As Carlo said, I'm heading our innovation and sustainability at Henning Larsen, and we see those two things very much go hand in hand. I have a background in engineering, been studying for 10 years at the Technical University in Denmark at DTU. So I have a right brain that is very much alike with Emanuele, that loves numbers and graphs and scripts. And then I have my left brain that I've been training being with Henning Larsen, the architectural studio, for around 15, 16 years. And I think that is super important that the numbers also need to have some kind of aesthetic and beauty and storytelling and narrative. I think that is also what I will try to explain or present today with a few projects, how we can combine computational design power with architecture and urban planning. And just a small disclaimer, none of my project today is regenerative at all, but they are having small aspect of it in the design. Short, Henning Larsen is at the Copenhagen design firm based out of Denmark, but we operate globally. We have studios in US and in Asia Pacific and around Scandinavia and Germany. We are around 650 architects, and we do a lot of different typologies, both in regard to cultural building, commercial building, and residential. You can see there's a lot of brown and green colors here. It's because we are, as Emanuele also was saying, that one of the levers for doing decarbonization is work with biogenic materials. So most of what we do at the moment is coming up in mass timber or CLT structures, and landscape is a big part of it. But we also do what we're going to talk about today, more big-scale urban planning, transformation, campus design. The center one is from the Harvard University in the US in Boston, where we do some facilities. The left-hand corner is also something that is like very close to my heart. This is a climate adaptation resiliency. Is the biggest wastewater treatment plant coming up in Denmark at the moment. Something that will be very smelly and outskirts of the city. Here is the heart of the city. And we promised the municipality that this will be the best picnic spot to go. So bringing those industrial facilities into the city, merge them in, creating a social value around them is important and something that are again close to our heart. But we do architect, landscape, and urbanism, and we see those very much weave together. When we do urban design, it's also about landscape and it's also about architecture. So when we're setting our teams together, both internally but also with our partners, it's across scale. And we have three topics that drive us. The first one is the center is design excellent. It's about long-lasting value. What we design is also having an aesthetic quality. And then it's about sustainability, and the right hand, the innovation, the research and data. And again, that is my right brain. I love data, but I also love when data makes sense and creates something that is meaningful. It's not should be this sake of having the data. Is it okay if I do it like this, Carlo?
Yeah, we still see your slider not in full screen mode, but that's fine. So we see
yeah, because
fine.
They will be running here. This is the world of Volvo in Gothenburg. I know, Carlo, you are from Italy, so you know the Ferrari world in Milan. This is the same in Gothenburg. It's an exhibition center, and it's have this warm color. Denmark and Scandinavia is gray at the moment. That's also why I'm sitting in a very dark room, not so much daylight. So we can use the timber to get some warm colors in. In Sweden, they have called the allemansrätt, is the right to nature. So everyone can go camping in nature. So that was also the dialogue with Volvo here. They own the land, but it opened up for the public. So you can go to the landscape and you go to the roofscape without buying a ticket. But again, coming back to the structure, it seems like very complex structure, but we work very integrated with it, with our computational design team. And the good thing about this one is that it's not working around a standardized workflow. It's a more what you call digital craftsmanship, having the understanding of how things are manufactured. So this was a very much close dialogue with the Austrian manufacturer of the glue lamp being VHAG in Austria, and then our design team, and we understood, or we had a dialogue with the manufacturer, what is the robot that's going to produce them, what is the span and dimension, and then we built into our scripting. So when we do design changes, we knew that it could be manufactured within the time schedule and within the budget that we have set up. And I think that is also what it's all about. Is like bringing data. It's not about end-to-end workflow. It's about understanding, scripting, setting it up so it makes sense doing the design process, and it's like a dialogue tool with the client. But coming back again from the data, this is on the right-hand side. This is Philip in Austria with VHAG. And Philip is our design lead. I have never seen one of our design lead hogging a beam, but that is something that timber can do. It can make you smile and can also make you kind of want to hog. I have never seen someone hogging a concrete beam as Philip.
Jakob, I'm sorry, you are at slide 7 still, is correct?
Okay. Sorry.
There has been a small dysynchronization. Yeah.
Okay. I don't know why it's not working. I put it into the full mode. I was just
Microsoft always.
I will try to do it like this and see if it works. I'm sorry about that.
No worries.
That was what I was saying about our computation design workflow. You can see here, this is Leonardo working with the script and the plugin for doing the structure and analysis with our, and this is Philip hugging the beam, as I said. Sorry. And please shout up if you're not showing the next project I will show is about how we use computation design tool in urban planning, and this is the Philippi project. It's a new development in the outskirts of Copenhagen. There's been a big debate of it. It's a kind of a greenfield, but it's also a landfield. So also what we promise here is to bring more quality of nature back, not more nature, but the quality of nature. We worked very much towards and bringing nature into the built environment. And also something that if you're moving to Philippi, you're not allowed to bring your cats. You can have your dog, but you cannot have a cat because they're chasing the small mice and the small birds. So it's also when you're gonna live with nature, you're also gonna be understanding that you're not gonna your daily life need to adapt to it. And you can see here, this is like some of you maybe being in Copenhagen. This is an image of Christiania. So we want to create the same atmosphere of some low scale. And it was a combination of like a Copenhagen building block with a Copenhagen or a Danish small town scale. We create this new kind of block that is open towards the nature, but are more dense around the central plaza. And the whole thing was that is stepping down and creating that diversity in the built environment. It's a full timber structure, a full timber city. So everything is going to be built with timber structures. So that was also part of it. It seems very random, but it's also very well organized. And that was also part of the design workflow. We did a lot of generative optimization in regard to the density, the comfort, the wind, the daylight, accessibility to daylight. This is one of the sorry about that. This is Sophia. This is more. All the digital is not working, but the human is working here, so that I think that's fine. But this is Sophia working with the model, and we had some set up some scripts that could densify the area within the typologies, and it was about maximizing the view to nature, the comfort in the urban or the courtyards, and here you can see. Here you can see part of it is structured into those 3 neighborhoods here. It's also part of the planning and the design. And again, it seems like very randomly set up, but it's also very well structured. Everything is prefabbed in timber elements and is shipped to the site. So that was also part of the optimization process and the digital journey, that we need to have the variety in structure, but it also needs to be very rational. So it could be built and it could be manufactured and brought on site. And some of this is even built out of straw component. But the whole computation design workflow kind of optimized that almost 25% have access to green, 30% have access of view to the park and have balconies. So this is part of the design. Another project I want to show is not so green. Is in the US. It was a development project from a big developer called Tishman Speyer. And what we got here was as a design brief that was very much like maybe a lot of you work in the industry, that this is the requirement, the setback rules, the height, the density, and that is what you're going to work towards. And then what we designed here was like a computation design workflow, a generative design workflow, where we did a lot of iterations based on the rules, the geometries, the impact, or the input parameters, and then we optimize towards the comfort in the urban spaces. And again, this doesn't come up with a solution, but it's a dialogue tool for taking the right steps for the right solution. So here you see you can filter in I think there was around 10,000 different volumes. and you can filter it to the number of towers you want, the open areas, and the shift in the towers. That is also about the economy. How many shifts do you have in the levels? And the thing that we did was to select someone that works well, and then we were designing with those as input parameter. But what the thing was, where you understood from the very beginning that all those scenarios here fulfilled the requirement from the brief. And what this does is that it inspired the design team. It was not coming up with a solution, but it was inspirational. It also invited the client in. We had a very fun session where we showed these tools, and the client said, "Oh, can I have 10-15 minutes with you after the meeting? I really want to try it out and see different solutions." And so again, it's a tool for dialogue. And again, it's not a design tool, but it's a tool for qualifying the design based on the impact we want to create. And here you can see that it's creating more into shapes, into forms, and now it starts to become some kind of architecture. Carlo, you also introduced that we do a lot of innovation at Henning Larsen. We have like a applied research team. Again, it's very much about that we are not setting up end-to-end workflow. It's also, I think, what the learning for hearing Emanuele is about, tailor-making or scripting something that fits into the project that you're working with. So we do a lot of those small hacks doing the design. But again, it's also, this one is not working, but this is part of what we call the sandbox. Is a box where you can play with the sand, and it can scan and come into the digital model. This is our PhD, and again, some of you maybe out there want to do a PhD. Please feel free to reach out. In Denmark, we have a called industrial PhD program, so you can be employed by the company, but be affiliated with academic partners. You can see a very young guy on the left-hand corner that started up almost 20 years ago as a PhD. So that was my first journey here, and we have been continuing it. At the moment, we just launched 3 new PhD. That is Ming, Jesse, and Nitsan, all working with regenerative planning from different perspectives. Ming is ecosystem service, Jesse is more into biodiversity, and Nitsan are looking into urban planning, but also with the lens of AI. I think that will be the last part of my talk around AI. Everyone talks about AI. It's like teenage sex that everyone wants to. And this is Nitsan, and he came and said, like, how can we use AI to understand more data when we do regenerative urban planning? Because there we have a lot of data, but we also need to be conscious about what kind of data. And we did this small LinkedIn post about that we are also consuming data, and it's like having an effect. When you do a prompt, it can be the same as taking a shower in the morning. And it concerns a lot. I think there was 130,000 people that have a reaction to this. And of course they have a reaction because this is like something that we meet every day. Data have power, and we need to understand that power and be conscious about what kind of data we share. And again, it's also coming into the whole infrastructure part. Meta is now looking into buying nuclear plants and become part of the energy infrastructure. So again, having this awareness of utilize data in the best clever way is not about over consuming it. But again, it also comes with a fear. We had a newspaper that reached out to us and want to learn about AI, and there came a headline that AI are stealing our jobs. Maybe can I don't know why this is it's a bit annoying. It's not working. Maybe I can this one. If you go Google AI urban planning or AI cities, you will get some kind of Blade Runner architecture out of it, and that's, from my point of view, the totally wrong impression of working with data. What I'm seeing is that if you work structural with data, you can get more diversity in our city, and that also means that you can create bigger impact locally. That means that the connectivity and the whole impact of the city is improving. So data and AI is not creating some kind of like architecture that is futuristic is actually create more. This is from Berlin or Hamburg in Germany, much more social friction. And we see this is also what the client are asking for at the moment. Client is not asking for us designing for them, they are asking for us designing with them. And that means we need to understand data in a much more fine grid way to be able to create impact. And again, it's like an iceberg. Many architects only looks what is in the plain sight, what is in top of the water. But we need to bring all the data that is under the water up to the top, because that is the only way that we can create real impact. And again, it's like it's coming back to nature. It's about a lot of Danes have a lilac tree. I don't know if it's the same in Italy, but lilac trees is not part of Danish nature. It's coming from I think from the Middle East, and no insect can live from the nectar because they don't have the access to the nectar. But an oak tree instead is native to Denmark, but no one have an oak tree in their gardens. And more than 200 insects living from an oak tree. So again, understanding what is the plain sight and what is actually the real impact. Please, if you are any Danes here, cut your lilac trees and plant the oak trees when you come home.
Good point.
Again, it's about getting the invisible up to the surface. We had a urban planning competition. This was around 1 year ago, where we said it was an open competition, so we don't have that much money to spend on it. So I said, like, set aside 1.5 weeks and do what we can, all of it with AI generated information, and we were totally open about it. It was not something that we hid. This competition is then generated by AI. All the text, all the diagrams, and all the renders are generated by AI. And the workflow was that we went out for doing some data harvesting locally. Based on the data harvesting, we did the recommendation, and we generated images and takeaways for the clients to proceed with the planning of the. And the data was harvested from social media data. People have been into the site. It's a industrial site in the harborfront in Denmark, so they have been there taking photos, sharing the photos with a prompt, with a text, and then we filter it. What was on the photo? Were they taking pictures of food or greenery or people dancing? And then we use different tools to sort them and to organize them, finding out what kind of prompt, was it a positive or negative relation that they have with the photo. But again, it's also about knowing the site. Every year they have the Copenhagen Hell happening on the site. So if we don't know about the specific site and the planning of it, we will get data that is very exciting and maybe also very innovative in a way to design a new plan, but maybe not what we expected to be. What we saw here, I will not go so much into detail. This is the data harvesting, that there was a lot of images, prompt relating culture to start with, but then there was a food market moving in, so it turns into more food and beverage. And then there was a lot of green. Also, this is a very industrial area, but people was actually relating very positive with the green elements at the site. And based on that, we did some prompt and small visualization. You can see this is like 1.5 years ago is with the mid-journey, so that the visualization is very much what we saw at that time. Things are progressing super fast here. And we did some recommendation. And we won a prize for it, and now we are into doing the real design competition now, so that also makes us invited for the competition. Carlo, I don't know what time is running.
But maybe we have like 2-3 minutes left before we pause.
Okay.
Maybe we can have a small conversation also with Emanuele and you, because there are a few questions in the chat, but they're very specific on the tools and the project. Maybe you can address them directly in the Q&A box. But no, again, the potential is impressive and also very interesting to know how you are practicing these tools in your daily activity. So what could be your suggestion for a design firm which is not there yet, and maybe they want to take a concrete step forward to be, let's say, to provide regenerative services for cities? What's the main big step that they could adopt, let's say?
I think, Carlo, is a super good question, and I see the industry is actually opening up for smaller studios to be participating in it. I think also what Emanuele was sharing, there's a lot of things happening in GitHub. That means that it's free for use. You don't need to buy a tool with a heavy license price on it. So it's accessible for everyone. And also with AI coming in, that is also democratizing a lot of data and democratizing a lot of tools to use. So I really encourage people to explore that. But again, it's not to have just a comment. My team is not sitting in the corner of the office, being the nerdy corner, so to speak. We are sitting in the center of the office with the competition team, with the designers, and I'm so happy when the chairs in my teams are empty. That means that the competition designer is sitting with the design team. So it's about finding the talent that both have the understanding of data, have the passion for the green transition, and have the understanding of beauty and architecture and urban planning. I know it seems not simple to find those talent, but they are there, and we have a generation of young architects that don't believe in doing the iconic building on Manhattan. They do believe on doing more transformation and more regenerative design. So I think we have a strong design culture. Sorry,
Yeah,
that's
great. That's great.
Maybe
No, that's great. Also, the work that you're doing with PhD, with this PhD program, is absolutely precious and valuable. And I know you're really just after the main entrance of the office, so basically people have to pass through your area, let's say, to
we make them
deep
pass
dive
through.
deep dive in Henning
They cannot
Larsen.
go around, right?
Yeah.
You need to.
So, and for the companies that they think that are already like very advanced in terms of computational design, how could they switch to regenerative? So I appreciate a lot when you said, okay, we're not regenerative yet. We are doing something regenerative, because there is a risk of regenerative greenwashing happening probably in the very next future. But let's say for a company is already very advanced with tools. So is there a way for them like to switch to regenerative? Is it, or is it or the question is wrong per se, let's say?
No, I think it's a good question, and I think that it's also, we need to be transparent about the dialogue. But what we are advocating for is that each project have some kind of element in the regenerative aspect in it, but it not have the all, because it's too overwhelming at the moment for people to handle and to grasp if they're gonna do, like you saw the big chart from Emanuele. If you need to fill out all those boxes, then the people will get like stressed. So it's more to find having the dialogue up front with the design team, with the client. Where can we do this biggest impact with the site and the project we are working with, and where can we push the boundaries? And then you start pushing boundaries with different projects on different boundaries. It's not the same. It's like we also global design firm. We design differently in Copenhagen than we do in Riyadh, as also Emanuele said. It's different. But bringing all those learnings together will move us to more regenerative urban planning and a common understanding for it. But we are not there yet. It's like when I mention it to some of the design team, their eyes are flickering.
Sure. May I ask a further question? Thanks, Jakob. Wonderful as usual presentation. You have been creating a model where research, digitalization, and then you have all these oxymorons. You almost do digital straws some days, and then you really built it. So to me, you are perhaps the most advanced, and I know as Danish you're modest, but globally you're probably an example, because you have interpolated research, digitalization, construction, and I would say also with always a philosophical lift, some theory behind that. How was important in this triangle to really build things and to touch what you've been simulating, how this materiality it's a layer into your workflow?
Thank you, Emanuele. This is a perfect question to close the session. Please, Jakob, go.
Yeah, but Emanuele, I think it's also building up the culture for many years. But it's like, it's very much a cultural. It's very much like also when we recruit people at Henning Larsen, this is some of the first aspect that we ask them. It's not about the tools that they use. It's like the belief that they come in with, that they believe that every project should have an impact that goes beyond the aesthetic, and also this way of comparing that the right and the left brain, right? You need data is there, and it's good because it document what you're doing, and it's as a way of communicating. But data is not solving the design, so it's about this fine combination all the time, and it's really difficult to do a recipe on. It's very much a design culture that we need to involve. But again, coming back to the young generation of designers and architects, I see a big change the last few years.
Yeah,
and
it's happening. It's happening.
It's happening now. So that is.
Thanks
So we
so
need
much.
to get the old dinosaurs out of the room, Emanuele.
Thanks, Jakob and Emanuele. Great talks, absolutely. So we are keeping a bit less than 15 minutes pause now, break. You can also enjoy a Spotify playlist that we created for the event, and see you around at 11 a.m. Central Europe time. Bye-bye. So welcome back. Again, another session is going to happen, which is really with another couple of great design firms. So we are really playing the Champions League today. This session is about mostly decarbonization, I would say. Really how we can anchor regenerative digital design to the global CO2 emissions issues that we are facing. So at first, let me introduce to you, and again, you can look at, you can see the full bios of the speakers in the registration page. Sanne van der Burgh, head of the Next initiative. Sanne probably will explain to us what the Next is at your company at MVRDV. And Sanne, it's a pleasure to have you on board today, and I'm passing over to you. And yeah, let us know what are you doing around decarbonization with some very interesting tools and initiatives.
Thanks, Carlo. Thanks for the invitation, and I'm really happy to be here with this epic group of people to talk about something that somehow started as a curiosity and became my biggest passion, and that is decarbonization. So I'm going to share my screen, and you should be able to see.
It's uploading.
Yep.
So we see your full, we see your slide viewer now, not in full screen mode.
Interesting.
Maybe you have to click on the
Okay,
icon on the right bottom part of the menu.
And now I will full screen.
It is uploading, so it's taking a few seconds.
Okay. I'm not touching anything.
Yeah, now I see it full screen mode.
Okay, perfect. Excellent. All right. Well, we have 40 minutes, and I'm going to do my best to keep space for questions. And yeah, nice to meet you. I'm Sanne, head of MVRDV Next, and this is going to be a roller coaster for the coming 40 minutes. We're going to talk about tooling, research, Grasshopper, of course, analysis paralysis, a bit of AI, because everybody wants to hear about that, focus, relevance, and impact. So let's go. The main topic of today is going to be Carbon Space. Carbon Space is an in-house tool that we developed for architects by architects to focus on impact on the decarbonization from day one of the design process. And we recently released this for free for everyone. And this is not going to be a course in how to use it, because that already exists. Ollie passed by, Oliver Thomas from the Architect Network, and you can find the link here. And that is actually a full recording on how to use Carbon Space. So we can skip that, and I would like to talk about the bigger picture, the why, the how, and the what of Carbon Space. Yeah, as Carlo mentioned, I work at MVRDV. Our mothership is in Rotterdam, the Netherlands, but we also have offices in Paris, Berlin, Shanghai, and New York. And I have 300 colleagues that work with me, and we work on projects, architecture, urbanism, interiors all over the world. Around our corner from the office is the Market Hall. This building you might know quite well. It's a very colorful building. We also built this in Amsterdam Valley. It's a very expressive building, the wild child of gravity and structure. We do star architecture things like put a big ball inside a library. but we also have a passion, and we've always had that, for regenerative design and sustainability. This is our Expo 2000 pavilion in Hanover. It survived the Expo. It became our first ruin ever, which was super cool. And we're currently now transforming that into a student district. When we think about regenerative design, sustainable design, sometimes we think that we should maybe design for eternity or for maybe 500 years lifespan. And this building in Munich actually was designed like that. It has double high floors, and external circulation, and it can endlessly be reprogrammed. So that is one of our dreams, is that our buildings will last forever, as all architects dream of that. So if you think of the work of MVRDV as this, projects, buildings, urban design, then the work of MVRDV next is actually this. So it's everything that happens under the hood. And it's very similar to what Jakob just said, is my group is a group that combines climate and computation. And it really makes sense to put those two together. So as I like to say, half of my team is nerds and the other half is tree huggers. With that team, we also work on the challenges of today. For example, here we have a design that was made with plastic ocean waste that we turned into a 3D printed design, and that became this shop in Changi Airport in Singapore. But we also designed and built our first fully demountable building. So this has been designed for disassembly, and all the 151,000 parts can be taken apart and are labeled. And that brings us to the topic of today, which is our journey through the world of sustainability. And that's been an interesting one. And I was lucky enough to be inside it. And this started a long time ago when we said we want to be 100% sustainable. And we love that. And we wanted to have we became vegetarian, and we had an LGBTQIA plus group. And then we were very enthusiastic. We started to recycle our coffee grounds. We were counting our toilet and cleaning paper, our printing paper. We had a green wall with a bird, and we had a book, 2018, a book with all these kind of rules that you can apply to make your projects more sustainable. We have a foundation that offsets our flights. We were working with the United Nations Sustainable Development Goals, even though we found them quite difficult to use because they're made for countries, not for architects. But we tried. And then at a certain day, we said, oh, we need to have measurable impact. So we started measuring all sorts of things. We had sustainability consultants that gave us very complicated Excel sheets that told us to count the worms in the soil. And of course, we had tools. Thank you, Ladybug. Also, we started to look at environmental analysis, and we started to use all of these tools in our projects. And we looked at compactness and open facades and daylight and sun and water and wind and everything. But at the same time, we were using all these tools. But the question for us was, how can we use these in a meaningful way in a design process? And are our buildings actually becoming better by using all of these tools? And we got the feeling that we were using the tools as a goal, and analyses became the goal, and we were actually continuing business as usual. And if we would be continuing business as usual, my house is 4 meters below sea level, then this might be our future. So there was a moment 4 years ago when we realized that we might be measuring everything but the point. That brings us to Paris and Rome. And Rome already warned us 50 years ago for our current behavior that's exhausting the planet. And 10 years ago, the Paris Agreement turned that into a treaty. Then again, 2024 was the hottest year ever since we started measuring. And the author of the Paris Agreement is calling what we are doing now suicidal. Yet architects have, according to the Architecture Journal, 196 times more power to cut carbon through work than through lifestyles. We are a very polluting industry, and we are part of the problem, and we wanted to become part of the solution. To compare how polluting we are, one flight London, New York equals 600 to 800 kilos of CO2. And that's why we decided to focus on embodied carbon, because that is what we emit today. And that's also where we have the most impact as architects. It's within our sphere of influence. There are certification systems, the LEEDs, the BREEAMs, but they were designed before the Paris Agreement, and they are not yet carbon-first frameworks. So there is a gap, and how to bridge that gap. We started journeying into the world of carbon, and we found a lot of things that were interesting, but also made the discourse very complicated. Every country has different legislation. Countries have different ways of measuring carbon over different times and over different scopes. If we would put our market hall, literally the same market hall in Sweden, it would perform better because of the way GFA is counted. So that shows how difficult it is to compare internationally. Different cities, different countries have different milestones, targets. These are all of the European targets that we found together. So you see they're all different. So how can you say something meaningful about targets? Also, databases, people love talking about databases. These are some environmental databases, carbon databases. They're all structured differently. None of them are complete. And several or most of them are behind paywalls. And if I'm an architect designing a competition in China, I can choose out of almost 1,000 cements. And I don't know what kind of cement I'm using when I'm using a competition. So that's why we said that we actually need less data, not more data. What I run into a lot of times at universities, carbon conferences, is people demanding more information, more data, finer data, like more numbers are going to solve the climate crisis. Also, currently, I don't know if you've ever done an LCA, but you need to have quite a highly detailed BIM model, and you need to do quite a lot of effort before you finally get a number. And that's usually when you're out of time, out of money, and all the decisions have been made. So when can we act? And this is kind of a summary of our journey through drowning in detail, data deliriums, and how can we have better information earlier in the process? Can we think of a method to design with embodied carbon from day one of the process based on maybe just a napkin sketch? So we said, let's make a tool. Part one, this was quite the adventure. First, we started to think carbon comes in very late in the process at this point, after all the one-click LCAs. Can we compare it to building costs? And can we imagine that we develop a feeling for carbon the way we have a feeling for building costs? And we developed a whole complicated Excel sheet with ballpark figures and ranges that gave us, let's say, a series of options that would explain roughly how much a model would emit, like a rough model, a fine model, different materials, different shapes, and that gave us ranges. But we also realized that this was quite vague, and also architects don't like working with Excel sheets. So the Excel sheet didn't work for us. Then we said, let's make a tool part two, which is where we made a ladybug, a grasshopper plugin. Our grasshopper plugin that we made was 4 key ingredients. So you put in a shape, very shape focused. Then you're going to guesstimate the missing elements with, again, ballpark figures and rules of thumb. Then you can explore your impact and track and trace your carbon. So we made the grasshopper plugin, and that was also quite an adventure. And there was this dashboard that would show you where to look for impact. And we thought, okay, we give this to our architects, they're going to work with it. And they were. And to our surprise, we saw this. And what you see is actually a lot of different options, 2 towers, 1 tower, like little village, but they're kind of all performing the same, more or less. And that gave us the insight that maybe shape doesn't really matter that much. And maybe it's not about the shape, but about how a building is made, what's behind the facade, and what are the systems that are used. Also, not everyone in our office could use Grasshopper. So attempt number 3, let's make a tool. We decided to go web-based, and we developed this is Carbonscape, which is currently publicly available at carbonscape.earth. And by making it available for free on the web, it's easily accessible, it's scalable, and it's transparent. It has an online documentation, libraries, templates, It's integratable with other softwares, and you can compare anything and everything internationally. This is the landing page if you go to the website, and you can register and start playing with it. If you log in, then the easiest thing to do is start a new calculation with a quick scan. And again, I'm not going to run you through it, so this is just super quick to give you a rough idea. But yeah, if I log in, I make a new building, it automatically fills in some basic values like a GFA and a height. That's just a pre-filled in quick scan, and you can start editing that yourself, your heights, your amount of floors, your facade area, glazing, and you can go as detailed as you want, but you can already say something based on ballpark figures. Then in the next tab, you have different options for your materials. So what you see here is you can choose from different floor systems, different roof systems, different foundations, different facades. So if you scroll through this, you can start to compare options, and it will show you what your reduction potential is. This means that it helps you understand where to look for carbon, where to find carbon, and where to see where you can have the most impact. We went through over 150 projects of our own, from the foundations all the way up to the maintenance crane on the roof and everything in between. We went through projects in the Americas, in Asia, Middle East, Europe. We went through competitions, through DDs, as-built projects. So we have a very broad set of different typologies, different countries, different phases. This is a bit of an overview of what we saw and what we are learning from ourselves and from our own projects. So all those vertical bars are actually buildings. And you can see that there's a big diversity you see peaks like very heavy carbon buildings, but also light carbon buildings. And the orange line is actually our portfolio footprint, which is yesterday at 469. What we learned from this as well, by crunching through 150 buildings, is that the most impact is in structure. And the most impact within structure is superstructure. So that's everything above ground. That's your floors, your cores, columns, beams. And also substructure is responsible for quite a lot of embodied carbon emissions. Yeah, within structure, floor plates have a lot of impact just because there's a lot of them, and they contain a lot of concrete. Concrete is made with cement, and cement emits a lot of CO2 during production. We also learned something else. Actually, we learned many things. We compared an as-built LOD 500 model versus a shoebox model, and we had two different teams do those calculations, and we compared them against the building permit calculations. And what we see is that the difference was 2% between a rough and a fine model. And then you might think, why is that? That is because it has the same amount of foundation, the same amount of basements, the same amounts of structure, and the differences are surprisingly small. We were also playing with shapes to explore what the impact is of shape, because we at some point were a bit afraid that low carbon design could be the end of fun or expression. And well, this was a very daring case, but we took this building and we completely pulled it apart until like the screws in the facade. We calculated it once straight and once completely flatly ironed. And the difference is 3%. And again, you would say, why? How can that be? That is only the straight version is only 3% lighter in carbon. And it is again because it has the same amount of basement, the same amount of floors. The only difference is the square meters of facade area. So we started to systemically Frankenstein with our own projects and experiment and play to see like where is the impact, what makes a difference, what doesn't make a difference. A lot of people always say that this building doesn't look sustainable or stone isn't sustainable. So we said, let's make it out of timber that looks very sustainable. The difference in the overall carbon footprint is 1%. And even if we would go like all hippie, again, the difference is 1% because all of the impact lies locked away, hidden in all of the concrete and the steel structures. And yeah, in both of these buildings, parking, very big parking basements, again, lots of concrete. So that also learned us to look at parking and be critical of parking. And this is a project we've done in Oslo. We've done a master plan here, and we were able to create 450 apartments with 20 parking spots. But why were we able to do that? We cheated because there's a station behind this master plan. So easy win, but as an architect, this is sometimes not in your sphere of influence. So yeah, what to do if you have to build a basement? Yeah, you might say, let's use sustainable concrete. We also thought of that, and this is a building in Rotterdam that we have just started construction on. And I'm going to be honest about the carbon footprint. It's been designed 10 years ago. It's very tall. It's the largest residential building in the Netherlands. So it has a very heavy carbon footprint. But if we would use the sustainable concrete trick, then we would win the very sustainable award and I would instantly halve my carbon footprint. So why don't we do that? Good question. Because of course we wanted to. This is a project in the Hoge Veluwe in the Netherlands. Very small, tiny pavilion, designed in concrete also 15 years ago. And during construction, we said, let's make this an icon of sustainable concrete. And we found a magic concrete with a very low carbon footprint. And then the contractor looked at it and he laughed and he said, I don't have this. And he used regular concrete. And that's the myth of sustainable concrete is that it's usually made with, no, it is made with byproducts from steel industry, for example, blast slag and fly ash. And if everybody would switch to sustainable concrete, the supply would be depleted almost instantly. So it could be a solution for your project, but it's not a global solution. So what can you do? Parking wise, so we have quite a lot of parking activists, basement activists now in the office, and floor activists. The young people really want change and meaning. You could do puzzle parking, automated parking, like here in our project in Silodam in Amsterdam, or in Bordeaux, where we are hiding the cars on ground floor and leaving them with the program. In Sri Lanka, we moved the cars and the parking to the first and second floor, and these can be transformed into offices later on. And in this AI campus master plan, we gave the cars their own building above ground. And this is also for us the first time that we started to master plan with embodied carbon. And we started to understand that you can treat it the way that you treat money. You have one budget, one carbon budget for your master plan, and you can start shifting. Some buildings need to be heavier, like the data center, the parking building, but other buildings can be much lighter, like the daycare, offices, residential. So we're balancing the carbon budget, and we have been doing that since day one, and we're now in the 1 to 5 facade details, and we can account for all of the carbon in all of the buildings. Yeah, tracking our portfolio gave us a lot of interesting insights. I used to know a sustainability consultant that told me that it's all about compactness. So we decided to look at that. And we didn't really find a very strong correlation. We actually see that kind of all of our buildings tend to be around 0.5. Yeah, are big buildings bad? Also not really. If you look at this, you see also like big differences between carbon footprints and building sizes. Heights, also not really clear. We have very tall buildings that are very low in carbon because they're timbers or transformations. We have very low buildings that are quite clunky. But then we found an undeniable correlation, and that is the relationship between embodied carbon and weight. Eureka, because heavy buildings have a lot of concrete, and again, concrete, cement, steel. And this is something that anyone can use, this information. You don't need tools for this. You don't need data for this. Try to make your building lighter. You can do that in different ways. For example, here in Paris, we used mass timber construction to build very lightweight. Here in Brussels, we're also learning from ourselves and actually designing with weight. And from day one, the team said, we're going to use timber floors. So the timber floor activists, we're going to use lightweight facades. And by doing those two things, we saved so much on the foundations that we were able to realize a 49% embodied carbon reduction compared to business as usual. And this is my favorite new thing is these guys, because of our carbon activism, became our clients now. These are the Buddhistic monks and nuns from Plum Village. They're passive peace and climate activists, and this is an MVRDV building. We are also reinventing ourselves. And this is our first building in straw. So yes, MVRDV goes straw, and we're super happy with this. So lessons learned. What did we learn from our carbon adventures? I recently was in Toronto to talk at a conference, and in Toronto they have something called the Toronto Green Standard, and that says that your superstructure, substructure, and skin need to be below 350 kilos of CO2 equivalent per square meter. And I was asking people, like, do you know what that means? How can you design with that? What does that look like? And I even checked the Carbon Leadership Forum database, but nobody really knew. So I thought, well, let's dive into our own carbon city that we built and see if we have something that looks like the Toronto Green Standard. So again, carbon city. And I filtered out superstructure, substructure, and skin at 350 kilos. And I found that we actually have a couple of projects that would fit those standards. This is, for example, one which is a transformation building, easy. This is our first timber tower, so also that would meet that TGS standard. These are our timber hybrids that also perform quite well. But this was a really big surprise, and I checked it 2 times. I had somebody else check it with the project leader and the structural team. And this is a building in India. This is Future Towers, and it's a mega housing project. And the reason why this is so low in embodied carbon is that it sits on bedrock, so it has no foundations, just a footing. It's in India, so it is relatively thin floors and very thin walls without any insulation or cladding. It's just exposed concrete, single glazing. So there's just very little material in this building. So that also taught us that there's not one way to Rome or to the climate goals, and different contexts have different opportunities and limitations. We summarize all of our learnings in the MVRDV Carbon Guidelines, which is a poster that's everywhere in our office that you can download for free and have nice carbon discussions with your family, your mom, your colleagues. And one of the most interesting ones is this: do not build new. Our PR guy wasn't happy initially when I shared this, but I think they've all warmed up to it now. So yeah, what is the future of architecture? 85% of the buildings that stand today will still exist in 2050. Real estate sectors are afraid of stranded assets, so buildings that don't function anymore, don't meet the standards anymore. So we are unstranding assets. This is a building in Shenzhen that was built in 1994. The client wanted to demolish it, and instead of demolishing it, we were able to convince him that a transformation would be faster. And because of that argument, we were able to transform this building into a very colorful women and children's center. And by retaining the concrete structure, we saved the carbon equivalent of 11,800 flights from Amsterdam to Shenzhen. Also, on an urban scale, you can not build. And here we didn't build this High Line. This was a flyover that couldn't support the traffic anymore. And instead of demolishing it, which would cover the city in dust for 5 years, we programmed it into a local High Line in Seoul that has all the species of the country from A to Z. And you also see that it generates, it increased the value of the property around the project a lot. So next time I would do something like this, I would ask these guys to pay for it. And you see also that in Time magazine, they also identified these projects as destinations. Here in India, we also are good at not building. This is an open sewer, the Barapula drain, where we made a self-initiated pitch. So I went to New Delhi and spent 2 weeks going through this drain, documenting it, and creating a vision for sanitation, regenerative design, ecological, multi-generational spaces underneath flyovers, urban connections. It never became a real project, but we put it on our website, and we got a call from a guy in Mumbai that said, hey, I have a flyover, can you do something with that? And that's what we did. We programmed this during COVID with art, with furniture, multi-generational spaces, green, shaded, protected. And what I love about this is that we won the Building of the Year award with something so simple as this, programming a space underneath a flyover in India. And for me, that also shows that the discourse is changing and we're looking at different things and really redefining what quality is of life and of architecture. Then we got a call from the governor of Bangkok who said, hey, I also have these things. Can you do something with them? And now I'm going to talk about AI. So we set up a temporary installation for a week. We turned it into a festival and we had an AI model trained that people could chat with and people could draw on. And we used AI not as a way to generate designs or visuals, but just as a way to hear from the community what they want. So none of these images are meant to be design proposals, but they visualize the wishes of the community. And it was a lot of fun, and it was really part of placemaking and brainstorming together as people of Bangkok. So what is next for us? This is our MVRDV carbon commitment. What we have is a live dashboard, so this gets updated every day. We are currently 60.9% on our way to Paris proof. We see every day how we're doing, and our goal is to achieve for our entire portfolio below 400 kilos. So we have to lose roughly 3 kilos per month for the coming 5 years, every month. We're also in discussion with policymakers and city makers. This is a Dutch article, but the 15 largest investors and pension funds in the Netherlands have signed an agreement that they will disinvest from projects without clear carbon targets. And we're also advising green building councils and other building councils on realistic targets. For example, this bio-based initiative had pretty ambitious numbers. We were able to help them out with what are realistic percentages of bio-based for a straw building, what are realistic bio-based percentages for a timber hybrid. So we're also advising policymakers. We collected all of our crazy adventures through the world of carbon in an exhibition called Carbon Confessions. It shows what we tried. It also shows the mistakes we made because we're also learning by doing. And it also shows the things that we think are useful for others. This is the greenwashing machine. It's also in there, super fun. And on the inside, you can see actual decarbonization strategies. And I was a bit afraid when we opened it, thinking who is going to come to this, but it was a hit, which was really nice. We started in Munich, it went to Berlin and Paris, and next landing is Rotterdam. And after that is going to go to Toronto and Singapore. So if you want this exhibition in your city, let me know and we can transport it there. We have not developed Carbonscape in splendid isolation. We have partnered with the Council on Tall Buildings and Urban Habitat, CTBUH, with green building councils, universities, and engineers and carbon researchers. And I'm very happy to share that next month it will be made public that we are the official decarbonization partner of the CTBUH that will be rebranding themselves into the Council on Vertical Urbanism. And together with them, we have the decarbonization program for the awards and the developer commitment. That means that the CTBUH will redefine the definition of architectural excellence. And in the future, tall building nominees can only get an award if they have an embodied carbon strategy with data submitted. So there is a change happening in the global carbon discourse. And the two main reasons the two main things we wanted to achieve with Carbonscape, and also why we are sharing it openly, is almost to make a tool to show that you don't really need a tool, because what we think we need is to develop a feeling for carbon, understanding where to look, how to steer, how to have better discussions with each other, how to look for impact, and kind of steer away from this desire for precision and precise numbers. Because in a way, it's not a calculator, it's a compass that helps you learn where to look and how to steer impact. And the other thing that we hope to achieve with the exhibition and the software and sharing is to create a global carbon community where, in an industry that's driven by proprietary tools and data, to take a step into actually sharing with each other. And I think it's fantastic that there's a lot of people in this group that are doing it, and we're happy to be part of that.
Brilliant.
And with that, I have finished my presentation.
Thank you, Sanne. Brilliant. So also thanks for telling us the story of how you developed the tool internally. So based on your needs, basically on your daily activity. So where you basically you put yourself to yourself, say the right questions. I was thinking, so you showed this dashboard where you are basically providing the daily data on your overall impact. How are you tracking this data from your projects? How does it work?
Well, I have to say it's a process. It depends, first of all, in what phase the project is. But usually early stage concept designs, we get our data from the Rhino models. So there we extract the square meters of glazing, a floor area. In later models, we actually extract the whole thing from a rivet set. But even based on a brief, you can already say something. If you know that your building is going to be 20,000 square meters, so many floors, you know that the soil condition is either soggy or bedrock or in between. So you can say if you're going to have heavy or lightweight foundations. So different phases have different sources of data. And actually in the as-built project, we sometimes get our data from invoices from the contractor. So the act of collecting quantities in itself is became a bit of a weird hobby, but data scraping through countries and phases is wildly diverse. But we have a whole team that's now kind of drilled in this carbon scraping, architectural forensics to look for quantities and data sets. But it's completely different per project.
Yeah, but so in the end, you have an internal process where your projects are feeding data directly into this dashboard. So
yes,
which is absolutely great, because in the end you know where you're going. So basically it's like really having a dashboard while driving your car. So and say, okay, I have to go a little faster or less faster. So depending on where are you going. Now this is interesting. But I was thinking, are you also comparing the real data from once the projects are being completed? Because in the end, this is a tool to make an estimation, let's say, of a rough calculation, let's say, of the carbon impact. But then, are you like also measuring ex post, let's say, from completed projects? And if yes, are you noticing differences that probably can also help you in fine-tune the tool as well?
Yes, totally. So of course, we have a lot of buildings with that have been realized that needed this calculation for the permit. And that's also why sometimes we work in reverse and compare the official validated LCA results against our internal version and even against the shoebox model. And what we constantly see is that the difference is just very small. And again, because there's just so much in the structure, in the floors, in the cores, the foundations, that the difference are just not that big. And that's what we see in a lot of different projects that we tested in different phases as well, but against an official LCA.
Okay, no, interesting.
May I follow up with a question?
Sure.
Sure.
Yes.
Thanks, Sanne. Wonderful presentation, very inspiring, and I love your sensitive analysis that comes from real projects. So that's something extremely remarkable. Obviously, your distinct trait as a firm is the ability to create space that are also adaptable. But the 3D development has been quite unique. And one of the controversy or one of the compliments you may have received in several occasions is the cost of shape, and you definitely the carbon cost of shaping, and you have definitely showed us that isn't the primary concern. I was wondering, I'm aware, perhaps through acquaintances, that you also inform developing, are considering other factors. Well, obviously, solar envelope, reverse solar envelopes, and many other type of topics. I was wondering if you're coupling the tool also with others, and what others palette you're having, or what other interesting trait of let's say, research you're pursuing?
We went through an interesting journey with the whole sustainability tooling, and that was kind of the beginning of my presentation where we went completely wild with wanting to measure everything and analyze everything. And we constantly realized that, and that's probably just it's our firm, I guess, but we figured that, yeah, we kind of know roughly how to work with windows, and that maybe they should be a bit bigger on the north, depending on where you are in the world, and how to work with shading. And we were doing this, but we didn't really see that our buildings were becoming better.
Sure. No, it is the question. It's not about this baseline. It is about cutting edge in-house parallel development to that one in order to inform the shape according to other type of performance, not the basic performance, let's say.
Yes. Well, actually, the building that I showed, the valley, the one we used for the shape experiment, that entire building is a computer program. So it's been completely made with the brute force environmental calculations of all of the cantilevers, where we compared and rated them with Design Explorer according to sun, views, shadow below the cantilever. We had, I think, 80,000 models of that, and then chose the one that was the best performer. And the facade is a computer program, because no corner, no edge is the same in this building. And how do you design the tile facade for that? And we developed a script that went from Rhino to Revit and back, kind of like a big letter soup. And we designed 44,000 tiles with 27 revisions in a computer model. And what we're currently doing is we focus more on non-spatial challenges. So our history of Next is really, we came from the computation side and started as like the complex geometry group. And what we see now is that we kind of know how to do that. And now the challenges are much more about non-spatial aspects. And indeed, we're now also working together with cities on digital twinning, on how to develop rooftop policies, to impact quantification of, working with cities. So we do see that we evolve also as a group, as Next, and that is, and of course we will always keep doing that, because the role of the architect is also, as I see, evolving as much more a curator of systems somehow.
Interesting. Thanks.
Thank you.
Thank you, Sanne, again. So there are a few questions in the Q&A box. If you can stay online with us, so maybe you can address them. Some of them are also very specific about the methodology, the criteria that you're using. So I think it does matter what are the systems and the criteria that we're using in assessing the embodied carbon, as you demonstrated from some of the projects. So maybe these are absolutely interesting questions that you might address in the Q&A box. So with that, I would pass to another interesting experience of another design firm, international renowned design firm, GRIMSHAW. They developed internally another tool addressing decarbonization with a different perspective. So I think it's also interesting to combine these two experiences, these two stories within the same session. So I'm introducing to you Paul Toyne, head of sustainability at the group level at GRIMSHAW. More specifically, hi, Paul. Nice to have you on board today. So you work on this tool, which is called Minoro, which is also supported by a number of leading players for sustainability worldwide. Let us know a bit more about how this tool works.
Wonderful. Yes, delighted to do that. And hello, everyone.
We see the slides with your notes now. Maybe you have to go to display settings and invert.
That was my first question.
Yeah, and the answer is fine. Okay, now it's fine.
Great. You'll see that I don't have any notes. So there we go. Unscripted, live, ready
Very
to
transparent.
be engaged. So wonderful to join you all today. Very briefly, I'm going to introduce Minoro, explain its origins, what it's set up to do and how you can use it. And then really welcome some feedback and discussion about it. So just by way of introduction, for those of you who don't know who GRIMSHAW are, GRIMSHAW are an architectural and urban design practice. We are global in the sense that we work from 8 studios. And we do have a long history of, I guess, integrating sustainability and sustainable development into our designs, whether that goes back to the Eden project in Cornwall or the Seville Expo in 1992. And if we fast forward from that period to when I joined GRIMSHAW, which was just before the COVID era, and I should say that my role is the global head of sustainability. So I get exposure to all the projects that we're involved in around the world. And almost every one of these designs that you see here was designed, you know, in the last decade, 10 or more years ago. But they all have incredible, interesting features, particularly around whole life carbon. And so, for example, the Terra Pavilion actually is energy positive in its legacy mode. The Cambridge University, and I'll show you some examples, but that building is designed for product extension, so it can be extended to. It is energy neutral as well because of the energy system they've got on the campus at the university. Woodside Building, which is Monash University in Melbourne, that's Passive House certified. And I started to ask myself the question, what was it that we did with whom to actually drive down whole life carbon in these particular projects? And wouldn't it be really useful to actually understand those steps, at what stage and what tools did we use? And if we understood that, could we replicate that to actually drive carbon reductions on all our projects globally? So that was an inquiry I started, and fast forward, and I'm going to skip a bit and go back. We got to a situation where we've now published Minoro. So you can find it right now, go online, it's completely free to use. And what Minoro seeks to do, it's going back to the last presentation around systems and thinking holistically about what we need to do to drive carbon down. And I have to say that this tool is unashamedly focused on whole life carbon because of the urgency of the issue around reducing global greenhouse gas emissions. But the approach that we're taking, which is a systems approach, could be equally applied to biodiversity, to materials circularity, to health and well-being. And hopefully you'll see this as I explain it. So basically what Minoro offers you the opportunity to do, it actually maximizes your opportunity to reduce whole life carbon in new and existing buildings. So, and that's because what it focuses on is, what is it that you need to do? Why are you choosing to do that? Who are you doing it with? And more importantly, how do you actually do that? So it answers those questions in a logical sequence order that allows you to maximize the opportunity to reduce whole life carbon. And if you think about it, and this, you know, going back to understanding of the client community and investors, it's really confusing for them. There's so much information, there's so many tools, there's different standards, there's different regulation. You know, what's the simplified way of knowing that I've got the diligence in place, the accountability to reduce whole life carbon on my project? And how do I know you as the supplier, whether you're an architect, an engineer, or a consultant, how do I know you're doing the right things in the right order to make things happen for me? So the opportunity is how can we have a centralized system, almost like a Wikipedia, of the key things that you need to do? So going back to the inquiry I led, which was in North America, mainly in the UK, across into our Paris studio and in Australasia, we then worked out the things that we had done with the different professional bodies, experts, to reduce whole life carbon in our projects. And we came up with this, what you can see on the screen, which is a very clunky interactive PDF. And then we started to trial it. And I'll give you an example: the repurposing of a warehouse in the Bosphorus in Istanbul into a state-of-the-art museum. through using those steps and the exposure with the whole supply chain to the challenge of reducing whole life carbon, led to conversations with our structural engineers around how we could, consider the structural elements, how we could reduce the amount of material, so dematerializing, and as a result, saving money and carbon. So just within that project, just on the structural steel, we saved over 25% of embodied carbon. And then the project team got really excited, and they went into the different elements of the building and looked at different ways that they could then reduce carbon as well. So we were finding really great results, and that led us to understand that there were 7 key carbon management activities. And if you follow these activities with the associated actions, and I'll show you Minoro in a moment, there's 71 actions. But if you follow these 7 activities with their associated actions, we were finding that we were getting tremendous savings. So, for example, I talked about the civil engineering building, a 66% reduction in annual energy use against the university's baseline for labs, 50% reduction in embodied carbon of the cement used in the substructure, 90% of all the steel frame is recoverable at the end of life through the adoption of circular design principles. So, I'm not going to go into detail, but for each of these activities, working with our with the project team, we can identify and give real sustainability savings, if you like. And the same can be said for the Terra Pavilion, which is in Dubai. It's a museum and a conference centre. And again, as I mentioned, it's energy positive now in its legacy mode. But it's also, think about other elements of regenerative design. It's also water neutral. It takes no potable water from any other source apart from the water that it has on use on site. It recycles all water, including black harvest watering. But, sticking to the carbon agenda, I then went out and spoke around the world and consulted and said, has anyone thought holistically about what we can do to reduce whole life carbon? I spoke to, the architectural institutes, I spoke to green building councils, I spoke to NGOs like Carbon Leadership Forum and Architecture 2030, and they all came back and said, no one's really thinking like this, but it'd be really good just to run it by a wider community, including our sustainability committees, etc. So that's what we did, and we did 2 things. One, we tested the content, and actually what we found was we opened this up from not being driven by an architectural design, but being driven by all parts of the project lifecycle. So that meant a conversation with the IFC and the World Bank about how you can access green finance to drive carbon reductions in your projects. It meant speaking to the client communities all the way down to facilities managers. The second thing that we did was we used that community to look at the functionality and how you reduce Minoro. So I'm going to move now into to show you Minoro. So I'm going to stop sharing, and I'm now going to go into Minoro, and just bear with me. I'm going to share, taking my life in my hands using this technology. But hopefully that has worked. So you now can see Minoro.
Yeah. Okay.
So just a few things about its functionality. You can flip from dark and light screen. You can look at this now. So I'm not going to, hang on a minute. I'm not going to dwell too much on it. What I want to do is just launch Minoro and just talk about the functionality. You don't necessarily have to register. If you register, you get the uploads and the information about where new information is there. But it will take you to this screen. This is for a decarbonisation pathway for buildings. So the functionality, just to look at the top screen, this shows you in full landscape mode. So if you were doing a workshop with clients or the supply chain, you could use it like that. You can then go into specifics, looking at the information about the actions, and I'll show you that in a moment. But it gives you that ability to use it either on your phone, a tablet, or on a computer screen. Let's go back to the large screen. The other thing is that we've if you look at the work stages, your design stages, design stage 0, at the moment, This is globally the global standards, if you your work stages, if you like, but you can change that. So you could move to the European Union system, and there's slight differences around the design work stages depending on what region you're occupying. So, you know, France has its own system, for example. So we've changed that just to make it easy. You can also use Google Translate, and all these actions get translated for you. So that's one thing. The other thing is at the bottom of the screen, you can see the 7 carbon management activities. So if you really want to have an understanding of where, say, for example, how you optimize embodied carbon, this gives you an interpretation of roughly where the key actions are that are relative to that particular activity. So, you know, switching across again takes you into optimizing in-use energy. It also gives you an opportunity to think, well, who am I? Am I a carbon manager or am I an architect? So here's the architect, and you can see where you are principally involved in driving those actions and being part of the solution to explore how you can reduce whole life carbon. So how does it work? So basically there's 71 actions, and let's just pick one. Establish energy use intensity targets, because that's something you're probably all familiar with. And so you go into a situation, so what's the global guidance? So you can use this tool anywhere in the world, and you can understand what it is you're attempting to do, why it's important, who should be doing it. And again, when you think about probably the people in this call and this community, we're very lucky. We have, you know, people like sustainability experts. We might have mature supply chains with specific expertise to help this. But if you're working, say, for example, I know Central Africa, and you don't have exposure to this, and you're an architect and you have to do everything, or maybe you're the engineer, then you know, having this global guidance is actually really important. So you can actually take action regardless of where you are in the world. So it then describes a series of approaches that you can take. So this is the kind of best practice. Sorry, I'm having to use my fingers. For some reason, I've lost my connectivity with my mouse. But anyway, let me scroll up. That's annoying. Just bear with me.
Yeah, no problem.
No, I've lost it. What am I showing now?
We're still on the page where you are scrolling down the example.
Right. No, I've lost it myself. I knew this would happen. So share again. Here we go. So there is well over 1,000 pieces of guidance in here. And so I'm going to go down and just show you. So these are live URLs. So basically the website. So we are taking you now into the internet, where you can find freely available, peer-reviewed information on how you tackle that particular action. Okay, so everything around whole life carbon. We do not specify, for example, the use of certain tools, but we might reference publications that review, like LCA tools. We don't say that this is all about net zero, but we give guidance of where you go to how you can set a target. Hopefully you can go beyond that, but we do talk about how the targets need to be aligned and compliant with the global science, particularly around the science-based targets and 1.5 degrees, etc. So these are the global resources, and then we go into the region. So we have specific guidance developed either at a national level. Some cases we can go even down to the state level or province level or city level, and the European resources. There is, at this stage, and we're a year into it being out there for people to use, there is a bias in this and the way it's being developed, in the sense that we have more complete information from Canada, North America, UK, France, Australia, New Zealand, and bits in between. And so our work that we're doing with the Green Building Councils is to try and get information from other states or nations. So there's an opportunity here for you if you're looking at Minoro and you can see something that you actually use, which is peer-reviewed, agreed, it's what you're doing within your country, but it doesn't feature in Minoro. There's a feedback tab on Minoro for you to actually share that information with us. So
Okay.
I'm not going to go into the actual URLs, but you can now explore it. So basically it does that. The other thing it does is this: you don't put information into Minoro, you take information out of Minoro. And so there's 3 downloadable pieces of information that you can take. So we call it a carbon management tool. First one is a carbon responsibility matrix, and you'll see it here. So you can download this, you can adapt it into your business, but basically it summarizes all those 71 actions. It has a responsibility matrix where you can then assign ownership and understand who's being part of delivering that particular action, and then you can track that action. So that's the first thing. So you can download that. The second tool, which is freely available, you again download it. That's your carbon opportunities register. So that's when you're looking at the feasibility of certain design moves. Maybe it's within the MEP, whether you're looking at different energy sources and you want to compare the cost, the opportunities, potential impacts, etc. So there's this document which you can then download. And around the governance about the Minoro, so at the end of every work stage, there is this point where you have to update your carbon management plan. So what we've done is, again, this has all been peer reviewed and checked, but we have a best example of a carbon management plan, which gives you all the headings, and then you can fill out the information. And as I say, from a client perspective, this gives a true accountability for your progress against reducing whole life carbon in all your projects. So again, this is being utilised. We've got examples of international construction firms, for example, Mace, downloading this management plan, adapting it for the work they're doing currently live on the Dublin City Metro, a large transport infrastructure project. So that's a very quick tour of Minoro. And then just to finish off, let me just show you what kind of opportunities there are in terms of savings. So now hopefully you're seeing my screen.
Yes, we see the screen.
Right, perfect. Okay, so I've explained, it's very simple, it's intuitive to use. We'd really like your feedback. It's free to use. It's not, in terms of GRIMSHAW, we're just kind of like the guardians of it, but it's out there now. We've got, since its launch in July, we've got over 6,500 unique users. And these are people who aren't just kind of had a quick look. They're actually going on, they're downloading the pathway, they're spending time on it. We can track them from 93 countries. We've hosted 16,000 sessions, and we're continually updating it. So for example, in Europe, the top European countries accessing Minoro are the UK. The Minoro has just been updated to include the UK net zero carbon building standard. Second is France, third is Ireland, the Netherlands, and then Germany. So 46% of all our users are Europeans at the moment. And we'd love to see more data or more guidance coming from the European Union. The other thing very briefly to mention is in collaboration with the World Green Building Council, Mexico and Indonesia are now running their internal reviews to put their data onto Minoro. And the idea then is really to grow Minoro in the global south, where a lot of infrastructure development is going to happen, and where a lot of carbon needs to be abated or will need to be avoided. So at a project level, this is a project in central London, in Paddington. It's called, so this is with Places for London, which is part of Transport for London, which is the mayor's body for the underground, the buses and the trams, together with a development partner. But there may be a slight lag. So we've used, Minoro is used on all our projects, and it's out there for others to use. But this was a way of reporting back on the activities that were done by the supply chain. So what you can see was the first stage is 0 to 3 that we've been working on. You can see where the progress was. It's really clear back to the client what's happening. What are we doing in stage 3 that we still is about to be operationalized, if you like? So we've got to use the energy model. We've got these various different assessments to make. How does that align with what the London plan, it's the spatial plan for London is, or specific targets that we've got or standards that we have here in the UK? So again, this information is on Minoro, so we can demonstrate to the client how we're acting against the brief, full accountability and governance. And then you can adapt some of the materials that you find in Minoro specifically. So our partners here, the environmental consultants, Holly, who are looking at the challenge of reducing whole life carbon with our design team. This is an example of how they're starting to visualize the work from the information they've taken from Minoro. And you can start to see how the project is tracking things that they need to consider, reduction measures, again, thinking about the feasibility, having a conversation with a client, which route you want to go. Where do you go for funding? So there are different funding schemes. This we're constantly adding to Minoro in this particular thing, but in the UK we have something for public sector. So where could these measures actually find funding? And so again, that information you can use Minoro for. And so the real benefits is exposure to the issue of whole life carbon, understanding how the project team should have that one coming together as the one team to maximize these opportunities. It talks about and gives you guidance on how to do things in the right order to maximize those benefits. And you've got those downloadable materials, which again give openness and transparency, and you can track and understand where you are at each stage of Minoro. So it's out there, have a look, and please give us your feedback. Thank you.
No, thank you, Paul. Absolutely great, very interesting. In the end, is very clean. Also, the layout and straightforward. Also great that you are still populating it with data and improving it. So maybe I could suggest to consider also zero carbon certification from the future. I don't know if you're
it's
also.
in there.
It's already
So
there.
Yeah. No, so when
it's
you
already,
go down the route of setting targets, then there's information there about what kind of certification schemes are out there.
Okay,
so it goes into ILFI Net Zero, it will go into LEED, it will go into Green Star, Estadama, BREEAM,
Yeah. So
then there's a challenge as to whether those certification standards are appropriate.
Yeah.
And actually can the projects, as I say, this is not about net zero. This is about just what can you do to reduce whole life carbon.
Yeah, sure.
And what targets can you set? Can you go beyond that? It's a little bit like what Sanne was saying about instinctively and actually having a feel for carbon, right? So we need the whole project team to identify where is the carbon, what can we do about it, and what can the client afford to do, and how do we then future-proof our design work, whether it's a refurbishment or a new building.
No,
this is not a certification tool.
No, it's
this is not something where you put
set
data
of guidelines.
on. You take data, you take information out.
Yeah.
You keep that within your business or your project team. But we have asked, so there's a new section coming around case studies. So we've got, working with the Green Building Councils, we've got some fabulous examples of how Minoro now has been used to maximize that reduction in whole life carbon. So this is the systems approach.
Yeah, but are you also thinking in the future to connect with tools that are assessing the carbon impact, or for
the guidance? The guidance is there about what you would do, but we're not going to be in a situation where there's going to be commercial companies saying, "Oh, we've got the best tool ever. Please, can we have it on the website?" We have to. This is neutral. This is the information you find on Minoro is freely accessible. It has gone through international peer review or national peer review, so it's credible data. It gets refreshed and updated periodically through our networks and people that are using Minoro. And what it can't be is an advertisement, because for particular companies, because how do we know, there are other companies that have got something even better. So, we just have to guide people to how would you do an embodied carbon assessment, what kind of tools are available, where you'd go for more information, similarly around, energy intensity, renewable energy, and whatever else. So we it's a guidance, right? Points you in the right direction, saves you a lot of time. Yeah, just imagine, working out how you would do this So this isn't just GRIMSHAW. With the consultation we had was with well over 250 different professionals around the world. You know, some of them are actually on this call and others not, but they are,
No,
you know, the peer review process.
you
So
did a
that, you know, that's what we've attempted to do.
You did a massive work indeed. So we have 1 minute left for a round of, so maybe the last question to all of you guys. So which I think is about harmonization, standardization, because you present a number, Emanuele, Sanne, Paul, you presented a number of interesting tools. The point, so are we getting lost with all of these tools? Is there any international effort to harmonize some of these tools so that we can have a sort of shared language, shared approach? I know this is sort of a utopian question, but
well, can I just answer one question in the chat? Was how do you access the Excel downloadable files? If you go into Minoro, there is Toolkit. It's on the top right. You can download it. It then is in your system, and you can adapt, use, etc. The other thing, to your point, Carlo, my understanding, particularly with COP30 coming, the recent announcement that the owners of green building certification schemes are going to harmonize their information so that there can be one kind of example of the truth. How you then apply it within your region might vary slightly, but there is a standardization going on, which I think is to be welcome. Unfortunately, carbon emissions.
Sorry for interrupt you, but they just did something around materials vetting, for instance, just announced.
Yes, yeah.
They're announcing today at Green Build Los Angeles, by the way. So this harmonization about how to vet and select materials. Sanne, any comment on your end? And also
Yes, I think it's a question that I often engage in with people. Is this specifically this quest? I talk to people that work in Poland and they want Polish concrete, and people in China and they want Chinese concrete, and people in the US want US concrete. So there's always this kind of desire to have local databases. In the end, all the concrete in the world is made in the same way by burning fossil fuels, and the process itself also chemically emits CO2. So what we like to say is that we should work towards global sane defaults, and whether your concrete is from China or from Poland, it's all made in the same way. So to actually start working with ranges and sane defaults for materials would help us to deviate from the hyper-specificity per country. And I think that will be extremely useful. That's also what we do by using one database for all of our projects. So we use Ökobaudat, the German Ökobaudat, because that's free, open, and transparent. And we use realistic values.
Yeah. Thank you. Now, Emanuele, also you presented how the palette of the tools that you're using dramatically increased in a few years. So is there also an harmonization effort for the digital tools that you have seen?
Sure. Are you able to see my screen, right?
Yeah.
I'll share very briefly. Yeah, I agree very much with Sanne. I showed before how I developed several scripts, and the important thing is that concrete is concrete, trees are trees. When we talk about ecology, health is health. So sometimes, especially in the design effort, I feel that we are adding a level of detail that is not necessary, but also when we talk about climate change and other matters. So all the palette of tools I showed before that are transversal to several domains are based on simplified tools. I will never be able to be a consultant, or if I would use all the database and have to put my head into that. So I guess that there is an effort also an academic level of break the notch, but probably it's possible to act qualitatively, which at the end is what makes more impact.
Thank you, Emanuele. So thanks so much again for everything. Thanks for being with us today. Thanks for your amazing talks, Sanne, Paul, and again, see you in. We are taking another break, say lunch break, let's say, and see you in 1 hour at 1:10 p.m. Central Europe time. So stay tuned. Thanks so much again. Have a great day.
See you later.
Bye. Thank you.
Bye-bye.
Bye.
So welcome back again to the second part of this crash course on regenerative design in digital practice. A couple of information. Yes, the recording will be available for all of the registrants after the event. Not the day before, probably. Sorry, not the day after, probably, but give us a bit of time. But we will make it and we will share it with you. You will be able to access the recording with the same digital code you use for the registration. And second point, yes, we're also collecting the Q&A and share with you after the call. So thanks again. Welcome to the second part. I'm passing over to Emanuele Naboni for introducing the next session. Enjoy.
Sure. Yeah. So this morning we had a chance to talk widely and specifically about carbon and also ecology. And this session reflects this array in the sense that I'm very excited to have Verena, Eleftherios, and Jens speaking about Rhino Ecologic, and we will have also a demo. And following to that, we will have also Emily speaking about parametric mix design and circular economy. So I will not take more time from your presentation, and we handle the mouse to the team.
Okay, thank you so much, Emanuele, Carlo, and Christine for setting this session up. And thanks for inviting us and everyone else for joining and your interest. So what we will going to be showing you in the next 30 to 40 minutes is a new tool that we have been developing at McNeel Europe. McNeel is a software development company. You probably know us because we develop Rhino and Grasshopper. But in Barcelona, in our European office, we have an R&D team, and we also participate in research projects. And we do so in relation to these research projects, we also develop some additional tools on top of our frameworks and open APIs. And the latest tools that we have been working on is called Rhino Ecology. We have not released it yet. It's an alpha version at the moment. So we have a few beta testers, and we just want to show you what we have been working on. And if you're interested, it would be great also to have you in our group of testers to give us some feedback, and also, yeah, to learn from you. We would like to learn from you, and also now we would like to introduce you what we have been working on. So the session is called Introducing a New Ecological Simulation Framework for Rhino and for Grasshopper. I'll introduce my colleagues here as well, Eleftherios and Jens. Jens is a computational ecologist and also developer. Eleftherios is an architect and a developer. We are working in the R&D team, and I'm leading the R&D team. And my background is, I've been working for McNeel since more than 10 years. My background is also in computational architecture. Well, a little bit how we thought to structure this session, the seminar today. We will introduce you Rhino Ecology. We will introduce you to ecological modeling, which is really a part of biology and ecology, which doesn't come so much from computational design. It's a very specific expert field, and we will have Jens here explaining us more about it. Then we will give you an overview how the tool looks at the moment, and we will also try to demo you some of the examples that we have prepared, show you some case studies from our users that have already been testing it. And then, of course, it would be great if you have some questions, and we will try to answer those questions. Okay, a little bit, about us. We have been a larger team in the past. We have been working since over 10 years in European research projects. They are funded by the European Commission. They were in the Horizon 2020 framework. Now it's called just Horizon. yeah, we still continue to work in these projects. And these projects, we have been key innovator. And yeah, this is Rhino Ecologic, the tool that we also work on in the R&D team at McNeel Europe. And what is Rhino Ecologic? Rhino Ecologic is an advanced ecological simulation framework, which runs inside of Rhino and Grasshopper. And it is designed to integrate ecological and environmental knowledge into the design process. And what you would get as an output is location and time-specific 3D species distribution maps, as well as biomass and biodiversity analysis results over time and over space, custom to your project, to your 3D models. So the tool, it's sitting a little bit between architecture, urban planning, ecology, and computational design. So it's kind of a joint, yeah, this is where these kind of experts tries to bring these together, and that's where it sits. There have been a few challenges when we try to develop a tool like Rhino Ecologic. First of all, is we had to become familiar with ecological models. Jens will tell you more about them. There are these 2D raster maps, and they're commonly used in ecology. So we had to understand what kind of constraints, what kind of inputs these models need. And then also they run on a larger scale, mostly of the scale of a larger area, in some cases, even a whole country. So we had to understand how we can bring this to a 3D modeling environment, how we can bring this into a smaller scale when you want to analyze, for instance, just your plot or just a smaller part of the city. And there is a lot of complexity involved when it comes to simulating living systems, because you have a lot of data that is, codependent and that also runs over time. So it's a lot of data, and that comes there. We go into the next issue, which is the computation issues. Yeah, we have a lot of different analysis types that we had to set up to make ecological analysis in Rhino possible. So we had to parallelize a few processes and so on. And we had to work a lot on this computational pipeline, and the output that we would get and that you would get with Rhino Ecologic. It's also a lot of data points. And we had to find a way how we can structure this data, how we manage this amount of data, and also how we can explain this data to the end user. So to introduce another level of data analysis for people to understand what's actually happening in your model. So I will hand over to Eleftherios, as he will explain you a little bit more about our data model that we had to set up first before properly introducing the ecological modeling methods, in our whole process.
Sure, thank you for the introduction, Verena. As Verena has mentioned, there are a few challenges that we need to tackle in this process. In order to do this, we had to be quite strict with the way that we structure the different parts of the complex analysis that we're trying to run here. And the way that we managed to structure this is, of course, relying on open expert databases for the different data that we need to consume for in ecological modeling and also environmental modeling. The way that we structured the actual processes in 3 blocks, of course, there is the 3D model that's imported into Rhino, and the user models directly and interacts with directly. But we also grouped together a bunch of environmental analyses that support the ecological simulation. And these are packaged together in the environmental model. These contain solar, soil simulation, precipitation, and so on, which generates data that feed into the ecological model that runs over the years to produce the metrics that are being outputted by the process. And of course, the way that we need to manage this data very carefully so that the process is quite structured and it's running smoothly and in nice computational times, is that we need to map this model into a volumetric data model. In this case, we're going to see in a bit, we're mapping geometrical data, environmental data, and ecological data. And of course, because of their structured nature, we can use them quite efficiently and store them in training databases for any design optimization or predictions through the use of data analysis, exploratory data analysis, and also machine learning insights. A bit of a closer look into the volumetric data structure, or how the data are being contained within the application. We managed to rasterize the volumes of the models through voxels, so binding the space into predefined extents of space. And we treated this extent of space as a singular point where we can add attributes to. Of course, these contain things like their position in space, their extents, and so on. But they also include geometric attributes that we derive from the models, such as inclination, environmental attributes, such as what's the soil type and the soil depth of this particular place is, and also solar exposure. And lastly, all the spatio-temporal attributes are also mapped as attributes as part of this voxel, creating this quite deep, let's say, data structure for storing this data. Additionally, we do care about adjacency between the voxels. So we store the voxels all together in a graph structure, in a three-dimensional graph structure. So at each point, we can map the relationship between the different voxels and see how they interact during the ecological and environmental process. And due to this nature of the analysis and the voxelization of the data structure, we managed to accelerate quite a lot the processes, both on the voxel level, but also on an analysis level. That means that we can find the dependencies between the analyses, run them in parallel, and also run the processes for the actual data in parallel too for each voxel.
Okay, and now we will, as Eleftherios explained a little bit more about the data structure, Jens will give you an insight about the ecological modeling processes.
Yes, thanks, Verena, for the introduction. So we talked, our main aim is to model ecology on architecture. And Verena, can you go to the next, please? Because here you can see how we ecologists usually view the world. That's a typical way of analyzing data and making species distribution maps. So this is a statistical modeling technique. You take abiotic factors like temperature, rainfall, and so on, and predict where a species may live. So on the left is, for example, the plant species richness map for whole of Ireland, or in the middle, the distribution or the predicted distribution of golden jackals over Europe. So it's a statistical model. It takes a lot of data, and it doesn't really give us a lot of temporal information. So it's quite a static view. It's quite different from what we just heard about voxel mapping techniques. This is a bit of the starting point that we started with. Verena, to the next, please. And here's already with a sneak peek of a preview of how the model works. Because we do not stop at the habitat suitability modeling. We instead do first a general suitability modeling, saying where can a plant in general live, where is it able to live, but we add a process-based modeling step on top. That means we do an individual-based model. We model individual plants, let them grow, compete, and so on, and get a whole plant community back. What we achieve with this is, first of all, a community, an ecological community that varies in space, but also over time. It changes over time. And the biggest step maybe here is that we go into a really small scale and into a 3D world. So the maybe biggest step is connecting it with the voxel models we showed before. Verena, next. Thanks. So I try to explain what the model is actually doing, but I will go through it as quickly as possible because we want to show the live demo later. So what the model does is it takes a 3D voxel world and simulates the plants living in it. That means they germinate, they start investing into into growth and into reproduction, produce seeds. At some point they will die. And throughout this, they grow within and also across voxels, and they shade each other. And this causes a competition for light. On top of that, there is also a habitat suitability. So seeds only germinate when the soil type and the depth of the soil is sufficient, so they can only grow in specific parts of the world. What I should also say is, as an individual-based model, it is stochastic, so model results will change from everyone very slightly, mapping the real-world variability. And what's also important is we have annual time steps, so we do not model the seasonal change or the change over days, but over years. I hope that's sufficient. If you go to the next. I quickly show also the habitat suitability model as one of the examples. There's also other models inside our model, which is about resource acquisition and light resource allocation. But I just show the habitat suitability. So we use the USDA soil texture triangle as a basis that defines what kind of soils exist depending on the grain sizes. So you have sandy soils, you have clay, heavy soils, and every plant can only live on a particular set of these kinds of soils. So some require heavy soils, some are very drought tolerant and can live on sand. That's basically the basis of how the habitat suitability works. And then we do the process-based modeling on top afterwards. So if you go to the next, I showed you what we ecologists usually watch the world, this 2D map rasterized. We do now the modeling part in 3D. We take we talk with the volumetric 3D model, exchange data, getting it from the environmental data from Grasshopper, do our simulation and put it back into Grasshopper so that the whole model and the modeling results land right on your desk. And yeah, I think that's the basis of the modeling.
Yes, thank you, Jens. Great. If you have questions to Jens, then after this session, okay? So Rhino Ecologic demo. So I will just show you a little bit how it looks like. This is the interface of Rhino Ecologic. So we have a few example projects that you can already, or example Grasshopper definitions that you could already use to start using the application. Then we have a few tabs. We have a parameter tab, a project tab. We have analysis tab, data tabs, visualization tabs, utilities, and also statistics and a species library, which is the last tab. We just recently added that. So you can also define your own species, custom species, and use them for the ecological analysis. There are a whole bunch of functions. We won't have time to go through all of them, but there is a documentation in progress. So we try to release a user guide for you where you can read about these things. Okay, so just the basic setup. I will just flip through that and then try to also show you that in Rhino. There is one component which is called create your project. And then this is where you can give your project a name and you can define a location by the longitude and the latitude. And then you just insert a geometry. And it can be a mesh geometry, it can be NURBS geometry, it can be a sub-D BREP geometry. And this is basically the project. And then you define the size of the voxel cell, which is the size of your data model. In our case, we defined it in 1 cubic meter. So it's set to 1. And then you can see also that the project is divided into these little cubes. Another function which is interesting is that you can also define biophilic areas. So if you do not want to analyze the whole project as it is, you can just set a bounding volume around the areas that you would like to analyze. In this case, it's the roof. And then also some part of the exterior areas that we want to look at. And then you add another component, which is called the run ecological analysis component. It doesn't just run the ecological analysis, it runs as a backend service a whole bunch of analysis. And we can see here what kind of analysis they are. It runs the soil depth analysis, soil volume analysis, precipitation analysis, solar analysis, and also biodiversity analysis. And in the biodiversity analysis, we have a lot of different sub-analysis that I will introduce in a second. But the component runs by toggling basically from false to true, and then it takes a little while, not too long, and then you would get these kind of results. So one result that you can then also with standard Grasshopper components, for instance, the gradient components, you can visualize those. So you would get, for instance, here a solar analysis of your site. You can customize this analysis by introducing the day or the time period that you want to run these analysis for. And then you would get in each voxel cell a value for shading, light conditions, which is an input also for the ecological analysis. You would also get an input on the biophilic areas for your soil conditions, soil depth and soil type and soil volume value. And then you would get the output for the biodiversity analysis. So in this case, we're showing the plant volume, how much volume you have in each cell. And you can actually add here the time step. So you could skip through the years. We have yearly time steps and see how the greenery or your plant volume changes over time. And you can visualize that in your Rhino canvas. You can visualize it, but there's a whole bunch of data behind this visualization. So you can get for a timestamp, you can get for each voxel cells all the species that are actually in these cells over time. You can get per species the biomass, also how many times they occur. We call this abundance, and as well the plant volume. And there is a visualization component where you could just do this all at once. So yeah, you can just set your analysis type or the attribute that you want to visualize and skip through it. This is, I'm showing this slide because it shows here that we disabled biophilic areas, so it runs automatically the simulation on the entire project. Okay, and then you can generate these kind of plots. You can get a precipitation plot, the light conditions plot, daylight solar, the soil conditions, and also the biodiversity analysis. And another interesting part is that you can change with the voxel size, you can change also the resolution of this data. Maybe Eleftherios, you go through that, these, and then I will change my screen and go to Rhino.
Of course. So as mentioned earlier, we generate quite a lot of data fresh out of the simulation as raw data. But what we have also implemented, and this is not part of the current release, is further data analysis on the data that are being exported. So there is an additional component that you can run some post-process on the actual data that are being generated through the simulation to understand what's the impact on the actual place or model that you're using. The process is quite simple. You run the analysis similar to how you run the ecological analysis. And then you can also use our built-in component to visualize as graphs straight into Grasshopper. If you could go to the next one, please. So what are the graphs in this one? Most of the time, most of the graphs that you can see are associations between the timestamps and also the different attributes, such as the sum of the biomass or the mean biomass over time, to see how for each species, the biomass changes according to the conditions of the site. And also, if you could go to the next one. We also produce a correlation map for a particular year that shows what are the correlation between the different attributes that we have in the process. That is the correlation between, for example, the soil depth and the solar analysis to the biomass or the sun biomass and so on. All of those, you can get them in Grasshopper, so you get them as results on this graph previewer that we have created alongside, which you get where you get the total biomass per species over time, the mean biomass per species over time, the voxel occupation per species over time, and also the correlation map as mentioned.
Okay, so maybe I stop. Thanks, Eleftherios. I stop and I show you this in Rhino. 1 second. So I hope you can see my screen. Yes?
Yes.
Okay, great. Okay, so we have prepared a few test files for our beta testers. So there is one project which is called Tiny Houses. So this is a tiny house project that you can then, here in this component, that's a sample definition, right? There is the create project component, and here you can just input the geometry. If you see, we have already inputted it here and run the analysis, which here you can see in the log file if it runs successfully. And now I can just flip through and show how you can visualize the analysis. So takes a little while, but here we have the solar analysis. Precipitation analysis should work in this version as well. This is where water hits actually the project. Here we have, the biomass analysis, and you can go here with the time step. Takes a little while, but you can slide through the project, through the years, sorry, and see how species start to grow on your empty plot. And this calculation, of course, considers light conditions, water conditions, and soil conditions. Okay. What is interesting here as well is then you can just connect a panel. For instance, the biomass, you see the biomass per species in each cell, and you also see the name of the default species that are in the plugin. We have one default plant library that ships with the plugin. And these are the plants that are in this default library, but you can also connect your own custom species library. I show you this definition quickly, where we actually have the biophilic areas as well enabled. So let's see how this looks like. Okay, so you can see that now only the areas are considered that are basically, selected. There is this bounding volume around those areas, and they're used for the calculations. So here we have the soil conditions. And again, if we check, for instance, the biomass, this example, we will see the same kind of output that you already saw in the PowerPoint presentation. We can skip through the time steps and see how these species start to grow. And probably some of you now wonder, they're probably also growing in height. And in this kind of simulation, we do not visualize that, but there is another component that I will show you. Second, which is where you can get your voxels. This component here, it should be in the utilities. It's get plant voxels. So I always get the voxels where I have plant biomass or plant volume in those. And I can actually select those and then also time steps through the years. I can skip through those and I see actually how plants outgrow these voxel cells. Just to remember, they are 1 cubic meter. So here they are going up to 3 meters. And also in our custom plant library, we do not have trees in this custom plant library. Jens, maybe you can say a few words about the plants that we have in this custom plant library, that are more or less working on a global level, and yeah, because you configured them.
Our default library, I think you mean. So we have a few common urban plants. Achillea is one of them, a few grasses. So things you can, at least in Europe, find in every city. And if you would do it in Australia, you would find a grass species that is very similar but has a different name. And so it's basically for urban areas a couple of pre-selected plants, but we can also define our own plants, which is, I think you want to show next, or is it?
I think we stop here because we have 10 minutes left, and I really have a few slides to go through, and then also the questions.
Okay. But because there is a few, I saw already in the question and answer, yes, you can define your own plants. You would need a little bit of ecological knowledge. We try to keep it as simple as possible. But yeah, you could in principle.
One second, I share again. I have actually this answer here as well. So in this example, you can see the run ecological analysis custom library. So we configured a custom plant library, and I put the absolute path to this library that I downloaded. It's my download folder. And then, yeah, I can use those. Okay, then let's jump to the case studies. So we have been working with a few people since we actually put a prototype together. We worked with people from MTech, from the Architectural Association, which is really great. They do a lot of computational design and optimization. It's run by Milad, and he's actually the developer of Wallacey, one of the developers of Wallacey, which is a multi-objective optimization plugin for Grasshopper. So we configured for the students a custom plant library for their project, and they were able to run some analysis. We explained them how it works, and they're also using it in their projects. And they also hooked it up with Wallacey to actually optimize a form of a new design that's optimized for biomass, to get more biomass. Well, that's possible because it's a very data-driven method to use these multi-optimization methods in Rhino and Grasshopper and design in general. But also we provide a lot of data as an output with Rhino Ecologic. So this was actually helping them to connect these data sets and doing these optimization processes. Then we also worked with Henning Larsen together on the Falbite project, which is Copenhagen's first all-timber neighborhoods. So we ran some analysis for them during the process, also to test it, also to see what they say, and they gave us a lot of good feedback to develop Rhino Ecologic in a certain direction. And then we also tried to connect it to Rhino Lens, which is like a plant visualization tool for Rhino. It has a whole bunch of other functions, but we just accessed that function. So we gave them the data and the location, and they were able to map these 3D plants on the project. Then we presented this in a few workshops and conferences and have some beta testers from different fields. So if you want to sign up as a beta tester, you can just take a picture of this or take a screenshot here. And it would be great actually to see after the seminar more people in our list, and then we can send out the information to you. So you would receive like an installer that's time-bombed, then quick start guide, installation guide, a few examples, and yeah, that would be great to hear your feedback. So thanks a lot for your attention. It would be great to hear some questions.
Sure. Thanks so much, Verena, Jens, and Eleftherios. Great presentation, and it was very dynamic in a way. So the orchestration was very successful. I have some technical question about it. The first relates to how that consider in the making of the biomass also the thermal stress coming from excessive radiation. As we know, most systems above a certain temperature begin to fall into drying and then into dying eventually with effect as production of increase of temperature and so on. So how the system is taken into account of the thermal stress, the possible thermal stress?
Maybe that's a question for Jens. How do the plants actually react, or how is this part of the model that how plants react to thermal stress?
So they directly react to light energy coming in, but that's only the resource. So they need these light resources to live and invest it into biomass. The temperature itself is not really in yet. I guess there will be more question about what about this, what about that. We should also have things like wind in it, proper drought modeling. Well, since we are just starting, there's a lot of things we could further incorporate. Thermal stress is a very difficult one because it relates directly to the water that cools down the system again. And these two in conjunction, that's would need a physics PhD as well, I think.
I'm asking because this morning I show a system that somehow address those components, but it's surface based, and that leads to my second question about voxelization and time of computation. It's a fast tool, or and why did you decide to go for voxel and not for planar development?
Okay, I answer first why we go for voxels, and then Eleftherios, you can talk about maybe about how we optimize the speeds using voxels. We decided to use voxels because these ecological models and also the species distribution models and habitat suitability models, they're raster models. And they're working 2D. And then if you have a kind of free form or any kind of shape, also terrains, they are really free form. To map these rasters on these shapes is actually really difficult. And so we decided to go directly from these raster 2D maps to voxel cells to have a volumetric data model. So we can store not only the voxels of the exterior envelope, but also voxels that are inside. So there's a lot of possibilities. If we go back to the plugin, we can choose actually if we want to select the exterior voxels or if we want to select the voxels of the exterior envelope or the interior voxels. So we can map data in even the voxels that are in the air. We could map pollution values in those. So we have this massive data model with data from the environment, from ecology, from even we have some geometry data in those boxes. Yeah. So at the end, you have a structured data frame that you can use also for statistic analysis, machine learning purposes, and so on. So this was really important. And if you just map it to mesh faces, it's different. And Eleftherios, maybe about the speed, if you want to.
I think one thing to note here is that in the visualization that we've shown, it seems like it's actually just on the geometry, the voxels, but it actually is not. It's a whole data structure that is comprising like the whole volume around it. So in a way, it's a way for us to move away from boundary representation to a more volumetric model. So also solar data and so on, like environmental data, we actually map it to the whole exterior environment in a way, as in modeling a microclimate, as opposed to just the surface. It's just a method of visualization that you see here. But regarding the time that it takes, yes, of course, it's voxels are fairly time-consuming when it comes to, and computationally costly when it comes to computation. But because of their nature, we managed to implement a lot of acceleration structures, so we can calculate all of those in parallel for each voxel. And also we do quite a lot of neat tricks behind the scenes, such as dependency identification, so we can know which analysis score depends on what, and we can run that asynchronously and in parallel as well.
Yeah, and then also the voxel model is it allows us to actually understand what's going on in the neighboring cell, because we have this graph data structure. And for instance, if you want to simulate how plants grow in 3D space, they need to know, do I actually have resources in the neighboring cells without having started to grow there? So this model, this data model, allows us to actually incorporate that graph knowledge in, and have stuff growing in the on your project.
Well, congratulations for these spectacular developments. I guess that you will find several testers. Thanks for sharing your code. I see that you have already real-time answered so many questions. So thanks for optimizing your presence. And lovely. So if Carlo has more points or question.
No, I think you really covered a lot of topics. So you really provided a very comprehensive overview, and also addressing the specific questions in the Q&A box, which is also interesting. So thanks also for the questions. Some of them were really straight to the point, like also how to connect the effect of these tools with the carbon impact and so forth and so on. Very interesting.
Okay,
thanks
great.
Again.
Okay, thanks. And thanks,
so much.
Eleftherios, for doing everything at the same time. And thanks for the invitation. Okay, enjoy the rest of the day.
Sure. Also, just to mention, this morning we tried to map a little bit what is the panorama, and we see obviously that there is a big gap within the ecological modeling field. So thanks for trying to fill the gap. So we have already online Emily Scoones. She's the head of digital innovation of buildings in Ramboll. And there is a certain shift in topics. And this perhaps is the beauty of this event, the diversity and the integration of different means. Emily, I'll let you introduce yourself, and the screen is yours. Thanks so much.
Thank you very much, and thank you for the invitation to be part of this event. Good afternoon, everyone. As mentioned, my name is Emily Scoones. I'm head of digital innovation for buildings in the UK at Ramboll. I am a structural engineer by kind of background, but I kind of went through sort of process with sort of computational design and sort of learning coding throughout my career that's kind of led me into a lot of different spaces, including, developing software in some spaces and, seeing how we can leverage computational design in different ways to kind of help to support our design process. So I've definitely branched out from just being a structural engineer anymore and have done some stints in building services, and luckily this being part of this world has allowed me to kind of venture into lots of different areas. So that's been really exciting. And today I'm going to speak to you a little bit about kind of parametric design and how we've been utilizing it a little bit, and show you some examples of things that we've created in our sort of decarbonisation journey at Ramboll, but also with a little bit of focus of circular economy, both from the idea of reusing individual elements, but also trying to reuse buildings as much as possible. So a broad term of what circular economy might be. So yeah, we've been on a bit of a journey of sort of creating parametric tools, and they definitely kind of started off in the sort of realm of trying to automate some of our processes that we've been going through to mean that we can design faster, be more adaptive to the way that we're working with engineers and architects. And a lot of what we've done has been based in the kind of Rhino Grasshopper environment, which obviously is a natural kind of opening to that sort of parametric sphere. So on the left, you see a tool that we've developed that's for sort of that early stage massing, which allows us to kind of very quickly draw in floor plans and things within the Rhino space, and then automatically using parameters in Grasshopper and actually a human UI interface in this case to be able to visualize it, but also to start pulling out kind of key metrics for us. Obviously that started some of the structural ones, but obviously embodied carbon is becoming one of a key thing for us going forward, but also allowed for us to move away from some of the, fun spaghetti that you see behind the scenes of Grasshopper, but also to allow people to kind of use the human UI experience to use sliders. Similarly, we've been looking at that a lot in our kind of facades area, where we have similar kind of tools that allow us to parametrically sort of play with different build-ups, looking at the glazing, the insulation, the different facade kind of type, whether that's stone or brick, and really able to start to kind of pull out that sort of structural information, the deflection criteria, but again, also the U value. So it's this sort of holistic design approach that allows us to incorporate, the factors from both the services, a building physics, a facade, structural element altogether. And one example starting to move towards are kind of the ones that I'm going to explain in a little bit more detail of kind of what's going on behind the hood, is a tool that we created in our civils department, and actually I think ties quite nicely into our previous presentation, which was really exciting to see what the kind of ecological developments are within Rhino are. And this was a very early stage prototype, but for our civils teams, who the sort of problem statement is, when they start adding in civil structures like swales or, rain gardens and capturing water, what impact does that have on the sort of biodiversity net gain? And this is kind of following a very similar structure of drawing in Rhino, but allowing that quick speed and a sort of very quick kind of human UI element to sort of see the impact. So I'm quite excited to introduce them to the ecological tool to see how they could start combining the two, again, to kind of build into that more holistic design. But moving on to, I guess, more of our circular economy piece, and the first tool that we'll deep dive a little bit more into is our kind of steel reuse sort of prototype. I wouldn't say we've taken it to maybe the full level that we want to, but the concept behind it is that if we had a series of sort of stock elements, whether that be from an existing building that we're looking to try and repurpose, how can we take that and use parametric and kind of computational design to look at a new building or and build with those existing components that exist. And this is not something that's new. There's lots of elements of, Hook Park have done some cool stuff with trees of, building structure out of their kind of PEP trees shapes. But I think, there's a few people trying to do this within the sort of more mainstream sort of structural realm. So that's the kind of problem statement. And what we needed to do is kind of to work out our sort of workflow around how could this work in practice. And at that point, we were kind of working with a contractor to define, what beams and or steel elements did we have that we could utilize from the existing building that was going to be demolished. And there was a few factors at play at this point. Like, we didn't know how many of those elements were going to be able to be reused after they went through the kind of structural considerations of testing, etc. And similarly, these were from, an initial survey while the building was still standing up. How many would be potentially, you know, have some impact to them while they were being demolished, for example. And so we needed to develop a process that was going to be really quickly adaptable to any of these changes that may happen as we go through the process. So we developed kind of a very simple element spreadsheet, which would allow us to kind of parametrically play with those as that data came through. And then similarly, we needed the information for our new building and what did that look like on a structural consideration. So we were using, in this case, a Tekla structural designer model for our sort of geometric kind of piece, which we'd done some initial analysis on. Then what we needed to do is be like, how do we start to build in other constraints, not just the sort of structural constraints around like how deep a beam needed to be in order to be structurally sort of sound in it, but also, you know, would there be architectural constraints, for example, like, you know, all the roof beams being the same depth so that there would be that architectural rhythm. And so starting to kind of consider at this stage, you know, what are the other aspects that we might want to optimize for, maybe not specifically for this project, but in the future, so that we could build our infrastructure accordingly. And then develop the tool itself that would take, based off both those constraints and what existed, which pieces of stock could fit those constraints, and therefore then also what did we need as an output in regards to a model that could then go through to even more detailed analysis, and, you know, an idea of which elements could go where. So we did this in Grasshopper, and I'm going to do this slightly scary thing, which is to go to Rhino Grasshopper right now and run a sort of, just to kind of, so you could see it a little bit live going on. So the idea here is we started off with this kind of spreadsheet, which, you know, isn't anything sort of too fancy, but, you know, kind of gave the idea of all the sort of information that we were going to get from the contractor. And that allowed us to kind of import it automatically into understand what our kind of stock elements are, which are all of these currently gray objects right here. And then also see, this is from our Tekla model being imported from the output that you can do from that, a CXL file, automatically into Grasshopper. So they're all live linked, but I'm going to try not do too many live changes. But the first part is that, you know, from those, hopefully this works, okay, is that we were able to start to see, okay, if we have elements of a certain depth, so all of these elements in yellow here are of a certain size depth and had been assigned for certain types of load cases, and similarly the red ones were for a different depth of beam that had a sort of stronger load case, as you can see. And then you had all of these ones, and similarly there was a green one here. So you were able to kind of look at it as the sort of depth. And what it would then do is start to try and assign those into each of those elements. And we were able to, and there's no pretty way of looking at it, it's a very big Grasshopper spaghetti piece of how we assigned certain parameters to, you know, constraints to some of these different beams or columns to define which depth they could go to. So as you can see here, all of these beams were needed to be the deeper beams that you can see here. And so what we were able to see is like how many of these existing elements were being used to meet this construction. And what we're able to do is to kind of, I'll switch it around, is that we could then say, actually, we want these columns here to also be in things. And you can see how it instantly changes to be taking up more of this existing set of stock elements going forward. So this is it looking at the depth, but actually what we also needed to be able to do, so that first part was more to kind of help us to validate that it was doing what we were expecting it to do, is that then, okay, how do we then map each of these elements into the ones here? And so there's a sort of color-coded system here, and you can see what it's doing is that it's taking each of these stock elements, it's trying to fit it into where it can fit here. It then cuts that beam or stock element at that point, and then is trying to utilize as much of that beam as possible. So you can see by the kind of gradient of elements here that it's cutting each beam into as many chunks as possible, and then that little gray area is obviously any bit that's kind of left over and not usable. So it's trying to use this as much as possible as fitting the kind of constraints, and then it allows us to start to then, okay, map these two pieces together, which is like if it's got this code, you can find the code within the model to then find out where each of those elements are being used. And so this was a kind of prototype that we developed to start working on how this system could work. There are definitely some features and functionalities we'd look to try and develop a little bit more, like live link around how it does optimizes for sort of structural constraints a little bit more, and also certain other fabrication constraints. So at the moment, it sort of assumes that you can cut each beam perfectly, but we kind of want to see how that might develop by working with contractors. But yes, it's a sort of early prototype to start to understand how we could use that kind of parametric ideas within that sort of circular economy space. So I'll hop back to the presentation now. So that's it, kind of looking at how we can look at circular economy at an element level. But actually what we're also really interested in Ramboll is to look at that sort of whole building reuse. So how can we leverage parametric design to really test every building, and the phrase we say in Ramboll is give every building a voice, and make sure that we're kind of really testing it to make sure that we're not demolishing something that we don't need to. So we do this in a few ways. You know, sometimes it's about creating sort of parametric platforms that you see on the left, where we're able to kind of build in the constraints around the existing building, what's the load, but what would be the impacts on the foundations, and then test, you know, if we build more floors and parametrically be able to play with that, what impact does that have on the foundations? And if at any point those constraints are exceeded, as you can see here, it would then highlight red, and it allows us to kind of guide that process. Similarly, when we're looking at existing buildings, it's like how can we play with the different usages of buildings in order to, again, work out what structural load could we save so that we could add more floors, but also in its energy use going forward. But the tool that I want to show you in a little bit more depth today is a tool called Zebrafish. These names do have like acronyms that mean something, but the idea is that this is looking more at our building services area, that if we have an existing building, how can we help clients to reduce their operational energy? So the traditional method would be that we kind of gather information from about a building, you know, where does it sit in the world, what does it look like, what's its geometry, how does it, what kind of usage does it have, for example. We're then able to kind of create a digital representation of that building. This is not necessarily a digital twin, it's sometimes at a much earlier stage, and so the kind of model is much more representative, but we can link it with metered data in order to make sure that we're modeling something that's representative of real life. And then at that point, we start to understand what are the different changes we can make to that building, whether it be in regards to the systems within it, so the lighting system, heating system, etc., but also of its fabric. So how could we update its windows, glazing, the insulation in the walls, and various different other things. And then at that point, we run a very rapid kind of exploration of all of the different potential combinations, which sometimes leaves us with hundreds of thousands, if not millions, of potential options for the client to understand how they can decarbonize their building and make it either meet standards that we're facing in the UK or look to, you know, reuse that building going forward. So the workflow behind this is that we have a honeybee energy model, which is built in Rhino Grasshopper, and I'll explain that in a little bit more detail in a second. Some standard inputs, which are basically the sort of Excel spreadsheets that drive all the parameters that could be changed at that point. And, you know, that could be, you know, 3 different types of facades, for example, and then it goes through our kind of bespoke, created with a not so pretty interface analysis app that we've created that allows us to run these analyses with the honeybee model, but also various other sort of algorithms that we've created to calculate heating loads, etc. And then use Power BI as a dashboarding instrument to kind of take those hundreds of thousands or potentially millions of results and allow us to kind of analyze them in more detail and take the client through what the impacts are of the different changes they could make to their building. So to create that kind of honeybee model, there's a few different types of things that we have to consider. That existing buildings have a range of fidelity of data that's available to us from the off. Sometimes we have just a PDF and a bill, and that's as little information as we have about a building. But in some cases, we may have existing models that we can leverage. And so through different methods, sometimes it's by using, for example, pollination or building stuff, we then build, different scales of model to match the fidelity of information that we have. If we're building it from scratch, some of the things that we do is, for example, if we just have that PDF, is to sort of build within Rhino these kind of energy models, which builds the different rooms and spaces and assign them the different usages, and use Rhino and Grasshopper to kind of parametrically build those models, and then use Honeybee within it to kind of come up with the usages of those rooms and the operational energy on a kind of annually, hourly basis. I'm not a building physics engineer, so I'm no pro in this space, but it's one that we kind of do, and I think a few people within the industry do use it. Then we use this kind of standard inputs to kind of define what is our base case, but also what are the different types of different changes we might make. So the differences in lighting, the ventilation systems, heating and cooling, as you can see here, going forward. And then, as I mentioned before, it then runs through this kind of C# created, actually, no, this one's Python. I take that back. Python generated kind of app that allows us to kind of run this like optimization and sort of parametric analysis of all these options. And what this gives us in the end is this dashboard that allows us to work with clients to understand, what are the changes that they can make to reduce their operational energy. So as you can see, we might start with looking at fabric only and say, okay, what happens if we make that change? How does that change the sort of number of interventions that we have? We are also able to embed in, very basic kind of cost and embodied carbon energy, which allows us to start to sometimes see the tipping points of, where does these changes have diminishing returns. So for example, as hopefully it will kind of show here, is that, after you make certain types of changes, actually you don't necessarily get a huge amount of impact on your operational energy for like a lot more cost. The idea being that we can work with clients, and we also share this dashboard with them so that they can parametrically kind of get involved and see what the impact are of changing different options and being able to test that sort of things. And so hopefully you leverage that to show them that they can make small changes to reuse their building, but bring down their kind of operational energy. And we can do this at multiple scales. So sometimes we look at this at an individual asset level, but we can also look at this at a sort of portfolio scale. So for example, at the portfolio scale, we recently did something for a sort of big infrastructure client, which helped them to look at their many buildings in their portfolio by breaking it down into individual or a series of archetypes, which was representative of maybe 80% of their building stock, run the analysis as if they were individual models, but compile them together. And the key thing that was very important there was about unique IDs became very key, and working out how that we could create a system that allowed people to start with different base cases, change lots of different parameters to work out, what they could do, which then helped with their kind of business cases going forward. So that was a kind of quick, speed through of a couple of tools that we're using, sort of the parametric idea to kind of meet regenerative design within Ramboll, and look forward to any questions you might have.
Thank you so much, Emily. That was a very interesting presentation that shows how on daily basis you perform such in-depth type of development. With Carlo, we have a possibility to have an intra-chat, and we were discussing on how the practices, and especially yours, and we believe you're in a segment of your practice, are developing faster. And it can be interesting to see or to understand how do you see, I'm sure by thinking about that constantly, what do you suggest for practices that are perhaps mid or small size in order to encompass or incorporate this type of routines, as if you are a consultant today that are speaking to a community interested in implementing that?
Yeah, it's a really good question, and I think we even face it in sort of the big consultancies. You know, how do we get more people in that sort of smaller team to leverage these kind of tools? I think the key thing for me is that it is a bit of a kind of practice, like it's a muscle that you need to learn, and it's sometimes about really understanding the problem that you're trying to solve and finding user cases that you know are gonna have an impact by trying to take this different approach, and actually sometimes to not start too big. And sometimes it's about kind of being like, okay, this is the first problem, and I would already see an impact if I solve this bit, even if the main aim is something this big, start this big, and then kind of keep building out. And finding the opportunities on projects, I think, is quite key to say, oh, I take a step back and say, actually, I could approach this a different way and try utilizing this tool in a very small part of it, and then seeing how that kind of keeps building. And then, because I think one of the fears that a lot of people have is, will they go down a rabbit hole that doesn't actually lead them to a solution that solves the problem? And so being really clear on what the problem is, break it down into steps and start at the smaller scale and build up.
Sure, fantastic. Actually, we can engage also the guests from McNeel in a small roundtable. As I was curious, Emily, you probably in other presentation we've met some of your colleagues, and there are also developments in the direction of understanding living systems, understanding water, understanding biomass as well. And I was wondering if you can tell us a little bit of what are the, if you are aware, what are the in-house development, and how do you see, for instance, meeting such distant, apparently world, but at the end so close, like your type of energy, let's say multivariable modeling. For instance, do you see at a certain point to begin to consider input from biomass as one of the sliders in your simulation? So how do you see the convergence of these different families?
Yeah, so I think this is one of my favorite parts of kind of computational design in this space, is the ability to start bringing in that holistic picture from areas that you maybe are not your domain expertise. And so I think that's where it starts to become even more powerful. It's obviously gets complicated when you haven't necessarily considered it at the beginning about how you bring this together. But I think spaces, for example, such as Rhino, if you have a few people that are kind of working in it, can start to bring together tools and work out what the interfaces are, then yes, and I would really love to kind of see some of that stuff happening. Like I mentioned earlier, our kind of biodiversity tool, which is obviously very specific to certain elements of design that we do, but where it becomes really powerful is, for example, if we could bring in some of that ecological data, for example, and combine it together. And so that Rhino space is very good. Some of this interoperability pieces that people are developing really start to help us kind of leverage that. And we started doing it, I guess, on a buildings level, and some of the stuff with Henning Larsen, for example, and various different other elements around the business. So yeah, I'm definitely really keen. And I think that's where it becomes really powerful, and where if we start thinking about the outcome of the people that are going to be living in these kind of places, how we use all of that data in a really holistic way to drive the decision making.
Sure. I'll have a small question. Right now I become Carlo in a way, and I'm asking you, or all of you, how much the regenerative paradigms has entered your vocabulary, or how it is pushing perhaps in the development of the tools. Yeah, perhaps we can start with from Verena and then pass through Emily. Yeah. You're on mute, Verena, I think. Okay. Thanks.
Okay, so the question was, how can regenerative design actually change how practitioners work and how it can evolve?
And your digital developments, for instance, or how your agenda is somehow influenced.
Yes, I mean, we're a bit working on the other side. We're working on the software development side. So, of course, the feedback from people like Emily that is actually working on real scale reward projects is very important. There was also a question now in the chat about biodiversity.net gain in the UK, these new standards that are popping up. I think also in Scandinavia, a few countries are now picking up a similar concept. So these things are really interesting for us also to develop and to provide the users a tool that actually can give the right output, that the architects or the planners can have these kind of values or on their competition proposals, and it actually it also is data that we can arise from a real ecological simulation model that's running in the background. So I think this for us, how to apply it in the real world. I mean, we would love to see using people or users using Rhino Ecologic, and also to develop cities that are more addressing the needs of other species during the design process, during the early design process. This would be really amazing, but we're not the ones that are, we don't have much control who's using it and who's not. So, so that's why feedback is very important to us.
Emily, what is your point on it?
Yeah, so I think it's true, like some of it is being pushed by, what is, being asked for, whether through legislation and stuff, changes in, biodiversity rules, or I think so that's a really kind of key, crucial part. And I think, for the existing building space, I think what I'd like to see is more of a proof of why you can't develop it. And so parametric tools suddenly become a key, crucial part of that role, because you're basically proving actually these are all the options that are possible. And if you've really tested everything and it really isn't possible, then you've got your evidence. But similarly, if you've tested something that you maybe in the traditional design process wouldn't have had time to, then at least it starts opening up avenues and potential solutions that are bigger than that. I think the other piece is that sort of mix of, it helps the individual because it sometimes helps them to do things faster. I also think it's very fun, from a personal perspective, but also it allows, again, that more of that optioneering, the ability to kind of react faster. So those are kind of some of the benefits that I think are kind of key messages to help drive people to use these kind of tools more.
Carlo, do you have some remark?
No, all interesting, and again, thanks for your great contribution. Again, I'm always fascinated about the trade-off between how to manage the complexity with tools without investing a gigantic amount of money and time, because this could be also the point. So compared to the results that we are achieving. So in the end, great examples from you guys, both from the digital company side, but also from the design firms environment. So interesting that somehow we are converging to the same direction.
Great. So wonderful to see how the tools can change the design paradigm, where we design for nature in order for nature to provide a set of shared values for human. And it's an important change of perspective. I just joined the International Panel for Climate Change, writing in a chapter for cities, and I will one of the elements I will try to carry to this pool of scientists that oftentimes are really focused on their experiment is this kind of messages. So thanks so much. We're on time again. Greetings to all the guests, and I leave the word to Carlo for the next section.
Yeah, thanks so much. Thanks, Emanuele, and all of you for your amazing presentation and talks. So, great examples which lead us, let's say, to speak about more about other practice cases, really addressing, can we call it regenerative urbanism? Because this is in the end what we are talking about with the next great group of speakers, Nitsan Bartov, Tor, Banke, and Ata Chokachan. We are starting with Nitsan Bartov first. You already learned from Jakob this morning about this PhD program that Henning Larsen is running. Indeed, Nitsan is running his PhD candidate work at Henning Larsen around regenerative urban design and artificial intelligence, and is going to speak about designing regenerative urban environments, also touching based on AI use. So Nitsan, happy to have you on board today.
Thank you, Carlo. Is my sound okay?
Absolutely, that's fine.
Yeah,
Thank
I'm
you.
not using my headphones, so I just wanted to make sure.
Yeah, we are hearing you perfectly. Thank you.
Okay, let me go about sharing my screen.
It is uploading. Yes, perfect. Full screen mode. We got it.
And do you see the presentation or my
No, that's fine. Full
notes?
screen mode. That's perfect. Thank you.
Okay, technology. Yeah, so thank you, Carlo. Thank you for the invite, and also Emanuele. I'm joining from New York, so it's a bit early here. I haven't seen the entire session so far, so I hope I'm not repeating too many things. But as mentioned, I'm Nitsan. I'm an industrial PhD at Henning Larsen in Copenhagen, together with the Royal Danish Academy. I'm an architect in training and computational designer, and I found my way through to work with urbanism and AI, as Carlo mentioned. For those who don't know, Industrial PhD is a program kind of unique to Denmark, where you can stand somewhere in the overlap between academia and practice, and hopefully trying to get the best out of both, work with kind of practice relevance and academic rigor. And my positioning specifically is around the overlap between architecture and AI, two vast fields where I feel like everyone is still trying to kind of figure out exactly where do they meet each other. There's a lot of thoughts, there's a lot of promises, there's a lot of ideas, but this is let's say, this is the space that I'm exploring as part of my PhD. Just a tiny bit on the background of my research. I'm working on regenerative urban design. This is the first part. And then I'm looking into site analysis as what I see as the most crucial part in order to achieve regenerative urban design. And an extraction of this is working with urban data and site data. And then all of this goes into how is AI kind of combining those different things and could help us work with site analysis towards a better regenerative urban design. I guess there was a lot of explanations about what regenerative is. So this is my take on the graphics of this famous graph that goes from sustaining, which comes from the word sustain, and keeping things as they are, into a regenerative paradigm where we actually improve different aspects of the site, maybe regenerate or restore some of the things that were lost through human intervention. But from the perspective of an architecture office, this means quite a lot of things. There is a lot of things that we need to take into account. And we don't even have, like, even if we had the best expert in each one of those topics, it would be super hard to implement not only the topics themselves, but also how they integrate and synthesize. And this is how, this is kind of, let's say, the direction to which I'm looking at AI in architecture, saying maybe AI could be at least one of the things that could potentially help us go into that direction of working with this super complex problem. And the first thing I would say about AI is that the conversation shouldn't really be about AI, because AI is kind of a channel. It's a little bit of an empty vessel to carry data and to allow us to work closer with the data. And I assume that there's been a lot of conversations about data, but I think it is important to take a little pause and ask what is even data? What does it mean? Because I'm working in a 650 people architecture office. We don't have a data analyst in the office. And I don't think that there's many people who actually work with data. Data is a vast field of its own. But it's important that if we talk about data and we try to utilize data, we understand what it is. And if we see the dictionary definition, it is an information output by a sensing device that includes useful and redundant, like it's not everything that I know is not data. Data is actually a very specific form of documentation of reality. And you can even argue about whether it's reality, but it has certain characteristics that would separate it from different forms of knowledge. So data is something that is constructed. It's not discovered. It's not just there. You don't just dig in and the data emerges. It's something that you need to collect actively. It is processual. It is dynamic. It is embedded in social context. It's mediated by technology. So there's a lot of aspects of data that we have to be very aware of before we go and run around and say we are data driven and we're letting data make decisions for us. And AI is essentially technology that is able to, let's say, create some sort of intuition or generate educated guess based on the data that it is fed or the data that it is exposed to. There's the training, which is the vast amount of data that is kind of identifying different pattern, and you can fit it with a little bit more. But what it does is it's creating an educated guess. And if I'm quoting this highly intelligent guy, we often mistakenly associate intelligence with truth. Intelligence is the ability to work with data, to come into conclusions, to solve problems, but it doesn't necessarily indicate what is the reality. And when we're looking at the data ecosystem of the architectural field, and I'm looking from the perspective of architecture office, not even municipality or engineering, architecture offices, they have to deal with massive amounts of data. We get maps, we get reports, we get social data, we get photos, we get interviews, we get, I don't know, soil conditions, climate. And as I mentioned, when you go into the data analysis department to see how do you then work with the data, how do you clean it up, how do you draw insights, the department is empty. We don't have people who are actually trained in data. But it is, I hope, very clear after all the presentation we've seen so far that we should be working with data. So how do you overcome this? Just, you know, as a little bit more background, and I promise I'll get to some demonstrations of AI a little bit later. I promise Carlo as well. But I think those things are extremely important, and I hope this you see it as more refreshing than heavy. But what kind of data do we use in architecture field? I'll split it to 3 different categories. We have empirical data, what is, let's say, the closest that science has come to, I don't know, a digital description of reality. And these are things that are just describing what are the current conditions or what are the past conditions. Data that has been collected from the site and is describing different conditions in a numerical computational way. Then we also have analytical data, which is data that is not collected, but is data that is produced by doing things like simulations, analysis, modeling. So this is data that tells us what could be if we go in a certain direction. And this is predictive, so it's not as accurate as empirical data, but it's a good indicator. And then we have human data, which is what science would call qualitative data, which is usually coming in a format that is less comfortable to work with, like texts, like photos, like interviews. But this is also the type of data that we work with in architecture. There's 2 main ways where do we even get this data. And this was also mentioned in the previous presentation, like sometimes we have a lot of data, sometimes we don't have a lot of data. So there's the data that we access. In an architecture practice, there's data that someone else has collected, someone else has generated, and we get access to it. So sometimes it would be the client that provides us with the data, and sometimes it will be something that we find online. Sometimes it's data that you purchase, sometimes it's data that you negotiate the municipality for, but this is data that is collected by someone else and we need to figure out how to use it for the purposes of our project. And then there's the data that we generate by doing simulations, by performing our own site analysis, by doing our own measurements, by speaking with different stakeholders. So there's the data that we get, and there's the data that we make. And then there's the big question of then why do we want to use data even at all in architecture? Data is a relatively new beast that has entered the architecture field. I would say that maybe 20, 30 years ago, we barely used any data at all. And most of the neighborhoods that we consider our favorites, favorite architecture in the world was built without any use of data. So what is the justification of, making that transition into data? One is that the modern challenges are more complex. The challenges that we face today, they just have too many variables and too many stakeholders, too much money involved in order to not use the data. And data is actually helping kind of compensate to the limitations of our intuition. There is a much bigger culture of accountability. When you do something, you need to be evidence-based. You're using other people's money. You are doing some pretty radical things to the planet. So you need to be accountable for it, and you need to put numbers behind the decisions you're making, the same as happening in other industries. Like in pharma, you have the FDA, and if you don't pass a certain threshold of the data, you will not be approved to do something. And the architecture field is going in that direction. Data actually helps us to go across different goals and optimize. There's all these kind of fun, parametric tools to put in different variables and say what would be the optimum for multiple factors and not one, which is essential for regenerative thinking, where you have to kind of work with, across the board of the different aspects of the project. And then data is actually a really, really strong tool for innovation, because sometimes the data will indicate things that we don't see intuitively. Another reason to use data is just because we have so much data. And if we look at this graph that shows, the blue one is the data that is being produced every year. And, when you produce more and more, then more and more exists exponentially. And if I'm looking at this graph, it doesn't make sense to even start it before 2010. There was so little data available. So I can't even do that graph earlier than 2010. And when you look at the scale of time of architecture, we have buildings that are still being built today that were designed before 2010. So this is a very, very current transition into thinking about how to work with data. And as I mentioned before, I find the most essential kind of data, let's say data work, to be done during the site analysis. And again, as I mentioned before, and as maybe you kind of realize, the ways in which we analyze a site traditionally in architecture, we have a very, very big tradition of site analysis. It's not something new. Analysis is kind of, a new type of word, but the tradition of understanding a site does not involve data. Jan Gale, a little bit, counting some people doing that. So there is the kind of attempt, but working with data, working with big data is not something that we are traditionally trained to do in understanding a site. And this is some transition that we have to do if we want to achieve regenerative urbanism. So basically my proposal in the PhD and what I'm looking at is how do we use AI as our own data analyst, working under the assumption that an architecture office will not hire an entire department of data analysts and train them into what is urban data and how does it differ from what they've worked with in university. They get paid 3 or 4 times more than we do. So working under the assumption that this will not happen within the architecture office, how is it that we can utilize AI to really increase the way that we work with data? In that little metaphor, the data is the worm, and AI is actually processing the data in order for us to be able to work with it. This is going into this thing that we are hearing a lot and we're seeing a lot, this idea of data-driven design. What is data-driven design? I think I'm assuming a lot of the previous conversations were about data-driven design, but does architecture even want to be a data-driven design? Do we put the data behind the wheel and let the data just make the decision for us? This would happen in certain kind of parametric activities where you just fit in the data and you describe what's the process that the data would go through in order to just reveal the design to me. But I would argue that architecture cannot be a fully data-driven design. First of all, because data, it doesn't provide the full picture of what a site or a project consists of. It can feed into what I know about the project, but together with this, there's also tacit knowledge, there's also experience, there's also artistic expression. There's also a lot of those things that are not completely driven by data, and will always be part of the architectural challenge. And that's why I think it's not really data-driven design that we're looking for, it's data-assisted design. We want data to inform us in our decision-making so that we are making better decisions, but the decisions are ours, and data is one part of a huge range of considerations. And there's also some ethical considerations of working with data. Data is a very strong tool to kind of shut down an argument and say, no, but the data shows, so nothing to talk about. But data, and especially looking into using AI as a channel for data, it doesn't represent the truth. It represents what the data says. And the data sets, especially of the common AI tools, they represent what is available and popular on the internet. So when I'm using subjective terminology, which architecture consists of mainly subjective terminology, and I describe something, make something beautiful, make something smart, make something innovative, those things will not come out as what is objectively those things, because there is no objective truth. It will come out as what is most represented in publicly available internet. And I'm more likely to get an image like this when asking for a beautiful building than getting an image like this, even though many people here would agree that this is actually more beautiful than the other one. But this is not, like, the data will not give me this one. And I could argue this is a data-driven, this is a beautiful building driven by data, but it's just not the whole story. There's a lot of people, there's a lot of information that is missing from the data. And then I would even argue, even if we have all the data, even if we have a huge, vast amount, we did a brute force, collected all the data that exists in the world, in architecture, we're not designing for the statistical majority. And I would say that, for example, if we were to be a data-driven, purely data-driven, we would never design handicap ramps, because there is no statistical justification for the investment there's just not enough people on wheelchair. But we are not only focused on what is statistical majority, data-driven, decision-making. We actually need to design for everyone. And those who are not present in the data or underrepresented in the data, we still need to consider them. So we have to be very, very careful when we put the data behind the wheel, because data doesn't show the entire picture. Another thing when looking about urbanism, if every person who wants to open a restaurant would go into ChatGPT and say, what is the optimal restaurant for me to open? They will all get the same answer, because the data will show this is the most profitable thing, but this is just not good for a city. Diversity is good for a city. So, statistical optimum is not what we actually want to aim for. Then there's a question of accountability. And this is Deloitte. They got sued recently for $400,000 because they produced a report that had quotes from papers that don't exist. Papers never came out, quotes never happened. And this is to the Australian government. And the person, it was Deloitte who got sued and not OpenAI. It was Deloitte who were misusing the data, because the data behind OpenAI is language model. It's an LLM. It's not a database that I draw real truth from. So all of those things, they have to be kind of taken into account when we go and start getting excited about those tools. And they are exciting, but we have to be aware exactly kind of where do we put this in the decision making. And this goes back to working together with the data rather than let data drive our decision. I'm kind of against this data-driven terminology. And then from the perspective of an architecture office, we have this think about, okay, what about then where is the creative agency? Like, do I want to stand behind the designs that I'm making, the decisions that I'm making, or am I letting AI make decisions? some decisions should be able, like we should be making them with AI, but some decisions not. But what I'm arguing is that it's not this kind of two-way binary road. It's a little bit more of a spectrum. AI can have a different level of involvement in every decision that we're making. And by being aware of the downsides and the risks of using AI, and I would say maybe using data in general, this could actually apply to data as well. We need in every decision to see what is the placement. Is data making the decision? Is data informing me and I'm making the decision? Is data making the decision, but I'm only validating? This spectrum is something that we need to really get used to as a profession to work with in every part of the decision-making process. So a little bit in how we use AI in the practice in Henning Larsen. There is this, a lot of people think, okay, so you just put a prompt and you get a full building. I would say we're very, very far from this. Architecture is not just one task. Urban design is not just one task. Of course, there's agentic AI that you can split out different engines to do different things. We're pretty far from this. We will get there, but we are pretty far. And what we're looking at Henning Larsen is not how do we eat the whole cake, not how we just kind of delegate everything to AI to just automate the entire process. We're looking at it kind of bite by bite. And there's a lot of different use cases of AI in the office that I'm not sharing today, but I'm happy to share if someone wants to reach out later. I will focus on how we work with data, because this goes back to what I was focusing on this presentation. How do we use AI in Henning Larsen to enhance our work with data? I'm going to give one example from the office, then I'll demonstrate. We had a project in Germany where we got 258 PDFs in German, which was the actual data of the site. And this was an academic institute, so the data is strong, is valid, and we are expected to use the data. But this is a competition. We don't have a lot of time, we don't have a lot of manpower, and we don't even have a lot of German speakers to go through the data. How do you even consider all of this data in the decision-making when you have 6 weeks to design an entire campus? And all this data is available, but what do you actually do practically? It was over 3.5 gigabytes of documents with very, very strong data that should be impactful. So what we used is actually a tool that I really like that's called Notebook LM. I'll do a little demonstration later. Notebook LM takes advantage of the LLM capacities of understanding language, understanding nuance of language, synthesizing between texts, and basically make this collection of all the data that I want to work with, and allows me to communicate with the data in my own natural language. I know that this capacity is kind of possible in ChatGPT and Claude, like all of those tools are slowly kind of catching up to each other, but this one stands out drastically. It's a tool from Google because it doesn't hallucinate as much. It doesn't just try to provide me with like a satisfactory answer to my question. It is a very, very strong RAG tool that goes into all of the data that I've put in and kind of confronts my different questions with the data. The importance of this tool is that you can use your natural language. And this is exactly the barrier that exists between architects and data analysts, because there is a language of data, but we don't speak the language of data. We speak our own language, and AI is actually able to bridge between the things that we can work with and all of this data that we want to work with, but is sometimes a little bit too intimidating, or we just don't have the time or expertise. And for that project, we actually used the data to validate a lot of the decision-making around programming, around biomes and planting, around distances from metros and distances from a lot of the decisions that were purely data-driven. Like if I need something to be 35 meters because there is a certain microscope that goes there, this is a data-driven decision. This is on the scale, on the spectrum. I'll put it all the way in the data. But if it's something that is going by what would make people want to spend more time outside in the campus, there is some data about this. But this should never be a purely data-driven decision. People are different, times change. We plan now, this will be built in 20 years. Am I going to make the assumption that by the data that I have today, this is what's going to be right for 20 years from now? But this discussion about like where in the spectrum the data stands in every decision was a very strong characteristic of this project. And and I think needs to be a very strong characteristic of regenerative design. We actually mapped all of the different data that we have for that project. That's maybe a little bit more less interesting, but what's really interesting is that we can find through LLM, which is a very, very deep kind of nuanced language understanding machine, not only what was directly mentioned in the data, which will be placed in the more data-driven decision-making, but also what is implied. Also what we can infer from looking at the data or from looking at connections between different data, and then we have the agency to decide how much we want to treat this in the project. So as a last thing, I'm going to do a little demonstration. Do you see my screen now?
Not yet. And by the way, we didn't understand the name of the tool that you spoke about.
But it's okay because
Max Campus.
I'm going to do it right now. That's
Max Planck Campus. Sorry.
Can we see it now?
Yes, we see a screen now.
Okay, so the tool that I showed, and as a general statement, I'm much more an advocate of using existing tools in architecture practice than developing tools. I don't think we have those skills. In other places, in Ramboll and companies that are focused on this, yes. My approach is like, let's look at the existing tools that are continuously developing and evolving and see how we utilize them in the best way. And my PhD is focused on creating this framework for what is the best utilization of the existing tools. And then whenever a new tool comes out, we can already use it because there is some sort of a framework for it. But what I want to show is this tool called Notebook LM. I'm going to start a new notebook. And for this event, I have created a fake project. The project is in Dubai. I've made a brief for the project. All of this with AI, of course. The brief follows the pattern of what a brief looks like. And I've also collected a lot of data about that area in Dubai. For example, I have soil resource appraisal. I have the different building regulation and building code. I have master planning guidelines. I have technical guidelines. This traffic report, this represents in many ways how project looks like from the perspective of an architecture office. We get the brief, we get a bunch of data, now go in planning. So I can take all of this data and throw it into Notebook LM, and then I can start asking questions to the data. And let's say I'm completely new and I've only started working on this project right now. There's, actually another interesting thing is that I can add links to websites. So I've also collected some websites with other sources. Now I have this database on the side and I have this chatbot and I can start asking questions about the project. So one thing, let's say I'm new to the project. I just joined. I get all of this. Make a table with all the key numbers for this project. Site area, GFA, target, parking, public space. I'm just getting familiar with the project. This will look mainly at the brief. It knows all of the different, it has read all of these different, what's it called? Data points. But then I'm getting here a really nice analysis. I get this is the site area, this is the GFA target, this is how much parking, I'm taking in all of this data and I'm processing it and I'm bringing it back to me in a way that is very, very digestible. And I can also say if I want it as a table, I want it as bullets. Then let's say I have specific questions throughout the project that I want to kind of test with the data. Let's say I want to make a shading canopy feature on the main street. Give me all the things I should consider based on the data in clear bullets. The range of questions around this tool can really, really vary. It can be very, very general. You can confront different suggestions. Oh, I have actually a good idea. So I need to consider the building code. I need the accessibility standard, RTA approval, master plan alignment, submission. This is giving me a really deep, let's say, answer to my question. And the beautiful thing around this is that each answer actually gives me a way to link back to what is the source that it's relying on. So I can validate myself if I think this is a legitimate answer or not. And if it says, okay, I need to consider climate resilience, what are you basing this on? And then showing me here, mandatory seismic design requirements, building over 3 stories must be designed to withstand seismic activity, wind load calculations. So this is actually part of the requirements of the Dubai Building Code. And Notebook LM has told me this is something that you need to consider if you're going to do this canopy shading. Then let's say I have an idea. I want to collect some functions and make a 60-story high rise in the center. What does the data say about this idea? There's a lot of tension, and okay. The idea of this challenges directly contradicts the established planning parameters for the area. Planning and height restrictions, maximum height 20 floors. Conclusion exceeds the standard and special zone maximum. So this has actually told me the data indicates that this idea is not good. I can still go ahead and do it. I have the agency to make decisions, and I know about some competitions that actually suggested something different than the brief, and they actually won, and they made, you know, some good or bad impact. But what this gives me is the ability to see very clearly in my language, without being a data analyst or a specialist, what does the data say? I'll give one last example and say which type of trees I should plant for shading in the main streets. And this one, I happen to know that it doesn't exist in the data. I didn't put in a list of local trees. So when I ask this, what I'm expecting to happen, yes, it says the sources do not specify particular tree species. This is where this tool outperforms ChatGPT and Claude, because it actually tells me, you know, this question you've asked, it's not in the data. But how do I compensate for this?
ChatGPT would say, no, we will find something, meaning, so
No, it's
ChatGPT will provide an
tree.
answer. Exactly, exactly.
Because
so this is the difference.
Its backend code is saying, you know, be a useful assistant, answer every question. But for that to compensate, I would want to quickly demonstrate another tool called Perplexity. Students here, just so you know, you can get the Pro for free for a year with a student account. Perplexity is a tool that utilizes the capacities of...
I love the name.
Yeah, it's a good name. It's utilizing the capacity of LLMs and agents to search information on the internet. So we know not all the information on the internet is good. We know not all of it is right. But in many cases, the thing that we would actually do is go search the internet. This is what we are going to do anyway. So if I'm coming here and I say, I need to make an urban project in Dubai and choose which trees to plant. Give me a list of 20 best local trees for urban nature and their characteristics, depth of roots, shading, water consumption, etc. I have these two options here. One is the deep research, which will take a little bit longer, and one is the quick one. I'm going to do the deep one. It might take another 2 minutes.
In the meantime, maybe I have a question. So also looking at the questions in the Q&A box. So there are questions regarding confidentiality. So I suppose that all what we are doing within this platform remains within your domain. So
I mean, the first thing I would say, this is Google. right? So
Yeah.
if you don't trust Google, then
Okay, so this is going
it's
on
up to you.
Google. Okay.
But let me just show you here. If I go on the settings and I would say upgrade to plus.
Exactly, but it's the same as you do
Look
with
at this. Look at
ChatGPT.
this. Your data stays private to you and those who you share your notebook with.
Yeah,
This
it's
is
the same that you do with
declaration from Google.
ChatGPT. Yeah.
Yeah. So
also with
I mean, a
ChatGPT.
general statement, I would always use paid versions. The
Yeah,
free
because
version,
you can also train the model of the machine. So
the free versions inherently use your data for their own training. They inherently check your data, and confidentiality is not there, and it's in the privacy policy.
yeah.
The paid ones, obviously, they know that if they do not remain private, nobody's going to use them. And also, I really doubt that there's people in Google that really care about looking at my Dubai data, right? But
Who
they
knows?
state it directly. And as a general thing, when you use AI tools, look in their privacy policy. They state clearly, do we use your data? Does anyone have access to your data or not? Of course, all of this is happening on a cloud, right? This is processed somewhere else, and someone might be able to access it if they want. But this is true for everything. Everything is on the cloud.
Sure, okay.
So this is not different than anything else. So if you're using confidential data here, just use the paid version, and it's like is cheap.
Yeah,
right?
yeah.
Nitsan,
so we have a few seconds left. So
yeah, I was just
we can see the results of.
I will let the perplexity run, but basically my point about this is that this is going to give me a list of trees. It's going to give me the source for each tree, so I can also validate, is this coming from a legit website or not? And then I can actually take this list of trees and put it as another source in Notebook. And then when I will ask Notebook which trees to put, it will look at the list of trees, but will also look at the regulations and the requirements, and will give me the optimal one based on synthesizing all of this different data. So I can take in, here it is, the gaff tree, the date palm, the ziziphus, the moringa, and each one of those I can see where it is validated from.
Source. Brilliant.
Super useful. We use this quite a lot, but if I'm going back to my presentation, this is my last slide. Thank you very much. You're welcome.
Thank you, Nitsan. Please, we don't have the time to. So there are a few questions in the chat again.
No, but I will stay for the Q&A at the end.
Yeah, a couple of them
and I will
probably again on confidentiality. Please stay online so that we can recover other questions for you at the end.
Yes.
With that, thanks again. I'm introducing Tor Banke. Tor Banke, now head of impact and associate partner at Third Nature Architects. With Tor, we are also investigating a bit more climate adaptive urbanism at the landscape scale. So in the end, going beyond the scale of a building to a different order of magnitude of complexity. Nitsan, we know that you have some very interesting examples to show. So happy to have you on board. Sorry, Tor, happy to have you on board today. Tor, I'm passing over to you.
Thank you so much, and thank you for the invitation. Can you hear me?
Yes, perfectly.
Great, perfect. I just dropped in on some of Nitsan's presentation, so I haven't had the chance to sit in on all the great presentation, but what a lineup! That's really amazing. Congratulations on that.
You are the lineup. Thank you. Thanks to you.
You're welcome. Let me see if I can share my presentation here.
Yeah, it is uploading.
It's uploading.
Yeah. Now we see
and you see it on full screen now?
Not in full screen mode now. Not yet.
Not yet.
Yeah. Now yes.
Now it is.
Yeah. Perfect.
Let me just. I'm just gonna change this bar here. That's a little bit annoying. Just a second. Okay, great. But yeah, thanks a lot for the presentation. My name is Tor. I'm an architect, head of impact, and associate partner here at Third Nature. We are a studio based in Nørrebro in Copenhagen. We are. It's a little bit untraditional for an office our size. We are around 25 people here, and half of our employees are traditional architects. The other half is landscape architects. So it means that we operate actually across all scales. And many of the, actually most of the projects are quite complex projects where we we are sitting in these very large teams and have very close collaboration with municipalities, also utility companies, big engineering companies, and so on. The company was founded in 2011. The people from Denmark probably know this image. There was a really big cloudburst on 2nd of July 2011, and it costed around 1 billion Danish or 1 billion euros in just one night in the cost. And what is interesting is that this image here, this flooding here, is actually something that we have not the price tag of 1 billion kroner, but like this specific image. This happened 2 times just in September last year. So it's something that's happening faster and faster, and it's getting wilder and wilder. I just want to use this image just as inspiration because it's something that I actually think is something that also has a little bit relation to the topic today in terms of computational design. It's an image that we use as inspiration here at the office. It was taken in on the Apollo 8 mission in 1968. So this was the year before we landed on the moon. And the astronaut here, William Anders, he took this image. It's called Earthrise, and it was like the first image taken by a human being where we saw like the Earth in space. And several years after, there was an author and philosopher that coined the term the overview effects. And what he found out was that like the astronauts that came down, they actually had a profound shift of perspective. And the reason why was that they have been looking at the Earth from above, and they've been seeing like the system from above and the interconnection and like, for example, the weather system, everything is connected. There are no borders. And he even phrased, there was a quote where he said that all kind of boundaries are actually only constructed in our head. And I actually believe that there is a possibility actually that computational design, now that we talk about regenerative design, there is actually a possibility that this is a way where computational design can actually have a role in actually creating this system where we can create this overview effect and actually have like this view. I have a little bit of a background, I've been 2 years here at Third Nature. We are very much focused on working with climate resiliency, especially in the area of water, but we are also working really with like the systemic and also like when we try to work with climate adaptation, we also create like these nature systems. So we really try to see it as a great system. I have a background where I was 10 years at Bjarke Group. I founded the R&D department and also served years as head of computational design, later director of sustainability. And this was really a department that was where there was a lot of kind of specialists. So it was both architects, engineers, construction engineers, and people interested in research and academia. And we developed a lot of these tools. I have some of them with me here today, and I would just before that actually give some credit to Anders Delorang, really one of my great heroes in computational design, and Christopher Neendal, that also he's an engineer and worked at Bjarke Group, but at the same time when I did my PhD, he was he was doing his work. And my PhD was this was 15 years ago, and so this was really like through my master's. This was the time where this was before Grasshopper. It was called Explicit History back in 2007, and later became Grasshopper. And in 2010, I started a PhD, and I also had the opportunity to meet Emanuele out at the academy, and really one of the things that I started doing and what I'm still doing is really to look at what's actually the possibility of these computational tools, especially in the early design phase. because it's in the early design phase where we actually have the biggest impact in terms of actually shaping and really make all of the important decisions. But what is happening here is that there is something called the project planning dilemma, and that means that we build up knowledge throughout the project. We develop the project, but there is a dilemma here because the knowledge curve and the impact curve they don't align. They actually cross. So my strategy throughout the PhD was, could we strategically build up some knowledge in the earlier phases? And I would like to end also this session here to ask what could be the future of computational design? And of course, in a business, there's also the opportunity to make important decision in the area of the phase where the cost of the changes are very, very low. But I would like to just show a few of these tools actually from my PhD. This is like 15 years ago. This was before I saw that Mustafa is joining later, which is amazing. This was before Ladybug and Honeybee kind of was in the game. And one of the things, and I think this is something that could be used also as inspiration for today, just as a method. And I've tried to actually collect a lot of tools throughout my career that is not the most complex ones, but tools that might inspire for tool developers, because all of this is something that's accessible. All the data behind is accessible. They are actually quite easy to get your head around. So one of the tools that I built back in 2010 was in daylight calculation. We have used a lot of analog tools, and all of these analog tools, like Nitsan was talking about data, all of these analog tools, they built along a lot of analog data, so measuring out in the physical world, and they have become these beautiful drawings that have been used as analog tools. This specific tools on the left is to measure daylight, daylight factor in one point at a time. So you can imagine how long time it takes to do a full daylight analysis. But what I just tried was to say, okay, but what if we just use parametric tools to not say 1 point, but let's just say several hundred points, and then link it into a model where we can then have a parameter about the specific geometry. So here, all of these points, they go and measure how much of how much is accessible from the window and could potentially also be beyond. And then it gives you a daylight factor, and it gives you an update just as a live tool. At this time, there were really no live tool for daylight calculation. So, and I mean, I didn't really do that much. I just took an analog tool and then I just put it into a parametric software. And that I did several times. This one here is a rule of thumb in terms of how much of the hemisphere from the facade is accessible for daylight. So it's taking in the specific context, and then it just gives an offset. If there's no obstructions, then it would give something like 2 to 2.5 x of the room height, right? And if there are obstructions, then it would be lower. And then there are also some factors that you could put in about material and so on. So this is again based upon data that has been measured physically, because that was how you did back in the days. And then it was just actually just multiplying that with maybe here a few thousand points, right? Again, I tried one where going into radiation analysis. And here, this was just an experiment that I haven't seen before at that time, where then I did 2 analyses at the same time. So here it's an Excel sheet with just a few kind of data point throughout the years of radiation, like a weather file that we all know from all the simulation software. And then it's just doing two calculations at the same time, and then it's just measuring like what is the shading effect of a facade. So something that's quite simple. Here it's just looking at then where is the sun in the sky, and then using like a sinus function to figure out like how much effect does it have. Like is it hitting directly, or is it inclined? So actually just using kind of geometry. Then I have another fun tool, because I mean we all know radiation models, and like this tool, this project here is a pretty nice project in Aarhus from Big, where it's a quite complex project. But what it does is that it sits out on a pier, and it opens up. So it's like these courtyards that opens up. So it gives these really amazing views, both towards the sea, but in the courtyard, half of the courtyard also towards the city. But one of the things that was a little bit difficult for us to figure out was actually what is, like here on the radiation model, you can see like these balconies that sit here. So what we were curious about was like, what's actually, what's a good position of these balconies, and what's the qualities of these balconies? And this was actually something that we used also when the real estate, when they start selling the apartments, because they were quite different. So what we just did was we made this kind of tool, and this is just a direct light analysis, where we put an analysis surface on all of these balconies, and then we just automated it, and we made this diagram. So it's like a parametric diagram that updates. So it means like you would get a kind of a diagram for each of these apartments, and then you could see like is the sun on my balconies, depending on, you know, like all of these apartments here, when they got sold, then they would have a small diagram that kind of represented like what's like the daylight amount of daylight, and when is the sun on your balcony. So it was actually something that was quite pedagogic to something to a design that was quite complex, but super simple again. Then here another fun project, also with just open kind of data. This was the Mars project, of course, for Dubai, where they wanted to build a Mars station in 100 years. And before, they would like a design out in the desert with kind of inspiration from like the Martian kind of site conditions. And I won't speak too much about like the specific design. I could speak for hours about that. But what I wanted to talk about was a little bit like a fun R&D exercise we did, because what we kind of figured out was that like being on Mars, maybe it's not that different, because like American studies shows that we use so much time indoor in you know, in our daily lives, and on Mars, of course, we need to be a little bit underground because of all the radiation. But when we are out in the open, then it's a little bit different, and still a little bit very similar to planet Earth, because on Mars, like a daily cycle is 24 hours. So there's like 1 extra hour, and also the sun is placed, of course, quite differently than on planet Earth. So we were speculating about what is actually the psychological effect here. Is that something that could inspire our design? And we were actually just curious about how is it. And we found some data on the NASA website, like on these specific things, because of course everything is recorded, and everything is also just open for grabs. So we found all of this kind of this data around what is the position of the sun when you are on a specific location on Mars. And then we simply couldn't resist building a small ladybug tool. So we made like a small ladybug tool for planet Mars, which like if you would build a project on Mars, then you would be able to actually probably get access to this small tool. Now we are back on planet Earth again, and this is I won't speak about the specific project, but I want to speak about like a general kind of difficulties in like working with different technical analysis. And one of the difficulties is when we talk about noise analysis. It's something that we always work with when we work in these very large scales. But like many other topics, it's very, very difficult for to get inputs early on in the design process. And the tools that are out there, they are either very two-dimensional or they are very, very difficult to get fast response from. And a little bit like from inspiration from the things that I showed from the PhD, we got some money to do a little bit of R&D, and what we did was that we got access to some papers, and this was also like super cheap access to some research papers around what is actually kind of the physics behind noise in very big open landscape areas and also urban areas. And what we also found was that a lot of these rules here, like formulas that were kind of observed, they were actually used in many of the tools that we use in practice. So they are also used like for legal purposes and these things. So we really dug into these, and then Anders de Lorang, he put some code to it. And what he did was that we found there was something called the rubber band method. And the rubber band method is really that you have a noise, like a point of noise, and then you have a receiver. And between those 2 points, then you put a rubber band. And that rubber band, you start calculating then both the length and also the angles. And through that, then you would be able to calculate like if the noise source populate with a certain dB, what would then be the receiver dB. And then what we did was we found a tool online that was now I can't remember what it's called, but if you do a super fast Google search, you would definitely find it. Otherwise, I can find it for you. But here they actually use that formula, and the formula is also used in like more complex tools. But that meant that we could test our hypothesis in 3D and then look in our 2D to kind of see if we were calculating right. And here you can set terms like temperature and humidity and ground factor and those things, and we could do exactly the same things in our tool. And then what we did, like this is like one of the really first tests here. Then we could then like populate it with maybe 50,000 points, and so these are like one of the first tests that we did. And here I'm showing it in kind of in landscape scale, but we also did it where we were looking at it directly onto facades, so we could do both things. And then finally, we got a little bit of money to actually have some engineers to actually verify our results. So we actually made like a feedback loop and had it tested, and it was actually quite precise. I'm just speeding up a little bit to manage the time. This is just a small exercise here that we did in Greenland. I think it was Covi, the engineers, that actually did a project one time where they did an analysis about what is it sufficient to have renewable energy at like, for example, wind turbines in Greenland. And we were doing a project up there, and we actually wanted to test kind of, what could this be done at scale, and how much energy could we actually produce. And the image that you see on the left are, I think they are not, you need to pay a little bit of money maybe to get access to an image like this. But this is a map that shows like wind speeds at 50 meters height, Normally you would see it at lower levels, like at airports, but this is at 50 meters height. So this is like specifically for conditions like this, and you can also get them for 100 meters and so on. And then we contacted also Vestas to ask them, like, every windmill has what they call like an efficiency curve, and that's like the dotted line that you see. So an efficiency curve is really like you when you make a windmill, you make it for a profile that fits the condition. So if you have it offshore, it needs to be like modified and fine-tuned so that it runs like on highest efficiency, you know, most of the time. So it means like here we could select like different efficiency curves. We could also then make a really fast calculation, like because we had all the data for all the data points throughout the entire year, like how much energy would we actually be able to produce throughout the entire year, and at what times would it be critical, and also what type of windmill could we potentially put here. So this was quite like inspiring to start to look at. Now I will just go into kind of the area of water, which is like my last topic. And of course, Anders de Lorang also made some pretty nice kind of analysis here on where we used it on a roof. And of course, this is something that was amazing to be able to shape the roof, but it's also something that we used for landscaping, and not just to see where the water was flowing, but also to see what how much what's the amount of water running down. We also had a project, the Serpentine Pavilion, where we actually tested like because the Serpentine Pavilion was a pavilion with openings, like it was like these cassettes that were completely open. They just had a parameter that was about depth, and what we investigated here is that when it rains, what is actually then the formula of like a raindrop moving through the sky, where of course it's affected by gravity, but also by wind. And these two parameters, then we could actually make these kind of statistical, you would say, kind of analysis. So we would test it against like a weather file, and then we could see like what is actually the risk depending on the different depth. So this was a way to actually kind of have a discussion about like what's actually an okay overhang, because it's always about risk, like how much rain would it be able to take in depending on the location. There was also a project on Google where you probably know the project, where we had all these shelves here that are PV, but they also, of course, the rainwater comes down. One of the very early ideas, which I'm not sure that went through, but was actually to work with a scheme where we didn't have any, like we would have actually the water to run off directly from the roof, and then actually design accordingly. And what we then investigated was like, of course, then the drop size of these like water coming off, and then what is actually, like using exactly the same formula, what is actually then the path that these water droplets would take down. Let's say that they would be 1 to 2 millimeters. What is then the distance depending on the wind velocity? And then like, would it be able to hit the facade? And in this example here, you would see that it would not. So it's also a way to kind of start to like modify the design and start to build up arguments again, like with this kind of risk kind of perspective. And another example here. Then this is one of the last example where we used, it's called the Manning formula. So these are again like completely access kind of formulas you can get online. Like Manning is something that I think it's from 1886 or something like that, and it's not a theoretical formula, it's actually empirical. So a lot of data was put into this to figure out what is actually like the relationship between like a flood stream, so like the section of a flood, the roughness of that flood, so depending on like how many stones are there, is a lot of plant vegetation, and also then the inclination here, and of course then the width of that flood. And through that, it was actually possible then to kind of look at then we were designing these artificial streams, you could say, in this big landscape. Like, what is actually the flow of this water? How much water can actually access, and what is actually the speed of the water? So, and we were able to manipulate then this design. It was interactive. So basically, it was actually again just like several thousand sections, where for each section, like we were calculating like what happens to this section, then the next section, then the next section, and so on. Yeah, and then these are just some last slides that I have for like maybe a further question, and this is something that we are very much working with like right now about climate resiliency and water, and this is something that is there's a big dialogue in Denmark right now, and especially because like about 1/3 of Denmark is at risk from water, from the sky, the sea, and the ground. And it's especially because like in Denmark, we like most Danish like cities are located very close to the water, and we have like 7,500 kilometers of coastline. So it's something that's very close to us. And this is again 2011 in my neighborhood. It looked like this. And there's been some calculations about like what is actually the risk in money, like over the next 100 years, and it's something that needs to happen. So what we are really working with is like, how can we work with something that is regenerative or something that's more system-based? Like, how can we work with both climate adaptation, but at the same time also working with nature? One of the most controversial projects right now is Lynetteholm. There's a lot of kind of discussions about the whole development side. We are not working on the development side. We are working on the big green area that you're seeing out there, which is a nature-based what's it called?
Area.
Yeah, exactly. Nature-based like area. To secure the whole Copenhagen in terms of rising sea level and flood barrier. So there's been these analyses like to the left in if we don't do anything, this is 2075, and then there's been some strategy work about like how can we protect Copenhagen, and this is something that's going forward right now. And you see Lynetteholm as, I think it's number 13. I can't see it from my screen. That is like the nature-based landscape. And we definitely see there's like for the edge zone, there's this great possibilities of like, we have seen it as something that was used for like war purpose, something that's used for industry purpose. And we have seen like a post-industry like area, like now 30 years ago, you're not able to swim in the harbor of Copenhagen, but now it's open to something that's more nature-based. And it's also something that I would like to question, like how can we use computational tools actually to kind of bridge this and merge these things? So it's not one thing or the other, it's actually both. And one of the things, that when we came to the project, there was an idea about making a traditional coastline, like a wall, where we introduced like the nature-based, where our engineers at COVI actually, they figured out that if you do it nature-based, you could actually lower like the landscape area with 1 meter, because you work further out. It means that you take a lot of the energy that's coming in, because one thing is the rising sea level, the other one are the waves coming in. So you can take that energy before. And of course, it's also more adaptable. The one to the right, you can put more soil on and adapt it, like let's say in 50 years when we know more from research, where to the left, you can only just raise the wall. So what we're working on here is like a strategy where this is going to be wild nature. So you're not going to plant with roots, you're going to plant with seeds, because that's also something that we learn, for example, from Holland. It gives a much more resilient area, and it also brings in like species that can actually thrive. So we are working as much like with biodiversity, but we're also working with geodiversity. So what are kind of the amount of area with sand, with stones, with large stones, how do we make an area that is actually diverse and give the possibilities for different species to actually thrive? And we have a test site right now where we're testing different plant seeds that are local from the area of Zealand and Malmö. And we have these to the left, these areas where we are testing different types of soil, different depths. We are mixing it with shells and chalk and other things. And then we are seeing like where do they thrive and how can we bring that into the strategies on the area. So here are just some kind of visualization of how we see it as not one thing or the other, but actually both. It's a nature-based place. There are also areas where you can come and visit and get closer to the area out there. So this is in construction right now. So I think I would like to end with kind of one of the bigger questions for me, and something that I'm curious about, like really how can we use this model to maybe think less about like controlling nature and looking at isolated things and seeing it more like a network of things and collaboration across, and mixing both like flood resiliency but also circular and regenerative and biodiversity. So that's kind of it for me. I think I'm quite on time.
Yeah, sure. By the way, we can find you on LinkedIn with this QR code. No, thanks, Tor. Great, absolutely. We were saying with Emanuele also, it's amazing how you did innovate in your career development, throughout your career development. So which is not usual, I say, for an architect or for a design firm. So this is absolutely interesting. Also looking how these tools evolved over the time. We can maybe we can have a quick questions again. I'm still interested about the point about adaptation versus mitigation. So is it still, say, the conversation running each time when you're addressing project, or maybe when you are talking with your stakeholders, they say, okay, we already lost the battle. We need to look at the adaptation only. Well, what's your take on this?
I think we have to, like, I don't think really there's not much a question, because like especially in Denmark, there's right now we have the 3-party agreement where like we need to like we have there's been some commitments about like we need to give nature much more space. Here in Denmark, we need a big area where we need to plant trees, and also the area of with the sea is in really bad condition. So a lot of things are happening right now. At the same time, there's the movement in terms of protecting, and I think we need to those two things need to go hand in hand, and I think they will. Like especially in the forums that I go to, it's something that's happening. Or it's starting to happen, I would say. But also because like the projects that we do are, as I mentioned, they are quite complex, and also in the area of financing the projects. Many of the projects we do, we try to look for synergies, because when we look for synergies, we also look for other areas where we can get financing. And I think that's the same thing here. What is missing a little bit is that the nature area. Like right now, we are not giving we are not seeing nature that much as like the area that like that is giving back in terms of financing, right? So I think like when we do these big projects where we start to protect, we actually need to get credit for like repairing these ecosystems. When we are, for example, like right now, there's an area of Burgh where they are looking at ongoing now right now, where they're looking at like how we can build these reefs, where they have actually seen how some of the species of some of the fish that has actually been gone for several years, they are actually starting to come back. And I think we have to look at these things like in synergies. Like, could we develop a design where we can actually get both things in? Then I think it's getting getting easier to get the finance, and I think it's gonna speed up the process much faster. But it's still like on a vision level. We haven't really seen it yet happening.
Okay. No, thanks. I think we are absolutely on time. Emanuele, if you have any questions, maybe you can keep these questions for the end, or do you have because you lived in Denmark for a while and you know Tor very well. Just a quick question.
Sure.
If you wish.
I've been always impressed since when I met Tor at the School of Architecture 15 years ago, I think. By the way he is able to capture one relation, a simple one perhaps, that can be scaled and then inform the project, and to translate perhaps a rule of thumbs into a form generator. And obviously his studies were related to daylighting and other factors. And then I was wondering, and this can relate to the path that many are doing, as we shift from primary matter and the practice shift more and more from the classic simulation of energy daylighting to complex topic, along which, for instance, the interaction between water and biological complex system. As the public is made of primary practitioner or researcher or investigator that are trying to evolve the field within this realm, what would you suggest in order to control both, let's say, the geometrical side as well as the formula or the trigonometry, mathematics, or flow law that are behind? What is the balance between, let's say, data and formulas and the geometry that you have seen along your career? Yeah. And what do you suggest?
I think I think the idea about having like a tool or a system that is that consists of everything, right? Like, you know, like an ideal parametric system that can, you know, where you can visualize the whole thing, is probably a little bit naive or like too idealistic. But I think there are some things that where we can use the parametric setup to look at very specific areas and see how they relate to each other, and use that as an inspiration. And then I think, like, I mean, like one of the things, I mean, there is so much focus right now on the building. Like when we look about the building industry, there's so much focus on the buildings, right? But we also know, like, the building industry, like more than half of, like, we were looking at a German research project where they saw that like around half of the building industry is actually between the buildings, right? It's our infrastructure, it's our landscape, it's, you know, all of these things, and 75% of our resources in kind of sand, stones, gravel, all of this sits there, right? And so there's also something, and all of our, like, all the legal perspectives, regulations, and certifications, and all of this, most of it is like towards the buildings, right? So I think we need to, like, also look at everything that's between the buildings and all of our landscapes and all of this, to actually see the potential there. Like, not to say that we need to make like just a lot of certification systems and ticks, you know, where we need to do some box ticking, but we need to see that potential that lies there, because it's where we can make much more synergies when we talk about the regenerative side of things. In the building industry, it's actually much more complex, because we are looking at the whole value chain, right? It becomes very difficult. But when we look about, like, the infrastructure and the landscape and all of this, you actually tap directly into a much larger ecosystem. So I don't know exactly, like, how to move that, but we are doing it in terms of, like, creating, like, narratives and using tools to try to actually, like, document and communicate and discuss the value that it brings, and the multi-function that it serves. And for us, that's kind of how we push in that direction.
Thank you. No, that's a great point. And also, thanks for making a point on sustainability standards. So in the end, are they suitable for managing this complexity? Probably not. Question mark. So let's move to. So we will probably collect other questions in the end if you're able to make it. Let's move to Ata Chokachan, MIT postdoctoral research fellow and also managing director at Climate Flux. Ata is speaking about the dynamics of urban climate and outdoor comfort through sensing and modeling tools, because we need to also to speak about how to collect data, and sensors are obviously important on this. And you have been working a lot on this. Ata, nice to meet you again. Lovely to have you on board today. Passing over to you.
Yeah, thank you both, Carlo and Emanuele, for having me here. I'm also joining from Boston, and unfortunately, I couldn't join the entire plan. But it's as a panelist, it's great to learn a lot about what Tor and Nitsan already presented. I'll go ahead and share my screen. Okay, so a little bit about myself. I'm also trained as an architect, and I did my PhD in Technical University of Munich in building technology. But out of curiosity, I was always interested on the space between the buildings and outdoors. I know there's a statistics exist that 90% of the time we spend indoors, but doesn't mean that the remaining 10% is not important. So that's why most of my work and our team work at Climate Flux, and my research works at MIT. We've focused on the small time we spend outdoors and the urban space in terms of outdoor comfort and urban climate. So as we know, the increasing temperatures are happening, and I would say the actual increase is 1 point, but the frequency of these events is actually adding more pressure to our built environment and urban environments, which we know 8 out of the top 10 most warmest years in our planet has occurred over the last decade. And as we saw also from the presentation from Tor, this is adding a lot of stress and pressure on our planet. Heat waves are one of them, but also intensified wildfire, droughts, and storm. And also based on statistics, 92% of most of these extreme weather events also happened in the past decade. I know we have a lot of audience from Europe and talking about the heat and how it impacts our cities. This is, I would say, more important topic for Europe because our buildings in Europe, they don't rely on air conditioning that much. And this becomes an issue over the day and night. And the reason that nighttime is also important because if the city cannot cool down, an old person who is living in an apartment down the street, they would not be able to cool down and recover and sleep over the hot summer night. And this has impact on all of us. It's hitting all of us financially and in terms of health. So we try actually to tackle this problem with several approaches at Climate Flux. We work on individual buildings, consulting the developers to improve the urban climate on an urban scale. We also work on exhibitions to raise the awareness and also bring the necessity of this topic to the public. And a big chunk of our work is also about community engagement. So how we can involve people actually on the decision-making processes, how we can connect, make a bridge between the citizens and the city, and make them understand this phenomena through the data and also through the existing mediums. So we know, I'm sure we've heard a lot about modeling, and we also use modeling tools because urban environments are very complex phenomena, especially if you zoom in and look into the micro scale and human scale. We call it the 2-meter air, that we have the most interaction as a human with it in outdoor environment, but also we use a lot of sensing technology to understand this. So for the modeling, I brought just one project because this is one of my favorite projects that we joined with the Geoturson. studio. And here, the proposal was building a park over a highway and connecting the Han River to the Northern Corridor. And here it was not mainly about modeling the static or stationary microclimate and outdoor comfort. It was more about how people would feel if they walk in this space, because the whole idea was to connect and create the people that they can promote it to cross the bridge. And if you can create comfortable outdoor conditions for people to walk, that wouldn't have failed. So what we did, we modeled different scenarios for actually people who are walking on this space, and taking into account what does it mean if they walk for 10 minutes or 15 minutes, and what's the impact of that exposure on human physiology. And based on this, we could actually zone the areas which are suitable for winter and summer, even for sitting, even for just standing, having a coffee. So this helped us to program the space with this data, which came from the simulation tools. I also believe that maybe we're in a period that we don't really need to develop new tools, because there are a lot of tools that we can use it systematically. I think that the most important thing about using a tool is that to understand, first of all, to understand the physics behind it, and then to actually use it to inform decision making and maybe create new metrics, link it to how people behave in those spaces. So I think the human component is a little bit always missing from how we interpret our simulations. And that's why the data comes in. And we all believe that if we can measure it, we can manage it. So in an urban environment, we believe that measuring and understanding the changes, because we know if you step from one side of the street to the other side, based on the changing temperature, humidity, sun, shade, radiation, mean radiant temperature, you would feel very different in a couple of even 100 meters. So that needs and necessitates the urgency for having high resolution microclimate data in our cities. And the reason why do we need this, the most, I would say, common use of this kind of data is pre and post development assessments. A lot of architecture firms, they do that. A lot of cities now, they have regulations for urban climate that you have to model or simulate your design and confront it with the status quo to see how much you're changing the microclimate. But there is another part which actually targets to what extent people are using the outdoor space, and what's the impact of heat stress on people's willingness to use and walk outdoors, or the impact on outdoor workers. There are a lot of people who are working outside. And if we don't have that data, we don't really know if this space is safe for them to work in terms of heat exposure. The other part is the impact on cooling and heating demand, which stretches out the pressure of climate change in terms of building performance. This kind of data, high resolution microclimate data, is really helpful for cities to identify the hotspots and plan the coming heat wave and prepare the cooling infrastructures for people, for vulnerable groups, that they can actually get a break from the heat wave. There are other species around us, humans, that are getting affected. Even this small temperature change, even a degree or a degree and a half, creating a lot of pressure on the green infrastructure. A lot of trees are dying out there. So this kind of data is also helpful to understand and protect other species. And also, this data is very valuable for model validation and creating human-centered metrics. So based on that, we started, this dates back to almost 8 years ago in 2017, where we had a small workshop back in the University of Munich with Chinese University of Hong Kong. And we tried to use a mobile weather station as another tool to collect data from the urban environment. And this model or this tool got evolved. We took it to Malaga. I even convinced Emanuele to wear and try one of these sensors. And over the time, we tried to actually expand this to help us to understand how the urban environment is shaping the way we use it, and also how this data can actually help us to make actionable decisions. So through the time, this device went through different iterations, and even as everyone loves to play with OpenAI, I also asked OpenAI what would be the next version of the backpack, and I came up with an image, but we didn't go that way. We joined with a group of neuroscientists in the University of Lisbon, and there we designed, I think it's the first portable kit to collect environmental data, including the EEG and brain signals. So we were measuring, basically the idea was that to collect environmental data, but also measure what's the impact on the way we perceive. And we analyzed this data to understand which areas creating or attracting more attention, or which areas are more creating more stress. And the whole point was to confront this with the way we perceive, or the level of heat stress we have in the outdoor environment. And we had really interesting findings. For example, one of them was that even if you're exposed to heat stress and you see a line of trees are coming up, since our brain works as a rewarding system, if you see a line of trees coming up, you would actually, your brain give the signal that there is a cold spot coming, and you keep walking. So this was even visually seeing green, it also can have impact on your thermal perception. As an outcome of this project, we created, I know a lot of cities don't like to have a lot of reports, so we created the policy briefs that the cities can take it and apply it in their cities. And there is a little dashboard. I didn't create a demo of this dashboard because I wouldn't want to take that much time, but if anyone's interested, they can go to this Geo-Emotional Cities Horizon 2020 dashboard, and they can explore the data actually there. It's available for 4 cities of London, Copenhagen, Lisbon, and Lansing. So going back to the story of climate walks, we've been using this tool or method to collect microclimate data. And recently actually got featured in Washington Post as one of the tools that they used to map the Indian hottest neighborhoods in Calcutta. And just to give you a brief idea how this works is that we normally create a workshop with the citizens, they get involved, and it comes normally to initiate a project from the city. So this was a project we did last summer with the city of Cambridge, and the project was about that the city of Cambridge is designing or redesigning a corridor between Porter Square and Davis Square, which is I would say, highly trafficked area, but they want to improve the walkability. So what we did, we teamed up with the city and the neighborhood people, and we collected the environmental data there. But what was interesting there was that the city was not actually looking for air quality, they were looking for heat stress. And since we measure air quality, this became another topic for them, that how polluted this area is. And this is one of the parameters that we don't feel it. It's not like heat, but we inhale it. So it's very invisible. But this kind of data on a micro scale, it actually helps us to understand. Most of these, I would say, models that we see, they're all on meso scale. If you look to the air quality maps, it rarely means what you inhale. It's most of the time it's on a meso scale, and it doesn't really translate what actually is happening on the street. So besides that, we had to collect the heat stress data. But what I want to actually a little bit provocatively question here is that is the metrics we use. So you might, I'm sure you're familiar with the UTCI metric, but briefly, UTCI means the feels-like temperature, and it collects 4 parameters of air temperature, humidity, wind, and radiant temperature. But in extreme day, if you measure or simulate UTCI, you would see all of these red dots. So, which is not really helpful to make decisions for a city. So it's all hot. But if you ask people who joined us on that event, they would find walking on the street. So it didn't mean that they're feeling super hot or they couldn't continue. And this all relies on what I was telling before, is that the way we interpret the metrics. So if you measure a UTCI for 2 people identical sitting side by side, one just sat for 20 minutes, the other one came and sat down after 20 minutes of jogging, if you measure your TCI beside that bench, it says 28. But these two people are feeling very different. So this brings the point that the heat stress does not affect everyone equally. So we need to really individualize this phenomena and maybe stop making generalized decisions on the metric we use. And the solution actually lies on individual monitoring and addressing this question on a very individual level based on the profile of the people, based on their age, based on their gender, based on their background, based on their access to resources. And that's what we did in Cambridge. So what we did, instead of looking to UTCI, we started to model scenarios with the thermophysiology. So how would these people feel for different group of people if they walk the street in terms of their core body temperature and skin temperature? And we developed a metric that actually helps us or help the city to make decisions. So what this metric tells us is that imagine that the human body is a capacitor. It charges and discharges the heat. And we could benchmark the areas where the human body is charges. So there is a limit that you can't actually compensate the heat anymore. But since we are walking on a vibrant urban environment with shade, with cooling, with breeze, so there is a possibility to discharge the heat. And we came up with this model that the areas that the urban environment doesn't actually provide a cold spot or cooling or relief for you. So that spot, if we expect people to walk along this trajectory, so there is a spot that the city should take it and improve it. And this goes aligned with, for example, some strategies to plant trees or creating cooling infrastructure. We can't plant trees all over the city. So we need to really find these strategic areas. And this was the approach that it could help them to intervene in interventions that actually make sense. So we took this idea. We had an access at MIT to a data set which was collected through entire metropolitan Boston area, or around 500,000 walking trajectories collected by the professor Andreas Sevcuk. And there, the idea was that, okay, let's now apply this metric, which is based on human behavior, on a broader scale. So the data set was mainly collected in 2023 between August till December. And as I said, instead of modeling static comfort measure, we modeled for each walking trajectory, how would that person feel based on the information we had if they walked exactly that path. And there was several interesting outcomes. And one of them was that we all talk about 15-minute city. But the 15-minute city, actually, if we consider the climate or the microclimate, for the case of Boston, in the extreme weather conditions, it could be extreme cold or extreme hot, the 15-minute city shrinks to 6 to 7 minutes. So I think this is actually the point that now we recognize that having this kind of data, having this kind of information, and talking about the changing climate, it really needs the new source of information, but not only information, linking it to how people actually would feel in that area. So to address this issue and having actually creating high-resolution microclimate data, 2 years ago, we started a project in Munich to using AI. But I would say AI is not the point here. It's more about how we can generate this data and using the data we have from the urban environment in terms of the building footprint, NDVI, and collecting high-resolution microclimate data with climate walks. So we did intensive walking campaigns in Munich and collected a lot of data from different parts of the city to train a model that can actually predict the microclimate conditions in an urban environment. And this data, as we said, it's very useful for different reasons. But one of the use cases that we came up was the Cool Street app. And this is mainly giving the opportunity for the citizens or for the people to know about the microclimate conditions around the neighborhood, but use it as a day-to-day based tool to inform their trips or know the best route that they can go and get groceries for elderly people. But also it can be used, since it's an API, it can be used, also linked to, for example, food delivery services, that they can pick the path that it's less exposed to the heat. With that said, we've started making this model now for the Munich. Now we know when you go from A to B, you have several path choices to know. Now everyone uses Google Maps. We always go for the shortest path or the fastest path. But I think it would help if we know that if we want to spend 2 minutes more or 1 minute more, but actually we're gonna be walking in a green path, or even we're going to be protected from a lot of sweating and heat over the day. So we use a lot of real-time information, real-time weather data, but also the information actually from the urban environment. And based on that, we could create a model that can, in a real time, and also with forecasting for the next days, for the next hours, it can give the users the most comfortable path. So I have a little demo here, just as a last piece. So the app is only for City of Munich. We're working to bring it to other cities. It's called coolstreet.app. You can run it on your browser. It has, talking about making it personal, you can sign up and give your very few information about the age, height, and the weight, because it's important to see how the human body is reacting to the outdoor weather or heat. You'll get a code. You need to save this, and then you just put it there. This becomes your personalized environment to plan your trips. So there's a couple of features, as every other app has. You can change your base map. But what is, I would say, makes this more practical is that you can actually see the real-time information, but also you can plan your trip in advance. So for example, let's say we want to go from the central station. You land in Munich, from the central station, a train station, to one of the mostly visited parks in Munich, the English Garden. So you're just going to put your starting point and the end point where you want to go. And immediately the model is going to try to calculate the possible routes. Based on the model, you might have up to 3 routes, but sometimes you might have only 1, because these paths might overlap. The greenest path might be the shortest and might be at the same time the most comfortable. And as soon as you are happy with one, you see on the lower left corner how much heat stress you're saving or how much time you're investing on this. And as I said, you can plan your trips in advance. For example, you say, tomorrow morning I have a work trip and I want to walk to work at 7. And you can actually see what's going to be on a micro scale, on a micro level, the thermal conditions on that path. It could also help you to find the right clothing for that. For example, in this path, we see you walk tomorrow morning, you're going to have a little bit of cold stress on that path. So it might be helpful to also inform personal decisions on day-to-day basis. So this project, or most of the work that you've seen, that it's based on an initiative that, besides the possibility or potential of these tools to inform our built environment, which is useful for developers and architects, we really try to bring this to people, to the day-to-day use of people, that can actually, because this is the piece I would say I was talking about when we talk about modeling is missing. So that's one of the main goals, that with these initiatives we try to bring the necessity of the topic first of all to the people, but also give them the tools that they can adopt and they can actually react or reflect on the topic of climate change. So that's all from my side. I think I'm 3 minutes over the time.
Sure. Thank you, Atta.
I'm happy to take the questions.
I would say, maybe what if you stop sharing your screen and we all get back into the main room? Perfect, also with Tor and Nitsan. So we can have a quick round of quick question if possible. So one challenge that we see is So what's the gap that basically you find in producing this climate data and then the application by the local decision makers? Sometimes they lack understanding of the climate science behind the tools. Let's be very direct on this. So are you also working on let's say closing this gap when you are talking with them, or they say, or it's not a problem. They immediately understand and they follow you. So what's the relationship between science and policy making on this?
So, I mean, that's a great question because, I mean, first of all, in every city, it depends like who are you talking to. And most of the cities now, they have, for example, heat chief officers that they know these topics and they have the know-how and they know the models. They know, sometimes they come with things that I need to go and ask myself, like, oh, this also exists. So there are people in the city administrations that they're very familiar with this topic. But what I see is we're going more and more, and I hear from a lot of cities that they're like, we don't want to add a report on our table. So we just want to take a model or something actionable that we can adopt immediately. The time is ticking against them, and they really see the necessity. So I'm with the cities that I've been working, I really see that they really see the potential and value of the tools. They even sometimes they are willing to invest in new tools. But I think it's, as we know, in every city, it's a slow process and it needs time, it needs patience. But I'm sure we have the tools, we have the medium. I think also the people, what I learned from this community engagement experiments, that I think the people really have the power to make that change. And they really have the power to bring this topic to the table and question it. And for example, in one of the projects we are doing for the city of Munich, the neighboring city actually started to complain about a new development, because the new development, the question was that it's blocking the cold wind corridors for the other city. And that becomes a topic now for the city, that they have to go and study that impact. So I think it's the potential is really there, and the tools are there. I think it's really the time to create some actionable solutions that the cities can take it and apply.
Thank you. You're right. Nitsan, Tor, any quick feedback from your experience on this?
I have a small question, Carlo.
Or do you agree with data?
Atta, can you hear me?
Yes.
Oh, okay, great to see you. I'm thinking of the people, the attendees, and myself too, to be honest, as a performance designer or designer. How can we almost reverse in engineering this type of findings? You probably have you can quickly catalog street section that are the grammar for different type of reaction from the thermal to much ample type of psychophysiological type of answer to space. How can that be used as an element for designing through modeling? How without get into perform an assessment of what can be the future comfort, how can that information more directly can impact design? Have you tried to do any experiment on that, or what can be a possible use?
Yeah, I mean, that's an interesting question, and I think I really like the work of Tor that he showed about. I mean, if you really want to create like impactful design decision support like ideas, everything relies on very simple mathematics and very simple understanding of an environment. So sometimes even like without running a very complicated CFD model or very complicated like energy model, it's really possible to say like, what is the rule of thumb in this space? And maybe that's something we really need to invest on educating our future generation, because there is a hype about AI, there is a hype about all of these tools, But what I see in the school or with the students, sometimes we're missing only the basics. We're really missing how, for example, a ray tracing works, what is the concept behind it. Everyone is really used to run simulations with a couple of clicks, thanks to huge computation potential now. But what is really missing, I think, is that knowing the basics. And talking about urban climate, I would say if you want to actually know what's the thermal conditions around your design, you just run a shade analysis. Very simple. Just do that, or just do one radiation study. Then you would see which areas are hotspots. So, but there is still, when you get to details, then you need all of those tools to be supportive and to give you more detailed feedback. But generally, maybe the short answer is that we need to little bit look to the computational problem also maybe from the lens of basic equations.
Yeah, thank you. Nitsan, Tor, quick answer, if you may.
Yeah, I think that my perspective on this is, I hope it came through in my presentation. Like, first of all, I don't think that inherently every decision needs to be data-driven, because, of course, sometimes the data is not fully representing what is there. And second, because sometimes it is just not the most right tool to make the decision. If I want to go outside and I want to choose if I take an umbrella or not, you know, sometimes the weather data will show that it's raining, but I'm looking outside and it's not raining. You know, like there's, it's not just about simple math. And
don't take it personal.
Yeah. No, it's not. I think the metaphor is good, but it's not. It's sometimes even more basic than simple math, and sometimes it's just more expanded than what can come down to a formula. Like, this is a very modernist approach to decision making, that everything can be optimized using mathematics. But then you want to know the thermal conditions in a site, go to the site. You know, it could be that actually the data will show that some areas are nice, but people are just not there. They're just simply not there. So it's our, I don't know, the responsibility is to balance what is even, what needs to be a data-driven decision, and what is it where we actually have to develop our own, you know, educate for common sense, for more nuanced understanding of what's the meaning of different decisions.
Okay, well, thank you, Nitsan. Tor, quick answer to conclude.
Sorry for being a little bit late.
No problem.
I didn't hear the question. Sorry.
Perhaps it's about the balance between rephrasing it between data and intuition.
Where is the boundary?
Well, I think it's an interesting question, because it's also something that I've been working a lot with, and for me, it's been like they have been coalescing. So it's like it's not one thing or the other. Like, I've been using a lot of tools, both with myself, but also in the organizations that I've been involved with, where it's been used to actually kind of raise the experience at the with the individual people. So more like a learning tool and more like a collaborative tool, keeping them quite simple, not as complex. And then instead of having one tool that fix many things, then many tools that fix a little bit each one of them, and then you could start to combine them. But actually to raise the intuition level, and then being able to access data from many places. But taking something that's super complex, making it quite simple and easier to understand, like synergies between things.
Brilliant. Thanks so much again, Nitsan, Tor, Atta. So we are a bit late, a few minutes late. We are taking the final break. We see each other at 4:25 Central Europe time. Stay in touch for the very final part of the event.
Sure.
Thank you so much.
Mustafa, and the guy from Norman Foster and Cyclops. So it's going to be quite an interesting session with Oscar and Wojciech. Okay. Okay, welcome everyone to the last chunk of presentation. This is a particularly interesting session where we have the privilege to have with us Oscar and Wojciech to start, speaking about Cyclops tools, which has been it is a breaking through tool within the palette of freeware tools for performance. And then we will have a session with Chris Mackey and Mustafa Rodsari. I guess that these are well-known names for us into building performance, design, and sustainability. So not to take too much time from the speaker, we leave the floor to Oscar and Wojciech. He will instruct on Polish pronunciation.
No worries, don't worry. It's all good.
And the floor is yours. Thanks for joining us.
Thank you so much. Thank you for the invitation and the opportunity to present. It's been quite an interesting lineup of very diverse speakers on the regenerative design and digital practice topic. So very happy to be here. So I'm Wojciech Karnowka, and I'm a design system analyst, and I'm joining my colleague Oskar Borgstrom, a design system analyst as well, and an associate partner at Foster & Partners. And we will start with a presentation. We will show a couple of industry case studies. We will talk about Cyclops features, and then finally we will move to the live demonstration of the tools. So Foster & Partners is a global practice with projects completed across the globe. We operate 18 overseas studios complementing our main base in London. The projects at the practice range from large-scale infrastructure to urban-scale master plans, but also down to a small scale of furnitures, light fixtures, and even door handles. The practice is structure of 6 integrated design studios that collaborate closely with engineering, BIM, with the design systems, and other specialist disciplines to deliver innovative and sustainable solutions. But complementing this structure are 12 technical design teams that provide in-house consultancy. And this is to ensure the technical excellence and tailored support across the projects. Now, applied R&D that we are part of is one of those teams. We are a group of architects, engineers, software developers, data scientists, also mathematicians, and historically we've been around 1% of the company. Recently, we just surpassed 30 colleagues. Now, we have wide breadth and depth of expertise ranging from complex geometries, performance-driven design to operational digital twins and artificial intelligence. But the key driver is tackling the challenges of the project delivery in efficient ways. So we strive to contribute in the most sustainable and innovative solution to the built environment, but we always look for the right tools and the technologies to advance this purpose. And today we will focus on the performance-driven design and optimization aspect of our expertise. Now, the traditional workflows involve multiple stakeholders and delay feedback loops. This slows down iteration and makes it harder for the designers to build intuitive mental models of how their designs perform. This is why we develop different tools in-house to simulate, analyze, and optimize performance, where real-time feedback is the key to empower designers. Now, the black box models are all the rage these days, but in some contexts like this one, fast, analytical, and physics-based will always win over the fast and probabilistic. Right. Now, how fast are we speaking and what kind of analysis? Here on the screen, you can see an analysis from year 2007 for the entertainment venue in Glasgow. What we analyzing here is the visibility of the blue area from the stands. We are evaluating one layout option back then of around 10,000 seats. And this, at the time, would have taken a designer a full working day. And now, 18 years ago, when we started developing and using this, we were evaluating 24 views per minute. But today, with the advances in the hardware that we're building on, but also the software that we develop, we're running around 4 million views per minute. So going back to the same designer 18 years ago, it depends how we want to look at it. But you could have spent the whole working days on this task, and then we would have evaluated a bit over 160,000 variations of the same stadium, or we could have just spent 150 milliseconds to run this very option and move to the next task. So here's Cyclops, our GPU accelerated ray tracing engine. Compared to off-shelf tools, we're getting performance gains by the orders of magnitude, and the amount of time we would have previously spent to analyze this one facade panel, we can now spend to analyze entire city block. Cyclops supports multiple analysis, like view analysis, artificial light simulation, daylight simulation, and multiple environmental simulations. It has a custom renderer in Rhino, and it has automated and standardized PDF reporting pipeline. So this is so that for each analysis, we can enable designers to easily compare between design options and communicate these differences between the options to the stakeholders. This unlocks rapid feedback, as I said, and just makes the turnaround in the design process a lot faster. Last year, Cyclops has been used on hundreds of projects, saving thousands of working hours and hundreds of compute hours. So now we'll dive into a bunch of case studies. We start at the scale of the facade. As you all know, most of the work in the industry is confidential. So we bringing this stand double, this unnamed generic tower, to illustrate some of the processes without disclosing the details of the actual project. And here we were asked to help and manage the direct irradiance on the facade. So we designed a system of horizontal and vertical shading louvers. Now, traditionally, this kind of shading optimization processes rely on evolutionary algorithms or other heuristic methods. This is to reduce the computational time by efficiently spacing the sampling the solution space. So with Cyclops, thanks to the speed and scalability, we can run a brute force evaluation of the full solution space, right? Testing every combination of horizontal and vertical louvers in some resolution, of course, per facade orientation. So this is done for east, west, north, and south on a laptop in under 10 minutes. Now, this approach allows us to plot a three-dimensional surface and understand the exact relative impact that each of the louver iteration have. For example, this image very clearly shows that deep horizontal louvers have much higher relative impact than the equivalent depth on vertical louvers. And so. And the next few slides will just show the same analysis, but for different orientations. Okay, so another not so specific building now set in Asia, where we extensively use Cyclops for finding. So here we begin by extruding the site to the maximum buildable envelope of 120 meters. And then we run the sunlight obstruction analysis to assess the impact of this envelope on adjacent schools. The voxels with the greatest negative impact are then removed, and then we evaluate impact of the resulting massing on nearby residential buildings. And we again redistribute the voxels to minimize the view obstruction while maximizing the views from our own massing. The voxels shapes then further rationalized for public space, connectivity, and the daylight, and some architectural gestures are then made, for example, on the ground floor, reopening the atrium. And that gives the designer a kind of an indication of what the starting massing is for this particular scenario and context. So going into the specifics, we are seeing the distinctive stages. For example, on the top left, we see the maximum buildable envelope, the voxel shading heat map, the visibility map. And this, this kind of diagram or a grid of diagrams really gives the designer an intuition of what certain architectural moves mean for the performance of the building. And finally, the example at a much larger scale here in Guangming Hub in China, where the goal was to develop a layout that optimized for the connectivity between the neighborhoods, the views towards the nearby central hill, the daylight potential, and the total floor area. So we again could have spent months creating and analyzing different options to find the best performing ones, but instead we feed the requirements and the design rules to the computer and allow it to do the heavy lifting for us. This particular process uses genetic algorithms and our distributed computing platform Hydra. so that the same analysis that otherwise would have taken 3 months now runs overnight or over the weekend. And finally, some of this distinctive analysis can be seen here on the GIF, where we see the results for cumulative radiation analysis, the view analysis, and the sunlight hours analysis. I will now pass on to Oscar, who will talk a little bit more about the features and run the demo. Thank you.
Thank you, Wojciech. So I'll try and talk a bit more about Cyclops specifically, and hopefully we'll manage to do a bit of a live demo as well in the end. So looking at the tool and the kind of benefits that it's brought to our company, we've now realized that we've kind of at a point where we believe that the industry benefit is larger than the competitive advantage that Cyclops gives us. So basically, following our commitment to sustainability, we decided that we would release the tool externally for free. This is to then encourage widespread adoption, but also to basically make the integration of sustainable design practices more accessible across the industry. The part that we're releasing includes the environmental analysis, as I said. So there is radiation, there's a few different daylight analyses in there, sky component, sunlight hours, and then a few novel pipelines. For example, the one Wojciech talked about was called sunlight obstruction. It is a Grasshopper plugin, and therefore it fits into most Grasshopper-based environmental analysis workflows. And then, like, the benefit here is that it really brings this power that NVIDIA GPUs has into the canvas. But it's worth remembering you need to have an NVIDIA GPU, and you need to be on Windows to run the plugin. So the benefits that we're seeing is then, as we've explained, the speed that it can run, but also really the scale of the models that it can handle. Like running the ray tracing on the GPU, we don't really see a difference in if you have 1 gigabyte context model or if you have just a small context model. Then obviously the integration into Grasshopper makes it very accessible and very adaptable, and you can build your own workflows however you want to do them. I'll show an example here of a site in New York where we're, for each frame here, updating the analysis. So every time we move this point, we generate new geometry and we rerun the analysis and we present the results on the buildings. So just to give some background here on what's actually happening. For each frame, we sample the facade in an evenly distributed grid. In this case, we have 1,700 analysis points. Then for each analysis point, we run 65,000 samples, meaning that for every frame, we trace 111 million rays. We're using a context model of a part of Manhattan with over 1 million mesh faces, and all of this runs at 40 milliseconds. Now, the benefit is obviously the fact that you can get your insight straight away. But what's important to remember is that to get this working, you also need to build extremely efficient Grasshopper scripts that run in the background. So when we look at the analysis here, the analysis only actually takes 20 milliseconds, and the rest of the time is spent, subdividing the facade, generating the colors, and then getting that display geometry back into Rhino. The aims, like a big aim during the development. No. Can you hear me?
Yes, we can hear you.
Yeah, sorry, my computer froze. Okay, so but the PowerPoint's not working.
So we see a page without the simulation, only the text on the left. Optimization workflow.
Yeah, that was a typical PowerPoint freeze. There we go. Starting again.
Yeah, you're probably asking PowerPoint too much today.
Yeah, to present the video.
Yeah.
Okay, let's see if I can share again. There we go.
Yeah, it's working.
Okay, so like during the development of Cyclops, the focus has always been to like try and pull out the computation that you don't need to repeat for a new design option and put that somewhere else so that you don't need to repeat that for every time you try a new option. And in doing this, we managed to create a process where the tool is extremely good for things like optimization, but also obviously for the real-time analysis, as I explained. So what we're looking at here is running optimization on a single machine, we have a single design objective here with the sky component, and it runs 23 options per second. So you can run very big optimizations extremely fast. And then in the same script, then we can add two more objectives like sunlight hours and radiation on the facade, and we can still run 16 options per second. And this is extremely powerful when you're running optimizations, obviously, because you can actually get, answers in a minute instead of waiting, days or what you were used to waiting. We've also developed an extensive set of documentation so that it's easy to understand how the different parts work, but also to easily get into the tool. So it ships together with tutorial files as well as the documentation. We obviously benchmark the analysis, and it's very exciting to be presenting alongside Mustafa and Chris. But yeah, so we obviously compare to the off-the-shelf tools to make sure that the results that we produce are following the standard. I think what we're seeing here is daylight autonomy for space, and it's within 2 or 3% variation. You just install through the package manager, Rhino 7, Rhino 8. It ships currently with a 90-day cutoff, meaning that every 90 days we will make sure to release a new version and you will have to update. And it's a bit like it's for the beginning when we're trying to catch bugs. It's a bit like Rhino Whip is working, it needs to be updated every 90 days. And I just want to reiterate that to run it, you need to have an NVIDIA GPU on your machine because we depend on libraries that are NVIDIA dependent. You can go to cyclops.fosterandpartners.com to learn a bit more. And I will try to rearrange a bit here to run a bit of a live demo. Okay. So let's put in Grasshopper instead. There we go. I assume you can see Grasshopper there. Okay, so the tool adds this toolbar in the top with the different components. You also get the drop down here with an about, check for updates. Here you can also reach the documentation. That brings you to the documentation that looks like this. And here you go through how to get started, installation, changelog, what happens when we release new versions. We also have a whole library here of all the components and how the different components work. This is kind of the data that you can read about in the components in Grasshopper. You can go in here and see how they all work. You can also in here click learn more. That brings you deeper into the documentation where we kind of present what actually is a sun rig and what are the different inputs and how they affect the outcome when you create this object. Or when you run analysis, let's say daylight, then what's usually needed when you run a specific daylight analysis and how does it work and what are the metrics that you get out. Okay, then up here we also have the tutorial files, and here we have tried to put together tutorials on how to run analyses for a lot of different metrics. So if I go into daylight factor, for example, you're presented with this tool or this script. And that kind of shows you then how to set up the geometry and how it's sampled, how you run the analysis, and then how you get the results out and how you can display them. So it's usually quite a good starting point when you're setting up new files. Okay, I'm going to now try and present the script that I used to create that New York GIF. So I have a Rhino model here, which is this part of Manhattan, as I said. And then we'll jump into this file. Okay, hopefully this is fast, yeah. So first off, we just create simple option geometry, that's these boxes. And we sample the facade, so because sampling can happen in a lot of ways to kind of decide where are the points that I want to analyze. I guess in a company like, or in a studio like Foster and Partners, a lot of buildings are very different, and we do very, very, very different types of analyses using this tool. So we do this in a lot of different ways depending on what you're analyzing. But in this case, we're just taking the vertical faces and we basically subdivide them into a mesh. And then we're using the vertices and the normals of that mesh to basically create something we call analysis points. And the analysis point is basically, for most of the analysis, that is the position and the direction in terms of where you want to run analysis, right? So it's the sampling on a surface on where you want to run analysis. So we create a set of points on the facade. A lot of other tools have kind of automated processes for these. If you've used Climate Studio or if you used Honeybee Ladybug, you know, they can create grids for you automatically. We don't do that yet, at least. Anyway, then we need to kind of adapt the geometry for Cyclops. So the way you do this, Cyclops is mesh-based completely. So you basically have your geometry. Here, this the option. I plug it into the component that basically creates geometry. And there you can, if you want to use materials, in this analysis specifically, we're just looking at the direct contribution from the sky onto these points. So we don't care about bounces, so materials don't matter. And then we wrap this in something called a geometry group. And a geometry group is a bit like a block in Rhino. So you wrap the geometry that you have, and then on that you can apply transforms. So if you want to instantiate, you know, 1 million trees in your scene, you can do that, and it won't actually burden your GPU memory because it will copy the geometry for the transforms just for the ray tracing. Yeah, so I've created the geometry for my option. Then I have the geometry for the context, and that is just all of these meshes. I do the same thing. I create specific geometry group for the context. Okay, now we come to one of the little more complex parts, which is optional. But when you kind of want to run things fast, as I said, and you have big contexts, you don't want to, every time you run analysis, you don't want to re-upload the context onto the GPU. And that's why we created a concept called a scene. And a scene is a way to like statically hold geometry on the GPU and save it there between analyses, you could say. So what we're doing is that we're creating a scene, and then to the scene, we're adding this geometry for the context, right? And what you're seeing here is the black groups I have in Grasshopper, right? They only run once. I have my scene, I add my context won't change. So I just upload it to the scene, right? But obviously every time I change my option, I will need to update the geometry that is my option, and I will need to resample the option. So these blue ones, they run every time I move the point, okay? And the benefit then of not having to kind of upload this every time is obviously I don't need to recompute that because the computation is gonna give the same results. Okay, so I have my scene here. I've added the context geometry. Now I can add the option geometry, and that obviously runs every time. Okay, then here we need, what do we do next? So we can talk about how the analysis works. So the radiation and the daylight-based analysis in Cyclops, they are based on something called shading masks. And a shading mask is basically an explanation of the relationship between this analysis point and the sky, right? So if we had bounces, it will account for bounces. And basically, okay, each patch in the sky, how much does it actually affect the specific point? I don't know yet about the brightness in that patch, right? Or the illuminance or the irradiance. I just know the relationship between that patch and the point. So you can see a shading mask can look a bit like this, where how much does each patch of the sky affect the point? And then obviously the layout of the shading mask is based on how you subdivide the hemisphere. So to run the shading mask analysis, we need to basically set up a hemisphere subdivision. And if you run analyses like this before, you would be used to the Reinhardt-Tregenza 145 patches. That is kind of the standard. We have a few more here. It's basically if you want to have a lot more patches for specific reasons, then the Reinhardt-Tregenza doesn't really like the goal here is to divide it into patches that have the same size, ideally. And the Tregensia one is nice for 145, but if you go up to 1,000 or for some reason, then you might want to switch to this one that's just called equal area aspect, which uses a different algorithm to do that subdivision. This is in the documentation. I'm not going to go more into that. We'll stick with the Tregensia for now. Okay. Then, so we have our scene here where we add the stuff. We have the hemisphere, then we have the analysis point where we want to run the analysis. And then we also need to set up the sampling. So how do you actually want to sample the scene? How many rays do you want to trace around the analysis point, and how much do you want them to bounce and so on? In this case, we're running just direct radiation. So we're just using a sampling setting with direct radiation. But you can go in here and you can do like preset analysis settings. And then you can choose low quality, medium quality, high quality. And then if I hover the output here, you can see what it means in terms of how many samples, how deep are we tracing the rays. And these are kind of equivalent to radiance parameters like AB, AD, and LW, if you know what that means. It's a bit like, it's about, Russian roulette termination. And you can read the documentations more about that. Okay, so I have my sampling settings, and basically that creates the shading mask. So I now have 3,564 analysis points, and for that I create as many shading masks. Okay, then we want to calculate, in this case, cumulative radiation. So then we need to now start to understand, how does the sky work? How does the sky look, right? So we have an EPW file. We read the EPW file into a weather object that basically encapsulates the data in the EPW file. And then we create something we call a sky series, which is basically calculating the distribution of illuminance across the sky, or the distribution of irradiance. And here you can then plug in the weather, obviously the hemisphere again, because you need to know your patches in order to calculate the illuminance, irradiance. And the time pattern of when do you actually want to sample this, right? Because you maybe don't want to sample the whole year. You might want to just sample a day or something. But in this case, we're sampling the whole year. Okay. And then we're just basically running the radiation analysis. And this, what happens in here is that we take the knowledge of the relationship to the sky, and we take the knowledge of the illuminance or the irradiance of the sky, and we basically do an enormous matrix multiplication, right? And this is kind of a separation, that, as I talked about before, this is quite an important separation of calculation. So I can, if I go in here and I say, okay, let's run a daylight analysis, and let's say I want to do the daylight factor, right? This just takes a shading mask input. Okay, so now in 3 milliseconds, I've also calculated the daily factor on the same facade, right? I don't need to redo all the ray tracing because I already know that relationship. Obviously, the daylight factor is not necessarily relevant on a facade, but because this is direct correlation, so if I right-click this and show the input for the sky type, and I make sure this is overcast, then this would pretty much be the sky component for the facade. It's kind of the same calculation. Okay, then I have my cumulative radiation values. I turn that into a color. I have my mesh. I color my mesh. And there we have it. I just go back here just to show again how I move this point. I rerun that whole computation, and I create a new output. Okay, some of the things that I talked about here, which are kind of interesting, or showed, which are kind of new concepts that we've introduced. In terms of the analysis, sometimes you drop a component and it's kind of doesn't have any input or output. And that's because we've grouped analyses into a single component. So if I then right-click this one, you can see that I can choose which analysis do you want to run. So if I then click daylight factor, it converts into a daylight factor analysis component. Another thing, which I should have kept that on. Let's drop that again. Okay, another thing is that if you have an enumerable input, basically an input where you need to just choose kind of a type, you can always right-click the component and click Generate Missing Enum Inputs, and it will basically generate that drop-down with the potential things that you can choose. Yeah, okay. Some other things. All of these things that you produce here are objects, right? They're C# objects. And for each object, you can retrieve the properties of that object. So we've introduced these components called get property value and set custom data. So custom data, you can attach any type of data onto these objects, but also get property value allows you to pull out any type of data that exists inside these objects. So if I plug in the sky series here and I click add, it basically creates a drop-down for all the potential or all the properties of that object. So I can now go in and get the cumulative sky, which is basically the representation of the cumulative data on the sky. And we can see what we're actually doing that down here. So we can see here we have the sky series, we get the cumulative data. And then from the cumulative sky, that is basically just a representation of the sky for all the cumulative irradiance and illuminance. And then out of that object, we can pull out the hemisphere. Here I could obviously also have used the hemisphere that I created over here. And then I can also pull out what we call the luminance cells, which is basically each cell in the hemisphere. I can also pull out then out of the luminance cells, I can pull out which metric I want to look at. Now we can look at diffuse luminance as an example. And then I can use this display component. So if I drop a hemisphere component, you see it doesn't have an input and output, because you can choose here if you want to create an hemisphere or if you want to display an hemisphere, right? So if I display an hemisphere, I get a component where I can basically display data onto the hemisphere. That's the one you're seeing here, right? So if I preview this here and we zoom into that, you can see it here where we have the diffuse illuminance shown onto the hemisphere for these values. And for this one, you can change a few things like the projection. And we can go up here and we can maybe, if I change the subdivision of the hemisphere, it becomes quite prominent. What actually changes when I do that? Obviously, the whole calculation becomes slower the more patches I have. You can display things like the shading mask as well, shading mask data, right? The relationship to the sky. Yeah. I think that's a start. Let's, if we have any questions, maybe I can go in deeper to other parts of the app if it would be interesting. Thank you.
Thanks, Oscar and Wojciech. It's quite impressive to see live from you the development. And I have a question about perhaps it's not so technical because the functionality, I think it was incredibly clear, and also your documentation online, it's frankly self-speaking. My question is about the cognitive model within it. Are you actually using your own as a performative design team, or in the office, in the spread office community, it is used by a larger number of people? And what did you see as a learning curve of the tool? Because our public, it's primarily of people interested in using the tool. Yeah.
I mean, so all the tools that we produce as a team are, they grow out of a need in the company, right? And like, we are not the sustainability team. We don't run sustainability or energy analysis or like we don't run too many of these, and like the sustainability group or the environmental engineering team in the company would usually run them. And then there's other analyses that Wojciech talked about earlier, like view analysis and stuff, which we haven't released, which are also used across the company. It's obviously we use it a lot. Like if we run a distributed optimization, then obviously we maybe run it in our team, but it's is primarily for the company, right? And it's like we didn't create too many of these assets that we presented for the public, right? We created this whole documentation for the company. Like we're like 2,500 people or something now. So it's a whole, you know, it requires a lot of effort to kind of reach that type of group and make sure that, you know, they pick it up and use it for what's valuable for them.
And I think also just to Oscar's point that while these tools are being created, we are in a constant conversation both with the environmental engineering team and with the potential users to try and understand what is their kind of mental model of thinking about these things, right? How do we make it easy for them to get their head around this, and how can it be useful, right? Because at the end of the day, we're creating it for them more than anything else.
It's also like they also come to us like in terms of a lot of the features that, especially the ones that are kind of internal, like we can do artificial lighting because the lighting team came to us and asked, okay, can we use this other tool? I'm not sure what it's called Dialux or something. Anyway, which is very slow for them. So then the question is, okay, can we try and speed up this type of analysis and make it more parametric by moving it into Grasshoppers? And also the fire engineering group, like, can we calculate, you know, the radiative transfer between bodies in space? If there's a fire there on this airport, is there gonna be too much radiation coming through the window? And like a lot of this, because we have detailed control of the ray tracing that happens, we can kind of just adapt it a bit. And then it works for this completely different analysis in this completely different field, but we can still benefit from this extreme speed up that we're seeing by using the GPU. And also the kind of benefit of if you buy a new GPU, you know, like NVIDIA is doubling the speed every year or whatever. If you buy a new GPU, your analysis is just suddenly going to be twice as fast. It's like it's really dependent on the hardware in the way that, not in the way that old GPUs are going to be slow. It's just that you can very much invest and buy more, get more or something. I think he said, the CEO there, that like you can really, by getting a bit better hardware, it's going to be a lot faster for you. But I think at the moment we're in a place where we're trying to gauge, are there other analyses, are there other things that we're doing which we can try and adapt to be able to use this compute power, right?
Yeah,
it's very interesting, but you obviously need to then really understand the physics and the technology of the analysis that you need to adapt, but also understand the hardware and the development that's required.
It's quite interesting because this session will offer different leverage GPU or cloud, or traditionally Ladybug has worked with a few core. I wonder if Chris or Ata or most of us any question out of curiosity, or if anyone from the public wants to have a further question. If not, I will ask further and briefly. Not at the time. Yeah, there are no questions at the time. So clearly the industry, and we could see today also, it's moving from optimization of building to an optimization of building and space in between. And it's clear that your tool can be applied not only to building, but also to streets for all a set of interesting parameters. How do you see, for instance, implementing very simple new feature like, you know, surface bioreceptivity once you have radiation, once you have, let's say, a temperature, even just from a weather file, and perhaps water from the EPW, or some of the EPW has this millimeter of water per month, or so. How do you see, have you thought, what do you see as a first, perhaps even internal force from the office? I can see that even Forstervet is changing a little bit the language and the vegetation. It's becoming a stronger asset in design. Yeah, how do you see the tools potentially evolving?
We obviously need to focus our development on what we feel is impactful for for the for our company primarily. Like of course we release this tool for free and anyone can use it, and please come and tell us what doesn't work, and please come and tell us what else you want it to be able to do. Absolutely. But our primary concern as a team and as a development group is to look at what do we need in the company, you know, and what can we apply in the company. And obviously these things are extremely interesting, and I think we are working quite closely with our environmental engineering group to understand, are there other metrics that they calculate that we can help them with, right? But then there's also the, you know, you need to weigh the fact, are we going to make it a lot faster by integrating it, or could it just be 3 other native Grasshopper components to combine this data with the analysis that we're already running in Cyclops?
Okay, yeah, very interesting, Oscar. I have just a quick question. I'm thinking as a user now. Let's say that I calculate wind flow from eddy, and then I've grid the points with a value. I haven't tried Cyclops yet, but it's a Monday task. Would that be possible to import results seamlessly into a grid, for instance?
Yeah, I mean, you mean you want to do something like UTCI or something, like you want to combine.
For instance, to create
I mean, the data that the number that you get out, right? It's just a number. This is just the kilowatt hours per square meters for each point that I inputted on the analysis point. Like it's not more complicated than that. Like you just put that data wherever you want to use it.
Okay, perhaps I'll do Sunday, not Monday. Okay.
Yeah. We don't really have any, like we haven't obviously we developed a little bit to like, okay, you can preview the hemisphere, or you can preview the let's say I make a sun rig, right? You can preview a sun rig, but we haven't really invested in, as I said earlier, creating these grids or creating ways to kind of quickly visualize on these grids.
And to add a little bit to that again, is not because we don't want to, but I think, you know, among all of you, there's so many ways in which this kind of visualization can be created, and you know, it's meant to fit into what you're doing. It can be a widget on the Rhino. It can be just graphs printed to PDF. There's just so many ways that I think, you know, the principle is to give you as much flexibility and opportunity as possible to do it your way.
Well, perhaps I'll just ask, can you see my screen right now?
Yeah.
Just technically, this is a simulation run with Ladybug tools, for instance.
I think you're sharing what I'm sharing.
No, sorry, we are still sharing. We're still seeing Oscar's.
Okay,
screen.
will I stop share?
Yeah, now we see your screen, Emanuele.
Yeah.
Okay, yes. These are 40 kilometer square simulation with CFD, and then I've done, let's say, with Ladybug tools. How and I have a certain idea of how long it took to run a Ladybug tool simulation for, let's say, in this case, it's radiation. How would it be possible to simulate 40 square kilometer, and what would be the time, let's say, as an average with a good?
I will not tell you the time, and I will not tell you which tool to use. That is completely up to you, but it's definitely possible to run the analysis.
Okay, thanks.
Yeah, and I mean it's you know, we love Ladybug and Honeybee. We're not trying to
absolutely. It's just great.
Tools, you know,
we
just found a need that we needed to use this.
Not because they're in the room.
And we all love it, and that gives us the chance to introduce the next speaker, which is Chris. Nice to see you after a couple of 5 years.
Likewise.
Likewise. I'm curious, what is the frame you have on your right, because it looks like a lot of logos from
oh yeah, that is all of our component
clients.
logos, at least 150 of them out of the 300, 400 or so components we have in Ladybug tools. But
Sure,
yeah,
sure. If it's for sale, count on me.
we've considered we've considered like selling some merch at some point, but yeah, we'll let you know. We people keep asking us for stickers too, laptop stickers, so
Sure.
I know we have it on our list to do a merch store.
I still have yours.
When you start developing Grasshopper tools, you never really understand how much effort goes into creating
the logos.
Yeah, it's quite an effort. Yeah, I mean, to make them all communicate and be legible.
Great, Chris. We can't wait to hear from you. So floor is entirely
yeah.
yours.
Let me share my screen.
Thanks so much.
Yes, it should be the whole screen.
In the meantime, Oscar and Wojciech, there is a question also in the Q&A box if you can address this.
I'll write an answer here.
Thank you.
Okay. Well, thank you for that introduction, and thank you, Oscar, for your presentation. It was very interesting and cool to see what you guys are doing with GPU. But I mean, I'm Chris Mackey, as Emanuele introduced. I'm a co-founder of Ladybug Tools LLC, along with Mustafa, who will be presenting right after me. And I think a lot of you listening probably are already a little bit familiar with Ladybug Tools. So I don't want to spend too much time introducing it, but just to explain what I'm going to go over in this presentation and how it's different from what Mustafa is going to show you. I just want to clarify, I think something we used to get a lot of questions on, although I think a lot of people have a better understanding these days. But I am primarily going to be presenting in this next half hour on Ladybug Tools, which is our open source project that has been going on for almost 12 years now. It includes a free Python SDK and a bunch of free open source Grasshopper components, all completely open source, all available on our GitHub for anyone who wants to use them. But I want to distinguish that from what Mustafa is mostly going to be demoing for you guys, which is a bunch of software we sell under the banner of Pollination. And so Pollination uses Ladybug Tools under the hood, but I guess it was about 6 years ago that we founded a company and started building a few specific types of like commercial offerings on top of that open source core of Ladybug Tools. So just to explain roughly what Ladybug Tools is and what the size of the community is these days. All right, so Ladybug Tools is a collection of Grasshopper components and Python software development kits that support them. There are several different insects, Ladybug being the first one that mainly does climate visualization and analysis. Honeybee is meant to do more of building scale energy, daylight, thermal comfort mapping. All of that happens under Honeybee. And then more recently, the most recent insect probably of the group is Dragonfly, which is mainly meant for urban scale modeling. I'm going to try and give you, I'm going to go over a few scripts that touch on a little bit of each of these insects, but probably most of them are going to be within the domain of Honeybee here, right in the middle of the curve. And all of Ladybug Tools, as you've heard me say, is open source, right? And the reason for that is because we believe it's very important for people to be able to see all the assumptions and everything under the hood for them to be able to use it. All of the engines, we're never in the business of creating engines ourselves at Ladybug Tools LLC. We always branch out to other scientifically validated engines like Energy Plus and Radiance. Right, and we use them in order to actually run the analysis. And then lastly, right, everything is meant to be free and flexible, that you're able to really combine the parts of the software development kit and Grasshopper components into your own custom tools. All right, and the reason for that is that so you can use it to answer novel research questions and design questions. So the community these days, I mean, it's gone well beyond the size that I think Mustafa or I ever imagined 10 to 12 years ago. And at this point, I think we're at some point we're getting very close to passing 1 million downloads of the software on Food for Rhino. The forum still has over thousands of monthly active users. There's a new topic. Sometimes in the middle of the school year, like now, you'll find like a new forum topic every hour. But average around 14 or so. New topics being made, 6,000 page views every day. So this is the scale of our community around Ladybug Tools LLC. And it's, it's grown to a size kind of beyond what we'd ever imagined at this point. So that is what Ladybug Tools fundamentally is, right? It's this free open source software that we have been maintaining and is supported by a community of volunteers on our forum who answer questions. Now, pollination, as I'm not going to show that many slides on this. I'm just going to say that what pollination is primarily, it's a collection, it's a CAD and a BIM plugin that primarily make it much faster and easier to set up models, building energy models and building simulation models. So I'm going to be starting from the place where I already have a model that is built with the, well, exported from our Revit, the pollination Revit plugin, and imported into our Rhino plugin. You can, of course, build energy models with Ladybug tools from scratch, but I mean, it can be a very tedious process. It's a lot of spaghetti Grasshopper, if you guys have ever tried doing that. So that's why most of the time these days, models are created in one of these two CAD plugins. And then I'm just going to show you a range of scripts, of different Grasshopper scripts exploring different metrics around, I mean, well, what I call the world of metrics here. In order to give you a sense of like what the freedom and flexibility you have with the 300 to 400 Grasshopper components and Ladybug tools. What are all the different types of custom analyses that you can run on an energy model that has been set up either with one of our CAD plugins or with Ladybug tools. And I think, I mean, this is a increasingly important part of working with environmental design in practice, is that a lot of the times, I mean, whereas like back in the day, maybe like 10 years ago when I first started, the main metric that I felt everybody wanted to get was just EUI, and that was like the be all end all of metrics, right? Because it's very easy to calculate from an energy model, and two, it allows you to basically benchmark yourself against other buildings to get a sense of how efficient you're doing. Right, so it's a very immediately accessible and useful metric, right? Because you're basically just dividing the energy use of the building by the floor area. But to kind of put a spin on that and explain how I would use Ladybug tools in practice to not just tell me what the EUI is and basically write in order so that I can compare myself to like typical buildings of the same type in the US, right? These are just the EUIs of typical buildings. Right, and just to go beyond that and not just tell me what my EUI is, but how can I actually make my EUI better, or where should I focus my efforts on in the design process in order to improve the energy use of my building. Right, so I'm going to show you a script right now, which is not just going to show you an energy use intensity metric, which, full disclosure, is going to just really be heating and cooling loads, although you can certainly get heating fuel and electricity for cooling as well, or heating electricity in the case of heat pumps. I want to kind of overcome a major limitation of energy use intensity, right? Is because even though it gives you a sense of building efficiency, it does not necessarily tell you how to make it better, right? And so for that, in order to know how to make your EUI better, the thing that I would use is something called, well, I would go back to the very fundamental basis of all energy modeling, which is the first law of thermodynamics. Right, and so that law that energy can never be created or destroyed, right? It basically means the energy that goes into a building has to leave it, or otherwise it's the building's going to heat up or cool down, right? So what that means is, right, the heat from people, computers, light bulbs, from windows has to eventually conduct out the envelope, be lost maybe through infiltration seeping through the walls, or maybe through ventilation that's purposely brought into the building. And whatever remainder of this equality, right, that's the heating from your heating system, the cooling from your cooling system. Right, so the visualization I'm going to show you in a Grasshopper script right now is what I call an energy balance, or a load balance, as it's sometimes called. But the nice thing about it is, right, it not only shows you like, okay, I have a lot of cooling in January, and if you can't tell, this is a graphic of an energy model in Australia, in the Southern Hemisphere, right? Because cooling in January would be pretty weird from where at least where I am and where the conference is. But you can see, right, the reason for this cooling is because you have a very high solar load. Right, and so this would lead you to say, okay, if I want to make the UI better in this case, the key thing I should invest in is shading, some better solar heat gain coefficient. So let me go over to Rhino Grasshopper here. I have a model that's already been prepared. This is, I mean, if you guys have ever worked or learned Revit, this is the infamous Revit sample model. Right, just exported from our Revit plugin, cleaned up a little bit, as Mustafa will show you later. Right, and just imported into Rhino, and you can see, right, we have all the different, 15 or 16 different rooms here in the model. I've assigned some different programs. Well, we've got boundary conditions for ground and outdoors. We have, right, some programs that have been assigned, so we have schedules and loads. Admittedly, I've just put some offices here, but this was a ready to go energy model, basically. It's all been set up. And I have a Grasshopper script here, right, which will, let's see, which is just meant to take annual loads, right? Just show us, right, the end use intensity in terms of heating and cooling loads, and then give us a graphic of that load balance, right? And so I have a component here that simply pulls in the model from the Rhino scene here, right, from our Pollination Rhino plugin. It's a component that comes with our single click installers for pollination, as well as Ladybug tools. They all come in the same package, right? So Ladybug, Honeybee, and pollination, these are all coming with the same installer, right? And I'm just grabbing the rooms of this model and I'm funneling them into a component that runs annual loads. And this will plot some monthly charts showing what those loads are. So you can see if I set this to true to run it, I mean, this component is particularly meant to run an optimized energy simulation with Energy Plus, just to give me this load balance. It should only be right for a building of this size with like 15 zones. It's only a few seconds, and you can see we get our result over here. Actually, I'm going to go over to top view so you can see a little better. Right, and so you can see in this case, right, this building, this Revit model, not only can we get a graph of the heating cooling load, the EUI, basically the energy intensity, and see, right, it's primarily driven by heating, cooling, and electric equipment and lighting are relatively small, right? So obviously, if we wanted to make this building better, we should probably tackle heating first. And now looking at our load balance here, right, we can see the reason why we have such a huge heating term, especially in January, is, well, I mean, one is the infiltration, right? So, which is maybe not surprising given a building of this size, right? You have a high envelope to volume ratio, right? But I mean, almost bigger than that, we have this blue term here, which is window conduction, right? And if we look at our model here, right, this is more windows than you really need, especially in like a space like this on the bottom. Right, and so the nice thing here, right, is that looking at this load balance, I can see immediately off the bat, right, if I want to improve this building, one, I could patch the leaks, but two, if I'm going to make a recommendation to a design team, it's going to be first and foremost, like, lower the glass and invest in some better windows. And I'm going to do that before I say, you know, right, the opaque conduction term is very small here, right? There's no need for like passive house walls yet when you're losing this much heat through the windows. So in Grasshopper, right, I have a little component here, which will just change the glazing ratio, right? This imported model here. I have a slider connected up here, so I can just simply change the glazing ratio. And right, you can see by default, the base model that I imported here has a glazing ratio of 52%, way higher than even just what the prescriptive code would say. Right, so we can lower that, right, from something like, you know, from 50 down to something maybe more reasonable, maybe even like 20. Honestly, for a building of this size, you're still going to get great daylight and views, you know, with this amount of envelope, even with 20% here, right? So we can see, you know, I forgot to show actually. So we looked at right at the load balance, and we looked at a monthly chart of EUI. But I forgot to make a note of the total load intensity here, the total kind of EUI, if you will, right? Which, you know, for this building with 52% glazing, that is around 202 kilowatt hours per square meter. Not very efficient, not the best. All right, so if we go and replace this whole simulation here, actually, why don't I show you it like this, right? So we can actually see if I were to connect up my building here with 20% glazing ratio to this component, you'll see it's going to rerun the simulation and this whole load balance will shift, right? Like you've seen here. And lo and behold, right, that glazing ratio term drops substantially, right? You can see as a result, the heating drops substantially, right? And we can look at our EUI dropped from like 200 something down to 172. Right, so this is the type of analysis that I found myself doing a lot when I was back in practice, right, of just, you know, looking at these load balances to try and make recommendations to the team, the design team, about what is going to be most useful for them to spend their time on, right, and starting to make cases for things like you know, lowering the glazing ratio. Now, if any of you have worked in practice, you may start to get some pushback, right, about lowering the amount of glass, especially when people make arguments for views and things like that they wanted out of the glass. So that's why it's kind of important to come back to the world of metrics and look beyond just the metric of EUI, right? Or even load balance intensity, right? So, right, because EUI is still very limited in terms of what it can really tell you, right? I mean, not only, right, does it have this limitation of it doesn't really necessarily communicate how to make it better, right? For that, you need a load balance. But, right, even with a load balance as a guide, right, you might still not, you may know the right term to focus on, right? Like we know glazing conduction was really important, right? That also lowered, by the way, I didn't go over the fact that that lowered the solar gain and the cooling energy that we needed for this building in summer, right? So, right, even with the load balances guide, to make a really good recommendation to a team, right, about what windows should I remove to get the most bang for my buck in terms of energy use. This actually requires a different type of study, a different metric, right? And so coming back to our world of metrics here, right, I'm going to take a second and look at useful, harmful solar energy, which is something that I found was very, very helpful for communicating and giving teams like a sense of like exactly what windows should you remove in order to have the best impact on energy use intensity. Right, and the fundamental principle of this radiation benefit study is that, right, like all of us know, if we've, like if you've taken exams in architecture school or an engineering school, right, if you have two orientations to choose from for your building, right, with more northern-southern exposure or more east-west exposure, right, the north-south exposure is better, right? We know that intuitively, right? That's kind of like a fact we all agree on. But not all of our buildings are boxes like this, right? And so it becomes necessary to actually extrapolate the core principle of this this analysis into something that we can apply more broadly, right? So what we can do is we can separate helpful winter sun energy, right? Sun energy that is coming at a time when the air temperature is below a certain building balance point threshold. And then we'll take the harmful sun that is coming when the temperature is above a certain outdoor comfort threshold. We'll merge these together into a single sky that we can then use as a radiation study and show us what parts of our building are the windows actually kind of okay, right? Where we're getting at least more helpful sun than harmful sun, right, on the southern end here, and which areas are we getting more harmful than helpful sun here, right? The red in this case, the negative numbers, right? And we can use this on any geometry we want, whether it's just like accordion-shaped building or, right, or it's just very different variations of that, right? You can actually track and see how much better different building massings are depending upon, right, this radiation benefit study, right? And you can extrapolate even beyond just massing too, right? You can look at different facade strategies and total the amount of like helpful versus harmful sun over all those facades to get a sense of which ones are better. And you can see, right, these are IP units, but this is the same metric as EUI here, right? It's just looking though at, in this case, instead of energy use per square meter of floor area, this is solar energy per square meter of facade. So this is what I'm going to show you right now. I'm going to pull up a second script here that has a radiation benefit study. And you can see, right, I've already got my sky dome. It looks a little bit like what Oscar showed in the previous presentation, right? These are those infamous Tregenza patches that the sky is subdivided into. But you'll see, right, so we've colored the sky with either positive or negative kilowatt hour per square meter values, right, depending upon a balanced temperature that we've set here. This is, right now it's set to 15 Celsius, which is probably as good of a building balance point as any, right? And this is what's helping us like basically differentiate the sky, the radiation of the sky, into helpful versus harmful sun. And so now let me see, I'm going to zoom into my building here. And I'm going to actually, right, you'll see I brought the model in again here, and I'm just extrapolating the apertures, right, these windows from this model that I've received from Revit. And I can just go run a radiation study with that sky, right, with that radiation benefit sky, and with the geometry here. And you see, like, that was like less than a second it finished. And you can already get a sense now, right? Like, okay, if I'm going to recommend what windows to be removed, right? So obviously the red is like, you have more harmful summer sun energy than helpful winter sun energy. And granted, right, this is not looking at the conduction term, which we know is important too. But right, if I'm going to tell the team to really remove some windows, it's probably going to be like these ones right here are not really doing us much service, right? They're getting blasted with a lot of probably western sun in the summer, which is really not helping our cooling energy much at all. Whereas, all right, maybe some of these ones on this side, right, they're south facing, right? We're going to maybe have some passive solar heat coming from those that could offset the glazing, conduction losses. So if you want to keep some of these, maybe that, okay, right? But yeah, but definitely probably all these ones facing north are not helping us that much. And worst of all are these skylights, right? This skylight is just pretty much only getting summer sun, right, without getting much direct winter sun. So, right, so this is another type of analysis you can run to try and get a better sense of, right, like to not, get beyond just using EUI to actually get to the point of making buildings better and making recommendations to people. So now, but coming back to here, right? So we talked about EUI, we talked about like useful and harmful sun energy, but there are still major limitations to these metrics, right? Because honestly, they're both variations of the same. They have the same units, right? Kilowatt hours per square meter, right? And they both have some major limitations, right? So I mean, we already talked about these two limitations of EUI being right that you need other metrics and other studies in order to show you how to make it better. But right, even with all of that, right? You have, cases where buildings that are well used by occupants are going to have a higher EUI, but that's not a bad thing, right? Like if you just try and optimize for EUI, you're going to end up with, a building that is not as well used or not as great as it could have been. Right. There's also the fact that, right, renovated buildings have, they tend to have higher EUIs than brand new ones, right? But tearing down the old one has all those costs associated with it. There are all sorts of directions under which you can critique EUI, right? Which is why it's important to branch out into these different other areas. But the ones now that I'm going to cover, right, the other reasons for branching out into the world of metrics, right? So a lot of the times you may find, right, energy use is what we care about, right, as energy modelers and as environmental designers, but it may not be. You may have a client who is just very stubborn, and you have to find another way to argue for these energy saving strategies that doesn't rely on EUI itself. And then lastly, right, you can still have something that's a good idea that saves energy, but it doesn't reduce energy enough for you to really justify it or make a case for it. So that's why I'm going to branch out. I'm going to tell you a quick story of at least one case where I had to really branch out away from radiation benefit and EUI. Right, this was a project that my office back in the day had been working on for competition, and we did a radiation benefit study to show that if you slightly tweak the orientation of all the windows of the buildings, you would have a benefit to the energy use of the building, right? You'd be getting more helpful winter sun energy than harmful summer sun energy, right? And this was used, like we made the model based on this principle. We submitted to the competition, we won the competition, and then, right, the first thing that the design team comes back to me as the building scientist in-house was like, okay, great, we have this idea. How deep do we have to make these, like basically zigzag patterns in order to get the benefit to energy use? And I said, okay, all right, now I'll do something a little bit beyond like a radiation study. I'll just model a shoebox and change the serration depth of the shoebox and see what happens. And lo and behold, this was the impact on energy use for those different depths, right? And so it did have some impact, but it was 3% basically of the whole energy use, and was not really enough to justify right, the additional cost of all of this serration. So I found myself coming back to the world of metrics. Well, and I could understand, I probably should have run the energy balance before I did this, but right, the reason was because this building was a hospital and it was mostly driven by mechanical ventilation, right? The solar term was overall a very small part of the balance. Right, so coming back to this, I started to look at different effects that that serration depth had on other aspects of the building. In particular, I looked at peak heating and peak cooling here. Right, and so the basic principle of that, those in turn influence the size and cost of the HVAC system, although they also can constrain what types of HVAC you can do. So that ends up actually feeding back into sometimes, you can sometimes choose a more efficient type of HVAC system if you have reduced the loads on that system a lot and the size that it needs to accommodate. Right, so this was the impact on energy use, right, of that serration depth. But this was the impact on the peak cooling and peak heating that dictated the size of those heating and cooling systems, right? And you can see, whereas it was only 3% for energy use, it was like a good 20-25% on the size of the peak cooling, which then dictates the size of ducts or pipes and everything, right? So this was a major way to argue for it, at least in terms of, right, justifying the cost of this idea that saved energy, but it's not necessarily enough to really justify it. So, right, so peak heating and cooling, right, the same way that you have like an EUI bar chart and a load balance, right, you can also do the same analysis with HVAC size and the loads that drive it, right? So I'm going to show you a Grasshopper script here using the same model, right? The same exact model. And we're going to do a peak load study of this building, right? So I'm just going to run, I have a component here called peak loads, which operates very similarly in principle to the annual loads component I showed you in the previous script, right? And I can go over top here and we can look for this particular building here, right? This set of offices. We can see, right, this is the cooling demand over the course of a sunny peak cooling summer day, right? And you can see it maxes out, the peak cooling maxes around like 21 kilowatts or so of cooling is what's really needed for this space. And you can see, right, the different terms that contribute to that primarily this is being driven by the windows, right, by the solar term and by conduction through the windows after the sun beats down on them and heats them up. Right, so if we wanted to see the impact of reducing glazing ratio, here we go, I'll reduce the glazing ratio again to like 20%. And of course, right, you can see here, right, peak cooling, I said it's okay, it's around 22 kilowatts. If we now go and reduce this to 20% here, just like I did in my previous script, you will see, right, that solar load drops precipitously. The cooling drops precipitously, right? You can see, and no longer, right, solar is now more comparable to things like electric equipment, electric lighting. And right, and we shaved almost 10 kilowatts off the cooling size of this building in this case here. All right, so this becomes a very powerful way to argue for, I mean, strategies that oftentimes save energy too, right? But in this case, right, you're directly impacting the upfront cost of the building, right? So the client is sometimes much more receptive to it, right? And I mean, this also can allow you sometimes to input systems that are more, you know, more energy efficient too, right? When you have lower loads, you can start to experiment with things like radiant systems and things that, you know, kind of need lower peak loads in order to operate correctly. All right, so I'm just going to do, I know I'm running low on time here. I'm going to do one last, you know, set of metrics here, which is to talk about thermal comfort, right? So we talked about monetary cost and environmental impact, right? But so to show you a model here, right? This like second, I mean, maybe I'll show you one more script if I have a minute, but I have a comfort mapping script here, right? So this is one of the most advanced analyses that we do, or at least most complex ones that we do in Ladybug tools. Right, and you can see I've taken the building here and I've subdivided a grid here, and I've plotted spatially the percent of time that things are comfortable, basically the percent of times that you'd find things in the range of a PMV comfort polygon. Right, and you can see this building is not very comfortable. So, and I want to be clear, there are set points, there are heating cooling set points in this building, but this building is not very comfortable. And you can see the main reason for that, right? The spaces that are so uncomfortable happen to be the very glassy ones, right? And that's both because of the sun streaming in here and because of, right, well, especially these northern buildings, right? You have conduction losses through the envelope and through the glass that are causing the space to feel much cooler than usual. Right, so if I were to go, right, clearly we see the best, I mean, even the best rooms are these internal rooms that are like 65%. If I were to go take my 20% glazed building here, I'm going to rerun this whole comfort mapping script here. It's going to take maybe like a minute or two. And maybe while that's running, I'll just explain actually what's going on throughout these whole comfort map analyses. But what we basically do is we take that core honeybee model, right, that is coming in from Rhino and pollination here. We export that to an Energy Plus simulation here. This is running in the background, just so you know. Right, an Energy Plus model that gives us air temperatures, surface temperatures. We run a radiance model that gives us surface view factors. We use that to evaluate the impact of direct solar directly falling on occupants too. Right, and right, so long wave temperature, the way that this is happening is that you have, right, this is a map of the surface temperatures we get out of Energy Plus, right, done through a whole energy balance calculation of Energy Plus, right? We look at view factors, right? We use radiance to basically gauge how much of each surface is seen from a given point or a given human, right? Right, and that's done primarily with radiance, right? Shooting out a bunch of rays from each point and seeing how much of a given surface they see, and using that to basically pull together a base long wave mean radiant temperature, right? And then on top of that, we'll do a direct sun, an indirect sun study to calculate the short wave MRT, right? So we'll look at the direct. I mean, historically, you would have had to run a whole radiation study over human geometry, right, in order to evaluate how much warmer that person would feel as a result of the sun. But in this case, we use a more simplified model where we just have to evaluate the direct diffuse solar falling on the person and use some coefficients to account for the human geometry. All right, and we can bring this all together to get radiant temperature, air temperature. We're mostly using this directly from Energy Plus, but we do have some factors to account for things like air stratification. And these all get put together into a predicted mean moat model that tells us, are these conditions comfortable or not, or are they acceptable or not? And we sum this up to get the thermal comfort percent that you saw me showing in Rhino just now, right? And we can break that down, right? So thermal comfort percent is the amount of time you're inside the comfort polygon. Heat sensation is the amount of time you're too hot. Cold sensation, you're too cold. Right, so this is what we've done here. And if I go back over now that we have, let me hide this, right? So this is with our 20% glazing, right? And you remember before, right, the only spaces that were really comfortable were these, right, these interior rooms. And you can see, right, especially on this lower floor, how much more comfortable, right, this space has gotten by lowering the glazing ratio. And so in cases where, right, where you're not, like the arguments of cost and of energy savings are not really getting through to a client, comfort can also often be a very powerful way of really trying to make a case for doing this. And of course, yeah, maybe in these spaces, we still need to lower the glass a little more if you really want to see a good impact on comfort there. But right, but this, you can see the basic principle of this, right, that this is how this runs. All right, well, I think because I'm out of time here, I do have one more script I can show quickly, but I want to make sure that you guys get your questions in. But hopefully, at least in this 30 minutes or so, you guys have gotten a sense of like how Ladybug Tools helps you be flexible across this world of metrics. But of course, right, all of this is not really useful unless, right, unless you have a model, a clean model to start off with. So Mustafa is going to pick up right after me and show you basically how to use our pollination plugins to export your Revit design models into, well, into all of these formats, but in one of these in particular is our Rhino plugin, right? The model that you see that I've been using here. So, all right, let me open it up to questions while we still have time here.
Chris,
Yeah.
First of all, thank you. I think it was like a WhatsApp 3 per speed. And I don't know how you can be so clear, but also so fast and give us so much knowledge and demo. It is nice to see the developer actually using its own tool. If you don't mind, we could start already with Mustafa. So we gather the question together because we are so interlinked that
sure.
That can be a way. And we welcome Mustafa on the stage. Nice to see you.
Sure, great to see you too. Let me actually, before I start sharing my screen, let me just start talking about what happened that we start pollination a little bit. So yeah, what Chris said. So Chris showed you all the great things that you can do with Ladybug Tools, and we started talking to people a lot several years ago when we started the company to understand like what are the main bottlenecks in the workflow. So you know, like it was interesting, Oscar's presentation that he said like it runs in like fraction of a second. You buy NVIDIA new one, it will be 4 times faster. So it's like a fraction of a second. So I don't consider that a bottleneck anymore, right? Like it's just so fast, it's real time, you call it real time. So then you move back, it's just like, okay, what is the other bottlenecks that slows down? Like I can run in real time, but then you find, oh, like getting that guy to understand what this means, then doesn't matter how fast you run it, it will still take 2 days for them to figure it out. And then we had a very interesting conversation that a very brilliant engineer, one of those young ones that you could see really wanted to make a difference, was we have all these great scripts here. We never have a model to feed in. It takes us all the time to build the model. So that was like, we had that, you know, light bulb moments of, wait, we are very, like we usually talk to people who know Rhino, Grasshopper. And then we realized like there's a big part of this industry who don't know how to use Rhino, Grasshopper. Very rude, but you know, reality. So, and then that was the moment that we realized, actually, if you look to the whole thing, there is a major bottleneck that we have ignored for years. And that's how you build the initial geometry that you can run all these studies, particularly when models come from Revit. So that was a big challenge. And that's where kind of like the idea of pollination Rhino plugin and pollination Revit plugin came to be. Chris showed how pollination Rhino, a model in pollination Rhino plugin looks like. So what I'm going to do today is to show you how to get your model from Revit there in 25 minutes of time that I have. So here's the pollination website, right? The main goal is you stop redrawing energy models from scratch. And a big part of it does. I know like a lot of you might have PTSD about like Revit GPXML exporter. We have rewritten everything from scratch. So instead of this, you're going to get this. But this is still not simulation ready model. I talk about that. I just wanted to make sure everyone knows that we have a Rhino plugin and a Revit plugin. Today, I'm going to show you the Revit plugin. I imagine most of you already know Rhino, and that's the part that you're more capable to figure out on your own. One thing that I wanted also to clear is this tool is not focused on Ladybug tools and connecting to Rhino and Ladybug tools. Yes, we could have used this as our advantage and said this is the only tool that has the best integration with Revit and you have to use it. But really, like as we do it, it was a problem that we saw in the industry that everyone is struggling. And we were like, what are the main tools that you use for energy modeling mostly? And then we built a connection to that. So we don't want you, if you're an IIS user or eQuest user or IDAIS user or OpenStreetMap, we want you to get this model faster, right? You don't use Ladybug tools. We're very happy. It's okay. Like just use the tool that can get your workflow to work. Let me start here. Just make sure everyone understands this. Let's we agree. All the Revit models that you get will need cleanup. Every single of them that you get it. Just get over it. I know there was a company with capital A, did this single click thing, told you like, oh, just click, you get a clean energy model. I have worked with thousands of energy models right now. Even the models with 2 rooms, I had to do some cleanup. The reason for that is these models are for documentation. They're not for simulation. Just get over it. People do it for documentation. It looks good in documentation. They don't care. That's where it is. I'll show you the Revit sample model and you will see it looks terrible for simulation. It's good for documentation. It's the official Revit sample model, right? Then if you get through that and you understand you need to do something with this documentation models, you should also keep in mind the reason we are working with this is this documentation model has all the information that you need, or most of them that you need for building an energy model. Probably if you have built it in Rhino or if you have done it in other energy modeling tool over a 2D plan, that 2D plan most likely has come from a Revit model. You know, they exported as PDF, DXF, they gave it to you. So that's why we're still focusing to make this thing work. Just, yeah, if you agree that basically accept this reality, your life is going to get much better. If you still want single click solutions, we are not for you. Pollination is not for you. I don't know whoever can do it and hashtag AI. So here, with that, I'm actually going to show you something. I thought like I'm the last presentation here. Everyone is tired. You probably have been through like 4 or 5 cups of coffee, tea to survive. I'm going to show you something that we haven't shown publicly and it's not even available publicly. Yeah, so you can't even follow if you want to. So we have a Revit plugin that we call Revit Plugin Classic, but I'm going to show you the new upcoming Revit plugin that no one has seen, like except for internal team. I have done some videos, so you're the first ones to see it. You're welcome to give feedback, of course, but I wanted to show you like where things are going and things can get easier if you are getting models in Revit, if you're like that part of the, if you're kind of involved in that part of the process. Again, it's just like very new, so things might crash, but you know what? That's how it is. So the way it works is what we realized when we initially started, the idea was, get people to clean up things in Revit, just so they can make it thing to be ready for energy modeling. And what we realized quickly was that this idea of collaboration in the industry is a little bit, I would say, like, what should I say? So it's not collaboration, it's coordination. I'm trying to be, polite when I talk about it. It's mostly we are coordinate with each other. We want to make sure the other person is not going to screw my drawing or like, you're not going to change my design on this. We don't really collaborate per se, right? Like software development, usually people collaborate. We let you give us code and we push it in, right? So it's more of a coordination, which is a type of collaboration, which is okay. But then we realized that making changes in Revit will make so many people angry because it's the document that so many people share. And there is a concept of ownership and you can't do that. So the solution turned out to be not really bring it to Rhino, which was initially what we thought, because yes, again, as I said, it's rude, but many people don't know how to use Rhino Grasshopper. I'm sorry. So we ended up with a 2D user interface, the one that you see here, which we call it model editor. And this 2D user interface has a lot of commands to help you get this model ready for simulation without making major changes into your Revit model. So this is how it works. You click on that, it opens this, right? Then there are different steps here. You go through levels, and we get all the rooms out, and then we go check the roofs, add any roofs that are not horizontal to the model. Finally, we add the windows. I think I'm going not to go door because it's very similar to windows. And then I'll show you how to add shades. And we get this in the rest of the time that they have to something that you can really run simulation on. I mean, it doesn't have program types and constructions. It will have default. But I'll try to get it all the way to Rhino and Grasshopper. Basically, you can connect this to Chris's scripts that he had, right? So here's how it looks like. You go here. It loads all the levels that you have in Revit model. So you can see we have entry level floor and third floor. If you have MEP engineers, yes, we also support the spaces, rooms or areas. So there are 31 rooms here, right? You can say, yes, I want to export this level. You can also say the extrusion height goes all the way to level 2. You can right click here and check it in Revit to make sure all the rooms are placed that you need. So there are rooms like this that are not placed. There are rooms like this that are not placed. These are fine. We can put them in the model editor. But if you find a major room with so many windows that are missing, then you want to place it here. The other thing is you will see all this. This is the one that I was saying, like this model for documentation is fine, for simulation is not. See, like there are gaps between all these rooms. You don't see it in plan, no one talks about it. So that's the one that I was saying about, you know, like how these models are for documentation, not simulation. I'm going to open second floor and third floor here for you too. And I'm going to select them and set the height. So the second floor goes to third. This one goes all the way to roof. Hello, and let me go here. The reason I did it because again, you are responsible to check this because people forget to put rooms in, right? So they missed this whole thing in the official Revit sample model. So you should expect people forget to put rooms in other models that they have. So I just put this in because it's a large room. Redrawing this or putting it in the model editor is a pain. Otherwise, I'll leave everything else as is. I come back here and I reload the room. So you can see it was 27, it's now 28. So now it's the time for me to just bring these things that I got from Revit to the model editor. The first step is I make a quick preview here, 3D preview. Again, we keep the whole, you know, approach that we have that we want you to see the background of everything, right? We want to make sure you know what you're doing. If there are any errors in the process, and there will be errors in the process, you can see them. So here I can check, okay, all the rooms are coming. There are gaps here, I know that. This should be double height. Okay, that's fine. I can also put it in later. So if I'm fine with preview, then I can just add all of this to this model editor. There are some parameters here, for example, how do you want to subdivide the length, all those stuff. But for now, they're not that important. And blah, magic happened. So all those rooms that you had are here. And now you can see they are kind of not in Revit anymore, but they're linked to your Revit model. And I show you why that's important. So now I can hear some of you there say like, I have a Rhino inside, you know, workflow that gives me the rooms. I'm like, yeah, great. I had one of those too. The challenge is, how do you fix this? Because you bring this in, you get all the rooms, and then you're like, oh, there is a gap here. You know, these things are all over the place, right? And we have ways to fix them one by one manually. Maybe I just show you one. So for this gap, what you could do, you can create a line we call alignment line. And then you can say, okay, let's put this in the middle of the two, and then select these rooms and the alignment line and align them. So you can say whatever is between 1 foot, just align it to this line. bingo, magic happened, right? And let me change this to metric. You guys lucky in Europe. So
Thank
here,
you.
yeah, you're welcome, sorry. So now for the rest, I can do one by one, but you can imagine like if something is like happening over and over and over, we have an automated command for it. So this is called auto align. Just keep your eye on all this gaps here, right? You know, all those issues. My favorite artistic part of this model with all those beautiful separation line that they put in Revit. So you can have this command. I run it with a larger value here just to get it fixed later. But basically I say, I'm fine. Oh, 1 meter. No, sorry. I thought it was 1 feet. So I'm fine as long as, you know, within like 40 centimeters of change or 30 or 20, it depends on like what you want to, like how close you want to be to the initial model. So I'm fine within 40 centimeters of change, just fix it for me. And just go, it goes and does the fix for all of those. I don't know, did you miss it or were you able to follow? So let me do it again. So this is what it used to be with all of that. And then this algorithm basically takes it and fixes it. And I know every other company here would have said this is AI. It's not AI. It's just some of the best practices that we figured out how to do, and then we automated the whole process for it. So now what I have, it's a cleaned up version of rooms, right? So I can just join coplanar faces. Then I see there are a bunch of missing rooms there. So if there are any common typical things that you need to fix, we should have a command for them. So the command for that one is fill holes. And then I can say, put it in, but if it is a smaller than 3 square meter, merge it. If it's not, just leave a new room there. And I call them shaft, and then I run this, and you'll see that it inserted those missing rooms that I had in the model, right? So now I can do a quick level by level review, right? So I have 3 levels here. I can go check the first level, select everything, run solve adjacency, do Alt and E to make sure exterior walls are only outside, right? Then I can go to second level, do the same thing. Again, if you know us, like our approach is everything will go wrong if they can go wrong. So I just solve adjacency, Alt and E again to make sure it's exterior. And I go to the third level, select everything, solve adjacency, and Alt and E. Okay, everything looks good. So now I have a decent model that I know, like at least from what I see, there are no issues in it, except for the fact that this one needs to be double height, right? This is a single height. So I just select this here, go here, and this is 3.8, so it will be 7.6, right? And that's about it. I have the model without windows and without roofs, but the geometry is correct. It looks correct, but you know, like you can't trust yourself. That's why once the things that you see are correct, we also have a validation routine here. And similar to other things for export, we have validation for different software because different energy model software, they have different expectations of what they want it to be. So I'm going to go with Energy Plus now, which is one of the more conclusive ones that runs all the validation routines, and I run it and it tells me it's valid. So this is very, very important because one of the other texts that changes that we wanted to make was basically get industry to a place that we can have a pact with people. I thought we have it here, but apparently not. So it is that if you have a valid model, you get it to a point that's valid, and you export it from pollination to any of the ones that I showed you, we guarantee the accuracy. If it's a problem, you just let us know. We say it's a bug, we'll fix it. If you cannot fix it, we give all your money back. What it means is if you spend any time in this software and fix the stuff, because we have all those experience that we went to the office and said, oh, this is this new thing that can fix everything, and then you spend time and nothing worked, and you look like an idiot in the office, you know. So we don't want that to happen to anyone. And we also know people's time are valuable. So if you spend time, we guarantee that it will go through with no issues, right? And yes, if people are thinking we haven't given anyone any money, because there has been issues, but we have always fixed them. So that's something for you guys to know. I'm fine answering some questions in the middle if anyone has any questions, but I can also continue. Are there any questions?
Just well, it's impressive to see the development and the solving of adjacencies and creation of guarantee models. I'm obviously stunned by that. And I spent the first 2 years of my career at the Berkeley lab with Professor Vladimir Bazjanak, just trying to take a model from, back in the days was ArchiCAD, Revit, and MicroStation. We had a representative coming from like, all the world to the Berkeley lab, and we were just solving like, 1/5 of what you have. So it's really impressive. Bentley, yeah. Meanwhile, from the audience, a question are developing. I have 2 questions, one for Chris and one on Mostafa on the same direction. So Chris, we see more or less we track what you do in terms of development of ladybug tools and the other insects, as you said. And I was wondering, what are the next development, or what is the future of the insects, where the efforts will be or not, just out of curiosity?
So let me finish this, get it to the...
Oh, sorry, Mustafa, I thought you were...
No. I just I thought I get it to Rhino side, and you'll see. No, it doesn't have windows. It doesn't have roofs. What is this? No, this is not. I told you I'm going to give you like a full model. I just said like if any questions after here.
It was
I can answer.
It was a long day, Mustafa.
Yeah, I know.
Sorry, it's our pen hour.
So we accept in houses without windows.
Okay. Oh yeah, you guys are like, this is already so good. Let's go.
I'm kidding.
Yeah. Okay. Let's add roofs if there are no like questions specific up to here. How do I add roofs? I'm going to use a different approach. You can do the same thing of like going level by level, but we understand not everyone, like understand how Revit these things are. So we can use geometry. So I can say, okay, export all the roofs, but then create a Revit view for me to review it. Now I can go here and say, this is a horizontal roof. I don't need it. So I can hide it in the view, right? And this one is not really a roof. It's a shade. I can keep it and convert it to shade. So I think this is fine. I'm going to keep this on top. I'm going to keep this one too. So I come back to this UI that I have here, and I say, okay, refresh it based on the visible elements that we have. It says, do you want to change the export size? Yes, I do. And I basically, with a few clicks, it's selected the roofs that I want to come in. Similarly, I can add them to the Revit model, the model inside pollination. They are there. You don't see them because they are hidden. So I can just bring them out. Why is it important? Because now I can just say this is top exposed. It means like it has a roof. And then I can say the 3rd floor also, all the rooms are top exposed, which means try to solve them against the roof. And then you can do a visualization. And now we have the roofs here, right? So this is the roof here. That's the roof on top, the one that we have. So now someone is thinking, okay, what about this extension? This is a shade element. Can I have it? Yes, you can. So this is how you do it. Just go here, create a polyline, then select and split it. Where are you? Split here, run. Now I can select these parts of the roof and make them shades. There are now shades, and I can select this one also and make a shade. You'll notice that the geometry here is not perfect, and that's why this is not publicly available. The classic one does the perfect job of getting the geometry right. But now I had the rooms, I added the roofs, I also added this small shade extensions that we have in the model. And now you can see like the shades are here too, right? Next step, windows. So I can go here, do the same. Again, because of the time, you can do all the things that I mentioned. You can basically select them in Revit view. You can do all that, things that I did for roofs. But here, because I know which windows are the ones, we need this system panel glass. Let's export them. We need this fixed windows also. They look like this. And you can change like even how you do it. If you want to include frame and all those stuff, you can also do that if you want to get more accurate. But again, for now, I'll just go with the defaults. Again, you see the windows, how they look like. If you see any issues, you go back here and fix them. Once you feel comfortable about the windows, you just add them to the rooms. So anything within 30 centimeters, and I put like 30 or 40 degrees of angle tolerance mainly because of this skylights here, and it should override the windows that I have. So I just add these windows to my model, and the magic happens here. And now you have the windows. I mean, you can see the number here, 1324 added. And if someone is really wondering why it was 1406 and 1324, that's a separate presentation. But now you see all the windows already added to this model. Now, you might be thinking, okay, great, let's just go and export this. I'm not going to do doors. Let me do shades, just because it can be interesting. So for shades, you can do something similar. Like for this case, I'm going to add all this, shades here. So I select all the instances visible in view, and I'm going to add them as shades to here. So now I can add this to here, and you'll see all the shades are there too. And at this point, we have the model, we have fixed the rooms, we have also added all the shades and everything that we had. And you might be in a thing of like, okay, let's export it. But remember, if a problem can happen, it will happen. So before exporting things, you go run the validation again. And this is one of the very, I think, important parts of the whole pollination workflow, that we have a validation routine that you can check your model frequently, and you can always go and see, right, what might be going wrong. So for example, here, I see an error. It says invalid windows parameters. I can click on it, and you can quickly see it's happening on top of this room, right? Here. And if you want to know what, you can see an image. We have even a PDF report, and you can also see it in 3D. So what's really happening is the way they have modeled this, maybe like because this audience are 3D model friendly, I can show you in 3D. So many of these things that they have modeled, they're actually on top of each other in geometry. You see it kind of like, it's if you get close here, you see this? They're all on top of each other. So again, as I said, if there is an issue, we should have a command to automatically fix it. For this one, it's called repair invalid windows, and I can quickly make them rectangular and clean them up. I can rerun the validation here, and that is valid. I got some misadjacency because I added this windows. So there are parts of the model, they have windows that are with adjacency issues. So this is because I added the windows. After I added the windows, I didn't run solve adjacency. So just run solve adjacency again. I select this and rerun it. Success. That means I can go now and do the export as promised. So I'm going to export HPJSON, which is a format that we natively support both in Ladybug Tools and the Rhino plugin. And here's a checklist that I have validated my model. I have calculated Altini. I did at some point, it's a presentation, but you know, like you go through all this and make sure everything is okay. And then you can run this and it will give you a model that I can save here. I can call it, you know, demo model. And this is saved, which is where the magic happens. And just to be clear, I could have gone right now to IDICE, or I could have gone to ISVE or Energy Plus or Open Studio. I'm just showing this because, you know, like to connect it to what Chris presented. So what I can do here now, I can basically come here and open this model. Do you want to validate? Yes, why not? So what will happen, you'll see, and I got some validation, yes, for do that. And what you will see is basically the model that we had in Rhino. Revit is now inside Revit. It has all the names and numbers. It doesn't have program types and construction set because we haven't added that to the UI. But now that you have it here with all your Grasshopper script, you can, as simple as bringing a model here, right click, get model. And now that pollination model is a honeybee model in Ladybug Tools, right? You can do all the Ladybug tool thing to it, including, you know, I can just explode this. And now you get all the rooms, everything. You can assign program types, you can automate all those stuff. And going back to Emanuele's question, what are next are, so one is like we got the geometry pretty much covered, but then where we can do a lot with program types assignment, reading the stuff from Revit. That's, I think, what's something very interesting. For example, we have IDICE users who came to us and said, hey, in IDICE, really what we want, for name, we want the number of the room in Revit. For zone, which gets translated to group, we want the name of the room in Revit. So because this model is loosely connected to Revit, I can go here and say for name, set it based on the parameters in Revit. So I can say set it based on the number, and it shows me this room will be assigned to this, you know, all those values. So I can apply that. And for zone, I can quickly go here. So no extra script getting data, like because it's connected to Revit, you can imagine you can get program types, you know, you can get construction. So Revit can work as that document that's supposed to work as the documentation that people coordinate. So now for this one, I'm going to use the name and apply. And now you can see if I click on this, the name is 234 and the zone is corridor and all that. So if you export it to, I don't know, to IDICE, this is what you want. You can get this. On top of that, I know someone there thinking, you change the areas and we want to know the floor area change. So we have some visualization. We moved from only color by for, you know, properties to color by area change, for example. You can see which rooms have changed area and how much they have changed. And then you can also come here. We have a section for reports now. So you can create a area change report and send it to your, you know, manager, or your team review it and see if you feel comfortable with that or not. We have also started now like working on a thermal bridging quantity takeoff, because we're getting more and more people who work with, you know, passive house models, and they need it. We also see like now it's part of LEED. Apparently you get more points and all that. So it's something like that. And we are looking more and more to basically remove this part of the blockage that we have in the process, right? Simulations are getting faster now. You can build the scripts faster, all of that, but still like there was this bottleneck in the process of like, give me the model that I can start running studies on, right? So we are trying to make that time that you get a model from designer, or if you're a designer, you get that model and then you want to run a simulation, and that can take a week sometimes in these larger models and a couple of days. And that's a lot of a stress of like, oh my God, I'm making this model, making this model. So if it used to take you days, it will be less than a day. If it was hours, it should be really minutes, less than a minute. I showed you the tools. And again, as I said, the only way we got here was by fixing like thousands of real life models that people shared with us. So yeah, I hope this was helpful and just showed you the other part though that we're working on.
Sure. Thanks so much. Nice to see the end of the process. Sorry to interrupt. We have several questions from the audience. Well, the first one was addressed to Chris for what are your next stages, or is your interest where?
Yeah. I mean, because I could also like maybe just speak more broadly. Like, I mean, yeah, Mustafa showed like the specific things we're working on in the next like few months with the model editor, but I mean, more broadly speaking, just I think, I mean, our goals with Ladybug tools, even like, 10 years ago when we were still putting them together, I think it was always not just about connecting like a CAD interface to Energy Plus or to Radiance, but really trying to connect like very siloed disciplines to one another. Right. And Mustafa was getting at that in the explanation that he just said, that really a major, like, I mean, we were very naive at first to think that like everybody wanted to just, we could just all collaborate together, use the same Grasshopper script, right, or do something together. And I think we've come to an understanding, right, that the major bottleneck people had, right, in terms of collaborating was just this redrawing of models from scratch. So I think, I mean, it's really like so much of the work that we've done in the last, like, I want to say 2 to 3 years has particularly been focused on, right, on mitigating this problem of like, how can we eliminate this bottleneck of people redrawing models from scratch. So we put a lot of time and effort into like the model editor that Mustafa showed you. And we've managed, I think, to finally make headway. Whereas like Ladybug tools, I was pretty much always popular, I feel like, in architecture education context. I mean, we had some engineers and some consultants using them, but there was always like a huge fraction of like, I feel like the MEP community that we were never really quite able to engage in Grasshopper, because either because of, the challenges of learning a whole 3D CAD interface like Rhino, or the challenges, the learning curve of Grasshopper itself. So I think this model editor has finally given us like headway into like a lot of like the MEP fields. And so I think we really do want to try and connect their workflows back into, what everybody is doing on either on the Rhino Grasshopper side, or like Mustafa said, we'll be bringing, I think, some of the capabilities of Ladybug tools maybe into that report section of the model editor, right, so that we can try and bridge this gap. And I think it still remains to be seen now that like this drawing from scratch bottleneck is finally like almost eliminated. Like, what is the next bottleneck to that is going to basically prevent us from collaborating with each other? And I think we are still trying to be open-minded about what that is. It's probably not simulation speed. I think we, like, just, I mean, as Oscar said, right? Like, I mean, the chips are so fast these days. Like, GPUs keep coming cheaper and cheaper. Right, it's probably something else, like, right, like something fundamental to the workflows, like this redrawing from scratch problem that we'll be tackling, I'm sure, next.
Thank you so much, Chris.
Yeah, but yeah, should we get to the other? There are some other questions here. Is that right?
We have a few. Perhaps one is most everyone has a question for pollination. I guess both can answer, but this one, Mustafa and Chris. First of all, thanks for these tools and it's from Atit Singh. When I check the license for pollination tools, it gives a free option for Grasshopper plugin. Is the Grasshopper plugin independent of the Rhino plugin, or it is just there to assist the Rhino plugin?
Yeah, I can answer that quickly. So, I mean, you can see we've really tried to keep things separate, like between open source project and product, so that when you're acting as like a member of our open source community or you're our customer. But I mean, so the pollination Grasshopper plugin, that installer, that free installer, it's primarily a Ladybug tools installer, along with some components that will just connect, right, allow you to bring a pollination Rhino model into Grasshopper that Mustafa showed you and that you saw in my scripts. Right, so that is primarily what, like, I mean, that pollination Grasshopper installer is primarily right. It's primarily a Ladybug tools installer. The pollination Rhino plugin, that is more the product, right? So that is the whole interface that you see with all the rooms listed in a little panel here, right? That is our paid product, right? And I mean, the philosophy being, right, if we're going to basically offer it as a product as opposed to something open source and free, it's just going to be something that primarily saves you lots of time and makes your workflows easier. We will never kind of put a pay barrier in terms of simulation capability. That's our philosophy of how we decide whether we're developing something under Ladybug tools or pollination, right? So that hopefully that helps explain the key distinction between those two, right? That Rhino plugin, Revit plugin, they're primarily about building these building simulation models quickly and fastly, and the way you can edit them easily, right? Ladybug tools, while you can build energy models with them, it's primarily, right, it's open source free, simulation capabilities, right, and the ability to customize analyses the way you want.
Thanks so much, Chris. I see Mustafa is typing and answering. He's not losing the time. He's answering all the questions by typing.
Yeah, I didn't want to take time from it, and I saw Mingbo is also trying to answer most of these questions.
And we will distract you a second. What is the tool seems to be almost, it's ready. What's the next phase for it, or it's stable and that's it?
So no, we have a classic plugin that I said, which is acceptable, which is available and it works. It has all the core functionalities that I showed. It's just the UI is not great, so it's not the best feeling. So we have spent a lot of time to make the UI. The one that I showed you is like mostly a great integrated UI and user experience. But as Chris said, like he said, it's kind of a full circle. I have this thing in my mind that you want to go from point A to point B. Usually the development is like this, or some people say it's like this, which is also correct, but I think it's like this. You get very close and then you realize, we forgot something. And it puts you on a cycle of like going like a circle back. Like sometimes this circle is a year, 2 years, sometimes 3 years, So we have been on this cycle of, we thought everyone wants to run more simulations faster, #cloud simulation, right? And they don't know how to make one model. So we have been all the way back to help people to build one model really fast. And now we're getting back to, okay, you have now this clean model, you're integrated into Revit, which is like where the models that really go for paid simulation are, and that's different from the fun simulation that you don't get paid for. And what if we can bring some of those abilities to run some studies and give people reports? We have been through this thing of like going during the several years that people are like, I need things fast, so accuracy doesn't matter. Let's just like garbage in, garbage out on a steroid, particularly like when you give it to people who don't know what is garbage or what's not, and then there's a big market there, which is something that we never wanted to do and we're not doing. So maybe we can give people studies that are very close to how accurate things can be, good geometry, help to make things faster I think we can do a lot of things to make it easier to assign program types, constructions, and all this stuff. I think it's just stupid that we go beep, sorry for the word, but it's dumb. You go like room by room. Oh, it's a kitchen, so let me pick a kitchen. It's an office, there should be like this is an office, just assign an office to it, right? So those are the things that we will automate. And once we get there, then we have a model that's really simulatable. And that will be the time, okay, if it's really simulatable, as Chris said, maybe we can bring some of the scripts that Chris showed, make them more accessible to more people who are not Ladybug Tools users, and give them reports instead of just giving them a lot of numbers and data, like give them like information that they can use quickly to make decision making. So that's kind of the direction that we are going for what is next. And I should add, a lot of good things are happening on the Ladybug Tool side. You saw that Chris didn't show butterfly as one of the insects, and I think everyone was nice enough not to say why. But
someone just asked.
Someone did. Yeah, rude. So, but it's a real thing. I didn't know who asked. Oh, okay. No, sorry, yeah. I didn't mean it. I didn't know you asked for it. But the things that I'm seeing in the market, Oscar and I can't pronounce your name correctly. I don't want
It's
to.
Wojciech, sorry.
Wojciech, sorry.
Yeah.
I'm sorry. Oscar and Wojciech showed like what are the tools, like, you know, they're making advancement in that area. There are other good Grasshopper scripts that people can use. And we have built Ladybug tools in a way that is very free to work with anything that comes to the market. You know, Eddy 3D is there. There will be more CFD simulation. It doesn't mean we will not go back to Butterfly, but it means, you know, Butterfly not being there is not going to block people's workflows. People can still do what they do. And a big chunk of Ladybug tools, personally for me, was to make the knowledge accessible, like, right? So I think a lot of things we see people develop things that in the past was not possible. Now they don't have to understand radiance exactly, but they can use Honeybee to understand radiance. They can use Ladybug tools to understand, you know, like, I think Chris' contribution made a lot of the thermal comfort things, like popularized thermal comfort, right? So I said all of this to say, like, one of the reasons we focus on this side, because I think there is a lot going on the other side that are good. It doesn't mean, and we keep doing, basically try to find what are the gaps that people really need, and we cover those gaps as much as possible. That's good. I should thank everyone else who is developing all those that give us that, you know, the opportunity to focus on other parts of the bottleneck or other bottlenecks in the workflow.
Yeah, I think we really have to shout out to just everybody on our community. Yeah, who I mean, if it weren't for all the volunteers who answer people's questions on there, yeah, we would never have had time to really explore these other avenues and bottlenecks to the hood. But
yeah, very super. And just a cross question among all of you. Well, Cyclops does use some machine learning to some extent. Is that correct understanding or no? Just the GPU?
No, we have a render engine which uses a denoiser, but that's the only machine learning or AI that we're using. No, it's all.
Okay, I have a question.
It's all ray tracing and Monte Carlo, and I mean it is. I'm not gonna say it's radiance, but it's like all the daylight analysis and so on is built. It's built on the same research and the same papers.
Sure.
In practice,
Yes,
it's obviously not open source, but we try and validate. So if you use it, please validate yourself if you feel the need.
Just a question. Well, of course, we are in a time of, and this also to approach the end of the day. Of course, we're in a time where the settings are changing, AI and machine learning, and you can add are beginning to change and sculpt a bit the wall. How do you see that? You've been involved with that, or that affecting your development? Perhaps we can start from Oscar and Wojciech, and then Chris and Mostafa to close.
Yeah, I mean we have done some research ourselves and developed models for, and I've seen like on LinkedIn and in other places people that have produced, you know, predictive daylight, like especially like something like daylight factor, and they put in kind of an image with the walls, and then or maybe they have a different representation of the data, and then they use an ML model to predict the you know, the daylight factor. I think so far I don't think that we've seen a performance which maybe meets what you would require. And obviously when it's like a, you know, when it's like a physics-based analysis, then, you know, like an actual analysis will always beat a black box where you just plug in and you get kind of an approximation, right? There's always going to be approximation, whereas at least obviously the ray tracing is also an approximation in a way, but at least it's you know what's happening along the way, whereas in the black box you don't really know what's happening on the way. And it's so like at least what we're seeing is that this ML model potential is not necessarily faster than the ray tracing that we can do. But I guess like let's see what happens in the future, I think.
Sure.
But it builds a little bit on the same developments that the AI does, right? So we will, in my mind, we will see the kind of the developments of that kind of in parallel, but not necessarily relying on the
I mean, another benefit that we're seeing is obviously that the AI models are computed on GPU, right? So much money is going into making the chips faster. And I think that is another benefit that we're kind of, you know, like in theory, this rate, like moving the ray tracing to the GPU, like the GPU is fundamentally a gaming hardware, right? And then for movies and gaming, they've spent so much effort and so much money to develop this technology that does the ray tracing really fast. And we just kind of use this technology that's really from other industries in architecture to speed up our analysis. And it's the same with obviously with the machine learning then, that a lot of money is going into the research to, you know, advance this technology, and we can just kind of piggyback on that advancement to, like, you know, if you compare the industries, there's no money in environmental engineering. How much is in the broader aspect of what machine learning can do for the world, right? So we need to find these technologies and see how can we, you know, use them to make our lives faster and better. I have a question, or maybe no, Mustafa.
No, please. That's great.
First.
No, we'll go with the question. We are curious.
Okay, Mustafa and Chris, thanks for your great presentations. I think I guess one of the big pains of all these analysis engines that you can then move into after the model export is that they are not, you know, geometry models. Like anyone who has ever tried to edit geometry in IES knows that it's just not made for it. Have you thought of actually, because the UI that you now create and the whole app it looks amazing, right? Have you thought about pulling at least for the engines that have APIs, pulling the analysis also into the tool?
Oh yeah, that's on the list. Yes, 100%.
So you get like more of a, I don't know, like Climate Studios and Rhino, that you obviously need to make a few assumptions because you can't be fully flexible, but then.
So the way we see it is basically this user interface, which we call it model editor, which I showed you integrated to Rhino. It's in Revit. It's actually also integrated to Rhino, and it's a desktop application. So the way we see it is like this will be the only, and for architects it's different if you know geometry, but for people who struggle with geometry, this will be the only user interface that you need to create your geometries for energy, regardless of what software you use. And then the next step is when you run the studies, you can read the results back and push it back, particularly into Revit or Rhino, wherever the model lives, right? The architecture model lives. And yes, it will be similar how we wrote, you know, and exported to GEM for ISVE versus like whatever for IMP for EQUAS. There will be different, I don't know what we call it, we don't have a name, but if there will be different components to read the result from ISVE versus Energy Plus versus, you know, Radiance versus all those. So everything goes back basically to this model editor as the hub to send the results. That's how we see it.
Yeah, very good point. Thanks. Perhaps we can progress with, I see we have also Ata. What do you see as integration of AI or machine learning in your work? We can do the Iranian line from Ata to Mustafa and then close with Chris. Yeah.
I just wanted to, first of all, thank you, Mustafa and Chris, for this very great work. I just had a question in the chat, but I think my question was mainly about if this can be applied in urban climate, because I also literally because I literally start redrawing the geometries, so I just gave up on that. But what I think I really like Chris' approach, and this because you start with metrics, and then I think most of these workflows and most of these tools or AI or all of these methods, I think that they've been being developed are all trying to address a metric that we want to quantify. And sometimes these metrics are actually making sense, but sometimes you're interpreting them wrongly. And in my field, for example, UT said one of them that people are using it very oftenly for different work. But when I talk to the city and I'm saying this is not suitable, maybe you should look for dynamic thermal sensation or other metrics, that becomes another, I would say, layer of conversation, which is regardless of the AI tools, models. And maybe I believe maybe we need another layer of conversation, only talking about metrics, what makes sense, and then find the right tool. Could be anything in the cloud or ground to model it and provide the right actually information at the end to the user or client.
Guys, I'm trying to close the the day. No,
I know Carlo is
that
trying hard. Like here you are, the slides.
I know that
everyone is just.
We can talk for hours on this, but we took a promise, let's say, with our attendees, and thanks so much, guys. It's been absolutely a fantastic day. We had 80 to 100 people steadily connected the whole day. So, which is an amazing retention rate, believe me. So, and we know that for some of them was not possible due to the time zone. So, the recording will be available because we had registrants from Australia up to Canada. So, in the end, the whole world. So, thanks so much again. It's been absolutely a pleasure, Emanuele. If you want to really close with the final thanks. Thanks also to Christine for the amazing work you did in organizing the event.
Yeah, just some closing thought. We have seen how probably there is a pull for the tools to change physiognomy. We have seen, especially this morning, how the topic of ecology, I'm reading now between the question about psychophysiology, or other perhaps a direction for development. Well, of course, interoperability, as most of us said, and computation time are shrinking. There are different approaches to that. And I think also when we talk about all the attendants that have rotated along the day, we had from east to west along the day. I think we have ingredients to already start and revise our tool chain. The topic was about tools, but also as a leverage to engage with further with strategy in management and in metrics, as Ata said, or in achieving regenerative targets. So I think it has been quite a diverse day and very productive. And thanks very much from the attendance to. And I leave Carlo to close.
No, it's my close is really thanks. Thanks again. Have a great remainder of the day and of the week, and see you soon the next time. Bye all.
Bye.
Thank you.
Thank you.
Cheers.